All right, good morning, everybody. Gordon, good to see you.
Hi, Eric. Good to see you.
Your background looks so pleasant. Okay. Yes. Hey, G.
Hello, everyone.
Cool, this is working. I had a minor heart attack last night. There was massive audio problems trying to mirror this up to Twitch from my computer. This is good. We already have more people than registered, which is even better. Cool. Okay, we've got about 5 minutes before we get up and running, so actually, no, we have our opening right now, right? So we should be talking about that, I suppose, because Gordon's starting at 9. We are well organized. Okay, I will be right back. 1 second. So we're not going to talk about the PC hidden in the other room, mirroring the Zoom feed to Twitch. So let me go ahead and share my slides here. Share screen. Okay. And you go over here. Okay. Everybody see the slides okay, I hope. Cool. Okay, so welcome everybody to SBST. It is great to have you all here. Apologies to those of you on the left side of UTC. It's for about 5 in the morning for me, and I know some of our other participants have an early day as well, but hopefully this year everything's good for everybody in Europe and Korea and who are also joining. So thank you for being here. We are very pleased to have you. Our webpage is here, so sbst21.github.io, that has our program and all of that fun stuff. G and I are co-organizing this, and it has been a delightful experience this year, so we hope you all have a good time. We are mirroring this on Twitch, and the intention was to incorporate any students that you might want to have join in who didn't register, which is fine for us. And if you're anybody who is joining wants access to the BeamNG research platform, please drop me a message and I'm happy to send that information to you as well. We have our Twitter account, which I haven't posted from this morning because I forgot to when I woke up. We are going to be on Zoom all day today, so hopefully that is okay for you. We do have breaks interspersed throughout our day to facilitate coffee and all of that fun stuff. And if you saw the email and you haven't installed the BeamNG research platform, I would recommend doing it sooner rather than later if you want to play along with the tutorial. It's a larger download and install, and it takes a little bit of time. But if you are interested, I would definitely recommend coming to the tutorial. They actually have a game released on the Steam store, which is a lot of fun to play with. I'm very excited to see how it plays in with the research aspect as well. So, G, your turn.
Hi, hello everyone. I'm Jiin. I'm a research fellow from University College London. So it's really my great honor to chair the workshop this year together with Eric. Eric actually did most of the job, and it's my I mean, I'm really lucky to co-organize the event together with him. So, so I'd like to introduce a little bit about the format of the workshop today. So for all the participants, I would like to remind you that because we don't use the Cloudy, as Eric just mentioned, all the events we use Zoom. So if you would like to have the full information, please check all the information from your emails. And also, please remain muted until it is your turn to speak to guarantee that we have a smoothly running of the workshop. And for non-registered participants, because we have a wonderful Twitch stream, so if you have any colleagues or students that would like to attend the workshop but didn't register, feel free to share the stream link to them and encourage them to watch the live ones. And yeah, just a reminder that as we mentioned before in the email, everything on Twitch will be recorded and uploaded to YouTube. And then, yeah, next slides, please, Eric. So this is the exciting program today. We have a really wonderful keynote from Gordon Fraser, and the title, I believe you, oops. And I believe the title is really catchy, and I'm so much look forward to it. And after the keynote is the tutorial. It's simulation-based testing. It's actually what I'm currently doing for my part-time job at Facebook. So, and me myself is also very excited about it. And then that's the program in the morning. And for the lunchtime, we have a social session, which we will split the rooms. Like we expect that 3 or 4 people would communicate to each other and know more about each other in the small rooms. We may have several turns so that we have multiple opportunities to meet different groups of people. And then we have the research paper section. We have 5 research papers. And next is the tour competition papers. I think we have 8, right? Is it 8 tour competition papers? So the last exciting part is the discussion part, during which we will talk about the future of SBST, which really needs the insights from all of you. I think that's the program, so can't wait to listen to Gordon Fraser's keynote.
Thank you, Gia. Hopefully this big Zoom bar isn't blocking everybody's view here. It just kind of expanded on me. One thing I should mention too, so we're also recording the Zoom session, so it will be recorded, and anything that pops up that needs to be removed, I will edit out. But just a heads up that we'll be doing that for posterity as well. And based on whichever video recording looks better at the end of the session, I'll probably put that one up on the SBST website if anybody wants to come revisit history in the future. So, Gordon, are you ready to go?
Sure.
Cool. All right. Well, what I will do is I'll introduce you here, and then you can take over screen sharing. Sound good?
Sounds good.
Cool. So we do have Gordon Fraser here. If you are not aware, Gordon is one of the creators of the wonderful Evo Suite toolset, and most recently Penguin, and has also gotten into testing of Scratch programs, which I'm really interested. But this should be an interesting talk. So basically he's going to be, I believe, going into some of the things they don't quite tell you about SBST. So I'm guessing we're going to be getting an interesting behind the scenes view of the building of Evo Suite and maybe some of the headaches along the way. And I think I may have heard some of these as maybe complaints at conferences throughout the years. But I'm not going to read the entire set of paragraphs here. I will let Gordon go over all of this interesting stuff for you. But he is currently at University of Passau in Germany, and Again, if you haven't checked out Evo Suite at this point, I would highly recommend everybody to go ahead and do that. So without further ado, Gordon, please feel free to take over, and happy to have you.
Okay, thank you very much. Can you see my screen?
Yes.
I just need to get rid of that Zoom bar. Okay, thank you very much for the introduction. I'm glad to hear that the clickbait title worked on Jiin. I still feel I need to maybe explain the title a bit. Mainly the title is a result from poor Eric having to wait very long for me providing a title for the talk. And then at some point I just chose to give him something very unspecific that would allow me to talk about anything really. But at the time I also came across this, well, not just the usual clickbait, but also this interesting book about 23 things they don't tell you about capitalism. And I thought, well, that sounds suitable. So I'll make this 23 things maybe people don't tell you about SBST. So I've built a number of search-based software testing tools over the years. I'm going to show you some of them. And there is a bit of a gap between what the literature tells you and the problems you face when you actually try to implement a search-based testing tool. So I'm trying to cover some of them. It's probably not actually going to be 23 things because there's not enough time. I understand we have until 10 o'clock, right? So it's going to be less than 23 things, but in the spirit of clickbait, let me tell you that number 17 will blow your mind. And also you won't believe what happened next and everything. So I'll start with a plot that many of you have probably seen. This, I think Yuan Yuan produced this plot based on the Seabase repository some time ago. And the plot is not entirely up to date because it ends in 2012, but you can see this exponential growth of search-based software engineering papers over the time. So it seems that search-based software engineering is super popular, and search-based software testing within the domain of search-based software engineering is kind of the most popular thing. And in that plot, we find seminal papers like Webb Miller and David Spooner's initial paper on automatic generation of floating point test data. And then somewhere around here, where the whole thing started getting momentum, there's Mark's paper where he coined the term search-based software engineering. And then somewhere around here, 2009, there's Phil's excellent survey on search-based software test data generation. It's quite old now, but it has aged well, and it's still, I think, one of the best entry points to search-based software testing. So I still recommend reading that as an entry point if you want to get started on search-based software testing. And when I say the classical interpretation of what search-based software testing is, and from which the practice maybe deviates, the survey kind of nicely captures what I mean. So the survey talks about local search and global search and so on, and I'm going to assume the dominant thing currently used in search-based software testing is global search. So we have some sort of evolutionary algorithm, and in there's the usual iteration where we start with a population of candidate solutions, which would be test cases or test inputs or sequences of inputs in our case, with which we want to exercise a program. Then we run these test cases and try to estimate what is the fitness of our individuals. How close are we to satisfying our test objectives coverage, for example. If we're happy with the result, then we can stop at this point. If we're not happy, then the whole thing continues, and we select some of the individuals of our population for reproduction. We apply reproduction operators, mutation, crossover, whatnot. And some of these are then selected, and they replace the parent population. And then we iterate and we reevaluate the fitness of these individuals until at some point we've either run out of time or we are happy with the result and our tests satisfy our testing objectives. Okay, so this is kind of what I mean with the classical view on search-based software testing and the main aspects that are covered in the literature and that we need to be aware of when implementing search-based software testing tools. Okay, so this is what is kind of described in many of the papers shown in this plot and nicely captured also by Phil's survey. Now, two things have always bothered me about this plot. First, let me overlay another plot. Okay, and this other plot looks very similar to the first one. We have this exponential growth, and things seem to be taking off really well here. We've seen, I suppose all of us have seen plenty of exponential growth curves over the last 1.5 years or so. So we're all used to interpreting this now. Now, what this very similar other plot represents is I used this little script, put the URL here, to query Google Scholar for the number of papers written for the keywords software engineering. Okay, so the general number of papers published around software engineering also has an exponential growth. So this raises the question, are there really that many search-based software engineering papers because search-based software engineering is working so well and so great? Or is it simply because we're publishing so much? And the second thing about the plot is we have all these papers on search-based software engineering and also on search-based software testing, but how many of them are actually introducing practically usable search-based software engineering tools? I'm not going to dare and try and produce a plot for this because I'd probably miss many tools, but I dare say the number of papers that introduce practically usable search-based software testing tools is vastly lower than the number of papers published in general. Maybe one point that gives evidence for this is if you look at the tool competition over the last couple of years, run in conjunction with this workshop, the number of tools entering the competition isn't particularly large, and most of the tools that do enter aren't actually performing search in the sense of the evolutionary search cycle I presented 2 slides ago, but they're doing random search or random testing for that matter. Okay, so I'd like to identify some of the issues I've observed in building search-based software testing tools, hopefully enabling others to build their own tools, or at least being aware of what the challenges of doing so are. So I entered this plot around here when we published the initial EvoSuite paper in 2011. And I'm sure most of you have at some point seen me present something like this video. You can see from the screencast that it's not a fairly up-to-date video because it's showing Eclipse. And now the young people all want to use IntelliJ, and they forced me to use IntelliJ as well, so I've switched as well. But this is essentially what EvoSuite does. You select a Java class you want to test, and you say, I want to generate some tests. Then it applies this evolutionary testing cycle, and it produces JUnit tests as output. And these tests instantiate the class we're trying to test, and it also calls methods on them, instantiates parameters, and gives us assertions. And if we run code coverage on our generated tests, then typically the coverage is quite decent. So in my foo example, we look at the coverage in there, even the tricky branches have all been covered. Okay, so it is built on that nice classical theory of this is what you have to do for evolutionary testing, but there are many other challenges along the way to making this possible. So this was my classical view of this is evolutionary test generation. If we look at where that is in EvoSuite, this tree map represents the source code of EvoSuite. Each of these rectangles, the black rectangles, is one of the Java packages, and each rectangle in there is one class, and the size of a class, the size of a rectangle is proportional based on the lines of code of that class. And the classical evolutionary testing approach I summarized in that one slide with the search operators and whatnot, that is captured in here. Right? There's loads of source code that has got nothing to do with that, but it's all the other things you need to do in order to build a search-based software testing tool. Now, you might argue that maybe that is a result of me being a bad programmer. At this point, well, I can probably confirm that I am, but I can also confirm that this is not just because I am a bad programmer, because we've built some other search-based software testing tools. For example, Eric mentioned Penguin. Stefan is here today. He's implementing Penguin, which is essentially doing the same as EvoSuite. It generates unit tests, but it targets the Python programming language. And so you can generate some PyUnit tests. Now, I don't know why Stefan gave me a screencast showing random testing, but it also implements MOSA and whole suite test generation and MIO and all the other state-of-the-art algorithms, and produces PyTest output. But many of the challenges faced while building this tool are very similar to the challenges we faced when building EvoSuite itself. There's other tools we're working on. For example, we have an Android test generator, which also implements the standard evolutionary testing cycle. But what a test is very different here. A test case is a sequence of interactions with an Android app. And again, this causes a number of very challenging problems that you have to face while trying to get this basic evolutionary test generation cycle working. Another domain where we're applying search, and again, some of the insights this talk is trying to convey is based on, is what Eric also mentioned in the opening, that I'm trying to test Scratch programs. So Scratch, if you don't know it, it's a fun little programming language intended to educate children in programming. So it's easy to use because you don't have to type code, but you drag and drop blocks. And so these are the programming commands, and you assemble them, and they assemble like Lego bricks. You can't produce a syntactically invalid program. By definition, if the blocks fit together, this is syntactically correct. And why would we want to generate tests for that? Well, so it's probably not going to be important from the point of view of security or safety, but we need test generation in order to support learners, to provide automated feedback, to auto-grade, to give hints, and so on. And again, there is a search-based test generation tool that implements the standard cycle of evolutionary testing and so on. And what it does is it sends sequences of inputs to our program. And so this is a little game where you have to move the ball left and right and catch the fruit. And when we start with our initial random population, the ball isn't particularly good at capturing the fruit, but we'll get back to this. And finally, very briefly, I'd also like to mention that we're also doing evolutionary search in what Alessio is going to also talk about in the tutorial. So Alessio has produced this nice asphalt tool, which again implements the evolutionary test generation cycle. But what a test is again very different in that a test for asphalt is a set of road layouts, on which you then simulate executing a self-driving car and try to find faults in there. I'm not going to say much about asphalt because Alessio is going to talk plenty about this in his tutorial later on. Okay, so having built or having forced students to build various different search-based software testing tools, there are a number of things we've learned along the way, and not all of them are things that you can find in the literature. So in the remaining time, I'd like to present some of the not so obvious things about building a test generation tool. And we'll start by looking at how well EvoSuite actually works. This is something we looked at a couple of years ago. Andrea and I looked at the SF110 set of open source classes, which we extracted from SourceForge. So we looked at around 24,000 classes over 6 million lines of code. And then if you apply EvoSuite on these 24,000 classes, the distribution of coverage looks roughly like this. And it suggests that for the majority of classes, we achieve 100% coverage. So that's great. There's also a substantial number of classes where EvoSuite really struggles. So these are technical limitations, things where EvoSuite just doesn't know how to generate tests. This is not so much what I want to focus on in this talk. I've spoken about this in the past many times. I'd more like to focus on the challenges in these cases where EvoSuite is able to generate some tests, but it's struggling to generate tests. But on the whole, the plot suggests, hey, this works really well. So then we also looked at how well these tests, having achieved 100% coverage, then are at identifying faults. So we looked at the defects for J data set, which at the time had 357 real bugs. It's got many more bugs now. And if we apply the regression tests generated by EvoSuite on defects for J, oh, thanks, Alessio, for pointing out that asphalt obviously was also joint work with Mark Müller. Sorry if I forgot to mention the name. So the stats on how many of these bugs can be found by EvoSuite generated tests don't look as impressive as this 100% coverage bar in here. Right? In fact, for some of the projects like Clojure, which is Google's JavaScript interpreter, the number or the percentage of bugs found is actually pretty low. And even if it suggests that for Apache Commons Maths or JFreeChart, the proportion of bugs found is actually quite good, this is an overly optimistic plot in which we show out of so many repetitions how many bugs were found at least once. If you, on average, the number would be lower. So there are a number of reasons why there is this discrepancy between, hey, we've got 100% coverage, but hey, we can't actually find all the bugs. And there are a number of things that I have spoken about in the past, and so I'll briefly mention them, but won't go into many details on this. For example, and maybe this is one of the first things they don't tell you about search-based software testing, that we're usually talking about how to use search to reach a point in the code, but just having reached a point in the code isn't sufficient to give us a good set of tests, right? So coverage tends to be more than just reachability. We need to exercise the code in certain ways. We need to exercise it multiple times. This isn't really captured well by the general notion of reachability, which we tend to focus on in test generation. Another issue that I have spoken at length about and won't focus on today is that this talk is going to focus on input generation, but in order to find actual bugs, there's the complementary problem of generating assertions for these, right? But this is not what this talk is about. I want to question how well EvoSuite actually performs. And so last night, what I did was I looked at SF110 again, and I counted the lines of code of the classes and plotted the distribution, and the distribution of the size of the different classes in that data set looks like this. So the majority of classes actually only has somewhere between 0 and 200 lines of code. It's a very long tail distribution. This goes up to very far to the right, and I cropped the plot to make it fit on this on the slide. But many classes are actually very small. And so I randomly picked one class, and this is the first class I opened from SF110 arbitrarily, and it looks like this. And I think that kind of explains why we have this 100% coverage bar, which makes it look like EvoSuite is working so well. It's a class that consists of a single function in which, so this happens to be a project about a genetic algorithm. This is not EvoSuite source code, it's just by chance, performs selection on a population. Right? And if you want to achieve 100% coverage, all you need to do is call that function. Of course, it's not that trivial because you need to be able to produce a population first. And that population needs to be non-empty. So there are some challenges. But there's 3 lines of code. Okay, so obviously, once you succeed in covering this, scores will look great. Maybe not all classes are as simple as this. You will have more code, but if we write nice object-oriented code, then even if a class is larger, the methods it consists of should ideally be as nice and small as this. So high coverage maybe is a bit deceiving. Okay, so let's have a look at the other classes where EvoSuite does not trivially achieve 100% coverage. What happens in there? Here's a plot that NASA, my PhD student, produced as part of looking at population diversity. And he identified 4 different scenarios that you can observe when you run EvoSuite on a non-trivial class. This red plot kind of represents what we'd like to have for an evolutionary algorithm. And as the search progresses, coverage increases. This is what we'd like to have. Very often, though, what we see is this kind of behavior. EvoSuite produces an initial test, which is not very good, and then it never manages to improve it at all. Now, classes that fall in this category tend to be due to fundamental problems that EvoSuite can't cope with. Classical example, there is an exception in the static constructor of the class, and so the static constructor is covered up to the point of the exception, but it's impossible to instantiate the class. That happens quite frequently. The third category, which NASA called plateauing, is this category here. And here EvoSuite for about 2 minutes succeeds in increasing coverage, and then it hits some sort of plateau and it can't succeed anymore. Typically, what happens here is that there is some code that EvoSuite manages to cover, so just setting up the class and creating some dependencies, and then it hits some boundary where, for example, the code depends on an external dependency, contents of a file, existence of a database or a web service. And there's just nothing EvoSuite can do in order to cover this. And so there's this plateau and nothing else can happen. And the fourth class, which NASA called stagnating, so this class here, which looks similar to the plateauing, but it isn't actually plateaued. So every now and then there is a slight increase in coverage. So it seems that there isn't a fundamental limitation in what EvoSuite can do. It's just struggling to produce what it needs to. So the search here hasn't converged. It still grows, but it grows very slowly. And it seems EvoSuite doesn't quite know what to do. How can we understand what are the reasons of this? And one way we've looked at recently in order to find out what causes these issues is fitness landscape analysis. Fitness landscape analysis allows you to better understand the search problem you're facing. And let's apply this first to this example, which I've taken from Phil's search-based software testing survey. It's a simple function that takes two parameters. So our input space is two-dimensional, and the fitness landscape then is a three-dimensional plot where we have the input space, and the third dimension is for each point in our input space, the fitness value. And we assume the target statement is we want to reach this point where both of the other two if conditions, which are numeric conditions on our input parameters, have to be true. The accepted standard approach to measure the fitness towards reaching this target statement consists of two parts. There's the approach level, which we've plotted here. The approach level measures essentially how many if conditions are we away from reaching our target point. Right, so if neither of the if conditions is true, then we're at approach level 2. So we're on this plateau here. If the first if condition is true, but the second isn't, then we're on this plateau. And if both if conditions are true, then the approach level is 0 and we're on this plateau. And the second component the classical fitness function consists of is to extend the approach level with the branch distance, which is an estimate of how close each of the branching conditions is to evaluating to true. So this serves to get rid of these plateaus and instead turn them into gradients that tell us how close are we to making the next step in our approach true. And the resulting fitness landscape looks like this. Well, we have nice gradients, and you pick a random point, and then obviously the search will be able to descend into the global optimum. So this is what a nice procedural function with if conditions, as in the classical view, results. But what is the fitness landscape for EvoSuite or any other more complex test generator where we have inputs that can't easily be plotted in two-dimensional space? One way to figure out, or at least estimate, what are the properties of the fitness landscape is the following. We can apply a random walk, which means we take our input space, pick a random point, and then we go for a random walk. We randomly pick a neighbor and iteratively do this for a number of steps. And for each point along our random walk, we can get one fitness value that represents the fitness of that point in the input space. Right, if we do global search and we haven't got an explicit neighborhood, then each step in our random walk essentially represents one mutation. And we can take this sequence of fitness values and analyze that in order to draw conclusions about how our fitness landscape looks like. There are different metrics, and so the whole process of analyzing the fitness landscape is actually pretty much looking at different numbers and trying to guess what causes these effects. So if we look at our simple example from Phil's survey, and we extract different metrics based on a number of random walks, we get a result like this. Okay, so I've plotted a number of metrics here. This is the autocorrelation. This is essentially the correlation between a sequence of fitness values and the same sequence time shifted by a delta. So the higher the autocorrelation, the smoother the landscape. And it appears that this particular fitness landscape is very smooth. But a fitness landscape can also be smooth if it's flat, not just if there's a gradient. So we look at other metrics. For example, the neutrality distance tells us how far did we go in our random walk before we hit a change in the fitness value. And for our example problem, you don't have to go far in order to change the fitness value. And so the neutrality distance is very low. The neutrality volume tells us along this random walk, how many different levels of fitness did we observe? Right? And again, this is 0.5, which we can then compare with the result we get in EvoSuite. What else have we got? We have the information content, which is kind of the entropy of the fitness values. And so higher entropy essentially means you have a more rugged landscape. And so it appears that we do have a somewhat rugged landscape in this particular problem. And indeed, the only way to get a step in the random walk that has the same fitness value is if you walk horizontally. The partial information content tells us how many times the fitness gradient changed the direction. So essentially, it's going to be 0 when there are no slopes, and it's going to be 1 when it's completely rugged. So it makes sense that this is roughly 0.5 if you walk across a landscape that consists entirely of gradients. And then we have the density basin information, which is kind of the entropy of equal fitness values. So it's a high density basin information means that the number of peaks is low. So you've got a flat landscape if the density basin information is high. Okay, so NASA looked at the fitness landscape for EvoSuite, and this is what his experiments showed. So the autocorrelation still is very high, slightly lower than in our example, but it's still very high, which suggests we've got a somewhat smooth fitness landscape. But smoothness might not be a result of gradients. It might also be a result of plateaus. And we'll see that when we look at, for example, the neutrality distance. So we can, in a random walk in the EvoSuite fitness landscape, it usually takes around 20% to 25% of the steps of the random walk before we hit the first change in the fitness value. The number of different fitness values or plateaus we've observed along the walk is very low. And indeed, if you look at the evolution in EvoSuite, you'll see in most cases, if you try to cover a particular branch, you have probably 3 or 4 distinct different fitness values and nothing in between. And so the neutrality volume is very low. Information content low, partial information content very low, density basin information very high. All these things suggest that overall the fitness landscape is mainly flat. And what that means is that maybe we need to think about a different fitness function. Because we have the approach level and we have the branch distance, and that will give us some guidance within a function, but not across functions. And this problem is not just specific for EvoSuite. If we look at other search-based test generators, for example, there's the Sapiens test generator by Kimao, Mark Harmon, and Hua Jia, which is using evolutionary search to generate inputs for Android programs. And what they used as one of their objectives is coverage, right? So it's less than approach level and branch distance. It's just the level of coverage already achieved. So I think we need better fitness functions for realistic use cases. Let's have a look why. This is the type of branch we looked at in Phil's survey example with the nice gradients and so on. And if we apply EvoSuite on branches that look like this, numeric branches that compare 2 numbers. If we do this for a number of times, for a number of different classes, what we see is that in many cases, the evolutionary search is actually way better than doing a random search. And that suggests that our fitness function is giving us some input and we can guide the search. Of course, there's always a large number of lines of code that are easy to cover and so on, but by and large, if your branches provide nice gradients, then the genetic algorithm will work well. The other type of branch you might observe in standard code is what is typically called a flag problem. Right? So somewhere we define a Boolean value, and then our branch condition simply checks, is that true or false? And what sort of gradient does that give us? Well, none at all. Either that condition is true or it is not true. There's no guidance at all in between. And this is something that would explain why we see a fitness landscape, or why our fitness landscape analysis suggested that the landscape for EvoSuite is rather flat. Now, what happens if you apply evolutionary search on a branch that has no guidance. The conventional wisdom is that if you have no guidance, then your search degenerates to random search. But that's not actually true. What happens is that the random search will work better than your genetic algorithm. Right, so this is an experiment that summarizes for a number of branches comparing Boolean values. If you apply evolutionary search, then there are some where EvoSwitch still work better using search, but there are more where doing random search actually achieved higher success rate in covering these branches. Okay, this has got a number of reasons. Mainly if you apply evolutionary search without guidance and you do local mutations only, the diversity in the amount of exploration you do will be limited compared to what you can do in the same time with a random search. But, and here's another fact, the GA isn't actually better than random if it's blind. Right? In fact, in my experience, it is worse. Now you might argue, this is actually a well-known problem. It's been around for a while. Mark suggested we could apply testability transformation. You take the program, you transform it in a way that you get rid of the Boolean flag, such that the condition gives you a guidance, and branch distance gives us a nice gradient in the fitness landscape. This isn't quite so straightforward in the object-oriented case, because things will become interprocedural. Okay, so we have somewhere a Boolean function that returns a Boolean, and then at some other place, we have a branch that depends on this Boolean. And there we would like to have guidance, but we don't have any guidance. Okay, so the testability transformation actually is quite more challenging in the interprocedural case. And there's two different things we've recently tried out. So there's last year an ISTA paper on the interprocedural flag problem by Yunlin and colleagues, where what they did was try to recover the branch distance that is available here and make it available at the point where you're calculating the fitness function. And an alternative approach we tried quite recently was to replace Boolean values with what we call certainty Booleans, which are essentially integers, which capture the certainty of the truth value. Right, so the larger an integer, if the integer is positive, then it represents true, and the larger it is, the truer it is. And if it's negative, it represents false, and the more negative it is, the falser it is. So for example, we could capture whether or not it is empty by looking at the branch distance, and then our Boolean comparison becomes a comparison between integers. And what this does is it changes our flat fitness landscape, because our Boolean condition can only be true or false, to one that has a nice gradient, right? In theory. In practice, it also does that, right? So here's an example branch where without transformation, the search struggles and never quite gets anywhere, and we see no change in the fitness values because we just have one plateau. If we apply the transformation, then we have a nice gradient, which we can descend, and eventually EvoSwitch will find the target branch. But if we apply this transformation and then throw this, the improved EvoSwitch on a large number of classes, we might expect an increase in coverage, and we do see a slight increase in coverage, but it is very slight indeed. So there are some cases where there is a bit of an increase, but the median is pretty much close to zero. Right, so we have this wonderful transformation which gets rid of Boolean flags, and still we don't improve the coverage. So maybe the influence of Boolean flags in object-oriented code is not what is causing the plateaus in our fitness landscape. On the one hand, we looked at how frequent are Boolean branches, and indeed the proportion of Boolean branches in Java code isn't that high, but they still exist. So you would expect a larger influence of these Boolean flags. So something else seems to be dominating the search. What is that? So we're back to the data set with our random walk where we explore the fitness landscape. What this plot shows is on the x-axis, the success rate for each of the branches in the random walk. Okay, so the coordinates of a point on the x-axis will tell us the proportion of random walks in which a particular branch was covered by the random walk, and the y-axis will tell us how often evolutionary search succeeded at covering the branch. We've split the plot into 4 areas. So here we have cases where the random walk succeeded in covering a particular branch, but the evolutionary search did not. And this really only can be explained in terms of something's wrong in EvoSuite here. So we'll disregard this for now. Branches in this quadrant are very easy to cover, right? Just doing a random walk will cover most of these branches sooner or later, and also the search is quite successful. So these are probably cases like the source code snippet I showed you earlier. You call the function and then you've covered it, so there's no challenge here. Points in this quadrant of our plot, and the size of a dot represents the number of cases here, so that's quite a substantial number of cases here. There are cases where regardless of whether you use evolutionary search or not, EvoSuite will struggle to cover these branches. So these are cases where there are substantial problems of some sort. And this essentially is what we'd like everything to be, well, at least in the top half, but what this quadrant represents are cases where the branches are non-trivial to cover because you don't just stumble across them when doing random walk, but the search is able to cover them. Now, what determines where you can find a target branch? One of probably the largest factors that influences this is the way EvoSuite tries to cover the methods that contain these branches. Okay, so this plot shows the number of times the method in which the branch was contained was executed. And we can see that branches that are in our easy quadrant are executed quite frequently, whereas the branches in methods that EvoSuite struggles to cover are very rarely executed. Why is that the case? Another plot explains this maybe. This is the number of exceptions thrown while EvoSuite was trying to cover these branches. Right, so for the easy branches, EvoSuite rarely encounters exceptions, but for the hard branches, whenever EvoSuite tried to cover something in here, it hit some sort of exception. Okay, to understand where this comes from, why do we have so many exceptions? Let's very briefly look at how EvoSuite generates tests. So we've got 2 functions. We're trying to test the class foo, which takes a class bar as parameter, and we have a function isBar, which again depends on that internal value, and some branch that depends on the input variable. Okay, and this is our dependency class bar. So when EvoSuite tries to generate a test, what it does is it picks a method it wants to execute, for example, isBar, and then there are some dependencies in there which it needs to satisfy recursively. Right? So we need an instance of foo, and we need to decide on some integer. So EvoSuite will randomly figure out how to generate a foo, for example, by calling the method, the constructor of a class foo. And now we've satisfied this dependency, but we've added a new dependency in bar. And so this is recursively solved. We tried to instantiate a bar, for example, by calling the default constructor of bar, and then we've solved that dependency. And then we also need to find some integer, and so we randomly generate one. And here's our sequence of inputs. Right, so this is how EvoSuite generate tests. Now, slight note about this while I'm at it, before I get back to my main point. If you apply this to other programming languages, there's actually other challenges you'll face, right? So here's what Stefan has to face when he's doing the same thing in Penguin, where you have the same code here. And if Penguin decides it wants to cover bar, well, you can kind of figure out you need to instantiate foo because you Penguin selected isBar from foo. So you know at least, well, we need to somehow instantiate foo. But then there's the question, what do you put into, what parameters do you use for foo and what parameter do you use for bar? Because we have no type information, which we have in EvoSuite. Okay, so this is a challenge that you'll see in other languages and to some degree, even in EvoSuite. Okay, so just to make that point, this part here is essentially covering everything that's got to do with generics in Java. which are an absolute mess and probably the weak point in EvoSuite right now. And I'd say this is probably related to the whole problem of dynamic typing, and dynamic typing really is an issue. But I got sidetracked. This is what I actually wanted to show you. If you apply this recursive generation of objects, what you end up with is something like this. So here, EvoSuite inserted a single call to transform tree, and everything else is just things that it generated in order to satisfy dependencies. And the probability that along all these statements, you do something that violates some implicit precondition is simply very high. And so one of the central challenges for unit test generation is that unit test generators very much struggle in generating valid objects. So this only covers as far as generating a sequence, but I think there's more challenges in here once we have generated the sequence, right? So now we have a sequence of calls and they exercise our target class, and now we want to apply search operators. So assume we want to evolve a test that exercises class foo, where we need to have a parameter x which equals 42. Right? So our sequence can contain multiple calls to foo, and our multiple calls to foo use different integer parameters. This one uses this integer, and this uses this integer. Now, if we apply mutation, then some of the statements will probabilistically be altered. So for example, we might mutate our 50 to 49. Now, if you think in terms of what effects this has on the fitness value, it has 0 effects on the fitness value, because this call will produce the minimum branch distance. 48 is closer to 42. And whatever you put here, unless it's smaller than 48, it's not going to change the fitness value at all. So in principle, we have a nice branch that gives us feedback, or would be able to give us feedback, but it's hidden by our representation. And I think that's one of the reasons why the many objective approach actually works better than the whole suite approach. It's one of many factors. This whole problem is exacerbated if you have a whole set of test cases, and then you try to mutate one particular parameter and expect it to show effects in the fitness value. This will be masked by many other calls. Okay, so mutation on sequences is challenging. Crossover and mutation is also challenging, and this is my very old example. You can see how old this example is because variables are still called var 0, 1, 2, 3, which they haven't been since, I think, 2013 or so. So this is JODA-time code, where we have a datetime class, and we call toDateTime, which gives us a time of day object and get seconds of minute. And here's another test case for JODA-time. If we want to do usual crossover, what we end up with is an invalid test case. Because now here we have a call to time of day on var 0, which happens to be an integer. And here we try to get millis of second on var 0, which happens to be an integer. And here we try to call minus on var 1, which is also an integer. So things don't work, and we have to apply repair. And that, again, is not a problem that is unique to EvoSuite or object-oriented test generation. It's a problem that I think is just inherent with tests that represent sequences. So if we look at the scenario of testing an Android application, a test case is a sequence of swipes and clicks and whatnot. And the action of clicking on this particular widget might not be available in this particular screen state, right? Because you might be in a completely different state of the application, and then you cannot even apply the action. So how do you cross over sequences of UI interactions? Right? It's an open problem. And I'm starting to think that this sequence representation that we keep using for most cases in search-based test generation might not actually be the best choice. And here's some more indication for this based on NASA's experiments. So this is the plot we already saw earlier with the 4 different cases of fundamental problems, evolution working well, EvoSuite plateauing quickly, and struggling to generate objects. If you look at the entropy of fitness values, essentially the diversity in the population, in the cases where the search works well, entropy is high. In the cases where the search struggles, the entropy, the diversity in the population is low. So what NASA tried to do was to apply diversity increasing mechanisms. There's many different to choose from. The literature has dozens, things like fitness sharing and so on. I'm not going to show the specifically which configuration is which. The main point here is that this pink thing is the curve that you get if you don't apply any of the diversity increasing mechanisms, and all the other curves represent cases of applying different techniques to increase diversity. And in most cases, it is vastly worse. Right? There's only this small bit up here where it's briefly better, but only very slightly, and then the standard configuration catches up. So what happens here is that the sequence representation we use in most test generation tools has a variable length, because we don't know ahead of time how long an optimal test case should be. So we decided, well, we'll let the search figure out whether we need long or short test cases. If you force the search to increase diversity, the effect you will get is that the length will explode, right? So here's the worst configuration, and the result is that the length of the individuals grows. If the individuals grow, you will have negative effects, because now mutation will have less effect, because the effects will be covered or masked by other effects. The time it takes to execute a test will be longer, because it takes longer to apply these sequences and so on. So these variable length sequences are actually challenging. And I think we might need to consider replacing our sequence approach with something else. At the end of the day, we want to have a test case that calls one function, and there needs to be some sort of fixture, and there need to be some sort of assertions, but we don't necessarily need to have a sequence in which the same function is called multiple times. So here's an example of an alternative representation that we can use rather than sequences. This is again the fruit catching game I showed you earlier on, where Whisker kind of struggled a bit in the beginning to catch fruit. And what you have to do in the game is you control the bowl, right? So you move the bowl right to left. The bowl is initialized at some position at the bottom center. Then it waits until the game starts. And then for 30 seconds, you can control the bowl left and right. And if the 30 seconds are over, then you have won the game, right? So this code here represents you have won the game. Now, generating a sequence that will succeed in playing this game for 30 seconds is next to impossible. And the branch distance will give us a hint on catching the first fruit, but as soon as the game repeats and the next fruit falls from top to bottom, whatever changes in fitness values you achieve in your sequence will be masked by having caught the first fruit. So it's kind of impossible for the regular search to win the game with a sequence representation. So here's what one of my students, Patrick, is doing. He's extracting what scripts are there and what properties do they have. And then he throws this at a neural net that predicts which actions to send to the game in order to, for example, play it for 30 seconds or to maximize the score or survive as long as possible. Right? And this is an instance of search-based software testing, because how do you decide what the neural net should be? Well, you can use evolution. The genotype would be a sequence, but in this case, it would be a sequence of nodes and connection weights. And then the phenotype is not the actual execution, but the phenotype is the actual neural net. And then to measure the fitness, you would let the neural net play the game. And I'm not sure if this is going to be visible because it's accelerated, and I forgot to click the I'm showing videos box when sharing my screen. But after a couple of iterations, what the result of the evolutionary optimization of the network is a player that can interact with the game and catches all the fruit. Now, maybe just to explain, in that game, if you drop the apple, you lose. If you drop the banana, you just lose points. And therefore, the neural net has learned that it needs to catch the apple definitely. And sometimes it catches the bananas as well because it gives bonus points. Okay, so alternative representation, this neural net can play as long as it wants to. So the question of how long does the sequence need to be disappears. And the question of what should be the branch distance is also handled implicitly by how well the neural net performs at interacting with the game. Okay. So we've only just started playing with this. We're planning to look at other things that could be helpful in trying to get rid of the problem of our sequence representation. But there's actually more to the whole sequence issue, right? We've only spoken about the genotype. How do we generate sequences of method calls that interact in our object-oriented scenario? There's actually more to this, because at some point you need to get to the phenotype from this and calculate your actual fitness value. And if you look at EvoSuite, so somewhere in here was the algorithms we started off with. In order to simply know which methods and which classes exist, you need to create what is called the test cluster. The name test cluster originates in a paper from, I think, 2007 by Stefan Wappler. I have no clue why he called it test cluster, but this is what we call it. It's essentially, you need to do some static analysis to elicit what is the testing problem and what options do you have. Once we have this, we can implement the genotype, right? So these boxes here essentially capture the genotype as well as the genetic operations, the mutation, the crossover, and so on. But now we need to somehow execute this. Okay, so, oh, and here's our generics, which we also need. Now we need to execute it. So all this is responsible simply for being able to run a test case and produce a trace. In order for that trace to be populated by anything, you need to instrument the code. In order for that instrumentation to be meaningful, you need to reset your state after your test execution. Right? Once you have produced your trace, you need to implement your fitness function that makes something out of that execution trace. So you need to generate some control flow graphs and whatnot and implement different types of fitness functions. Right? And so you can see, if you compare the effort that went into implementing just the algorithm and the effort that goes into implementing everything else, the engineering aspect completely dominates the performance in the end. Okay. Running out of time. There's a couple of other things you need to think about, like you need to write JUnit tests in the end, collect statistics, and so on. So there's large parts of code that actually don't have anything to do with the search itself. Well, I'm going to skip that in the interest of time. I'm going to show you this wonderful plot, which is kind of the final thing. This is not a plot intended to be shown in the presentation because it conveys interesting information per se. I'm showing this plot because it results from an interaction between Sebastian and me when we were trying to find improvements of the mutation operator. And the main point here is that this purple curve here is the standard mutation operator implemented in EvoSuite. And I implemented this in 2011, and it's essentially unchanged since then. And every single other curve on that plot is an improvement of the standard mutation operator, which taken by itself completely makes sense. But if you apply it in EvoSuite, it makes things worse. Right? And this is really fascinating. And it kind of reminds me of this 90s DOS game, The Incredible Machine. Right? If you cut through one rope here, there's effects in a completely different area of the algorithm, and it's impossible to predict what will happen if you apply an improvement at any one point in the program. So it makes it really challenging to apply improvements. And again, this is not specific to EvoSuite. So maybe just as my last point, nice comparison between two Android test generation tools. Sapiens is much better than Monkey says Sapiens. Sapiens isn't all that much better than Monkey says Stoat. Stoat is much better than Sapiens says the Stoat paper. But actually, these tools are just implementing completely different things. Like Stoat is using system events that Sapiens is not using, and these are tools we can't really compare. So there's a lot of engineering that hides what effects the actual algorithmic changes will achieve. Okay, now, since I've run out of time, I'm going to skip the last point. I think I came to around 13 points rather than 23. But to summarize, based on the experience of building all these different tools, I think there are two categories of problems. First, we have many open fundamental open questions that we'll hit, so things like the fitness, the representation, and so on. But solving these is very challenging because any algorithmic improvements we might think of will be hidden behind some of the engineering details in these tools. Okay, I'll stop at this point. Only left 2 minutes. Sorry about this. Thank you very much.
Great. Thank you so much, Gordon. That was great. So at this point, I would like to open it up for questions. So just a bit of administrative things. We have 2 minutes until our actual break, depending on, I guess, how many questions and how long Gordon wants to hang around for them. I'll keep relaying them. But Dmytro, you had one in the chat. I don't know if you want to go live or if you'd like me to ask it for you.
Hello, Gordon. Yeah, thank you, Eric. I can ask it like this. Gordon, thank you for presentation. And you mentioned several times the diversity of the population. And can you explain a bit more? How do you calculate the diversity? And can you give some examples of mechanisms to improve the diversity?
Okay. Well, we explored different approaches to quantify the diversity because it's not entirely clear what exactly diversity is for tests, right? So we looked at the entropy of fitness values. We looked at the entropy in terms of the syntactic representation, the genotype, how many different methods are called, how many different values are used. We looked at the diversity in terms of the execution traces, which branches were executed. And they all kind of lead to the same result, that measuring diversity on a variable length representation is just fundamentally challenging, right? Because you can, regardless what measurement you take, if you increase length, you also increase diversity, and that's the fundamental problem here. In terms of what techniques there are to increase diversity, there's dozens. There's actually surveys on this, which can forward to you if you want to. The simple things are fitness sharing, where if you have multiple individuals that represent the same phenotype, then they have to share their fitness value. And so you reward individuals that are more unique and different to others. That would be one example, but there's literally dozens of different techniques to achieve this. But getting these diversity increasing techniques work in conjunction with a variable length representation is a major challenge.
Yes, thank you.
All right, that was the only question I think we had in the chat. So if anybody else wants to ask a question, I suppose raise your hand. Yeah, go ahead. Yeah.
Thanks, God, for that. I like your talk really much, and I guess your points are the possibly unknown points for software engineering researchers, right? Because for people from other communities, like the machine learning community, they may have like 130 things that are known about search-based software testing. So maybe I could share some of my experience in working at Facebook London. So I'm collaborating with the FAIR, like the machine learning people at Facebook, and they are working on code translation, like how to use machine learning to automatically translate code. And there are also now a bunch of people working on using AI techniques to generate code or doing code completion. And I'm sure that automatic test generation could play a great role in this part, in evaluating the generated code or automatically completed code. And I found that they never heard of Eversuite. And when I introduced the tool to them, they were amazed. Like they hope they would know that earlier. So I wonder if you have any plans to do more advertisement to other communities, especially the machine learning community. I think I'm sure they would be very interested.
Oh, thanks. Well, that kind of points towards another challenge I did not mention, which is maintaining the tools. So the issue tracker of Eversuite is constantly growing, and I don't really know how to properly cope with this because I don't have the time anymore I had when I was a postdoc and working exclusively on Eversuite. Right? And so maintaining a tool to the level that it's of relevance to other communities who are just applying it and not interested in just exploring different algorithmic questions, that's an entirely different challenge and quite a large challenge. So I'd definitely be interested in having other people use it, but then I'm not sure how I'm going to implement the features they need in EvoSuite to make that possible.
I think the current, yeah, thanks. I mean, they tried EvoSuite, they have already used it. I helped them to use it in their work, and they said it's very surprising that the tool works so well. It's from academia and it works so well. So I don't think, I mean, the current problem I see is just to let more people know the existence of EvoSuite instead of just doing more maintaining work to satisfy their requirements.
Okay, yeah. Great point, thanks. And maybe just to add, I'm always happy to take pull requests, not just issues.
You mean for somebody to have fixed the bug for you already? Oh, yes. Good point from Jose. You promised a mind-blowing point at number 17. We didn't give you enough time for that.
Well, I was lying. There was no 17th point.
It was clickbait the whole time.
Yes.
Well done.
I thought that's how it works.
It is. Yeah, well done. Okay, I've got one question, I guess a couple of questions. Administrative notes, so in about 10 minutes, I'll start the tutorial video. But I love this idea of taking automated testing to the, I guess, block level programming or intro to programming types of things, like with your Whisker, which is effectively Scratch for kids, I think, right? Any thoughts on maybe looking at some other entry-level languages like processing or P5.js or anything like that to maybe look at outreach type opportunities? Those are basically Java and JavaScript, right?
Yeah, that's well, would certainly be interesting. We chose Scratch specifically because it seems to be the most popular at the entry level. And so it's specifically targeting kids, I don't know, 10 to 14. I suppose processing comes after that. But if you say it's based on Java, that would be interesting to look at indeed.
The problem is that this past year I've gotten addicted to, there's a person on YouTube, the Coding Train, and it's a lot of fun. More fun than just doing Python stuff for me. So it's funny, but that's something that just kind of popped into my mind. Okay, any other questions? Let's see. Can you say something about the trust issue from Alessio? Maybe, I don't know if you want to ask that. And then we have one from Anabali.
Okay, yeah, I can ask that. So sometimes there's, I don't know if it's true or not, there's rumors that automatically generated tests are not that good. So people, without even trying out the tool, says, no, I'm not going to use it because this makes no sense, or it's not what I expect. So if you can say something about that, and whether you predict that telling people that an AI creates the test will convince them that there is indeed good in generating tests automatically.
Well, I think telling them an AI created it will make things worse rather than better. So I tried to focus on the technical challenges in this talk, but I think getting developers to accept these tests is a huge challenge. Some of the large chunks of the, if you think of my tree map of the source code, large chunks I did not mark explicitly are for the sole purpose of post-processing the tests to make them look human, like a human would have written them, in order to get developers to somehow accept them. But they do not trust these tests, I know that. So I think the way to go would be to find some way to support it in a way that they can find bugs. Simple example, get them to write assertions in the code, then generate some tests that simply lead to the assertions being failed, then you found a bug, and then you can trust the code, trust the generated code that is the test. If the test simply is generated for code of which the developers think it is correct, and then they are allowed to keep it as regression tests and maybe execute it in the future, that maybe is not the most convincing approach, I think. But certainly a lot of the code is specifically there simply to address that problem of trust. I don't think we've fully addressed it though.
Thank you.
Maybe just to add, this also contributes to me being a bit unhappy with the sequence representation, because what we present to the developer in the end is not the result of the search. The search produces a set of sequences, and then there's a huge effort of producing tests out of these sequences that developers might be happy with. But it's not the actual result. So if you want to try to get your evolutionary search to produce something that is more trustworthy, that is kind of in conflict to all the post-processing that happens afterwards.
All right, and then I think probably our last question, Annabelle, you've got one?
Yes, let me turn on the camera. Well, Gordon, thanks first of all for the very nice keynote, very interesting. I'm actually hoping that the recording is going to be available soon again, so I can rewatch again with my PhD student afterwards.
Thank you.
But I have actually two questions. One is more research-oriented, the other one is more technical. So research-oriented, right? I think we have most of the search algorithms based on randomized. So you write random things and we hope that some interesting patterns come out of this and hopefully they help improving something. But how much do you think there is a space for other types of AI in this process? Like try to learn patterns from other parts. So from this is unit testing, right? That's the thing you mentioned in the slides. We don't have much information like precondition, postcondition. So how much can we learn from, for example, higher level test cases, or from, I don't know, how people write test cases, and then trying to incorporate model inference or learning algorithm into this process. So how do you see this part?
So it's a very good question. There have been a number of attempts of trying to learn from existing code and then improving what the evolutionary search produces for it to become more similar to the existing code, which is challenging for the reason I just answered to Alessio, in that whatever the search produces is then undone by all the post-processing. So I think one prerequisite to make that possible would be to somehow include that in the post-processing or change the representation such that the output of the evolutionary search is what we use in the first place. I'm generally a bit, I have also published a paper, for example, with Andreas, where we learned models of object usage and then seeded that in the test generation. And I think there were some papers at last year's SBST where I think I'm trying to remember who wrote that paper, but there was at least one at SBST last year where they also tried to learn from existing code. But I wonder to what degree that works, since the interesting use case is the one where you write new code that is different. What do you learn from there? Or do you suggest to learn from other types of artifacts, such as documentation?
Well, maybe just saying, so there's indeed the domain knowledge, but also like the data structure knowledge. So for example, if you have an array list, testing an array list usually is a predefined template, right? So we know we have to add, we have to remove, we have to instantiate with certain things. And obviously existing code inside use some of those well-known data structures. So I think about the domain, I think you're super right. But can we learn something about how the data structure are used? So for the example, for the assertions, right? So if you have something that in the end is using inside an array list, to have assertions, we have to use the pattern used to attest an array list. So something on those lines. I think there are two parts, right? One is how we create the test. The other one is how we add the good assertions out of it to understand what is undergone or behind the objects. Yeah, I mean, I was just asking just this thought about it. Should we open up to combine multiple types of AI, not only on computational intelligence in this case?
I mean, anything that helps, sure. The thing about array lists or data structures is that I'm not sure how much code people write that resembles standard data structures. A lot of the code that EvoStreet struggles with is not data structure-like, but it's simply connecting a couple of things for which you need to set up other things, right? And that's not the same as an array list. And so if you have the behavior of an array list, and then you have a different class that also implements the behavior of being a container that you can iterate over and so on, then there's things you can learn from one to the other.
Yeah, but for example, right, so if my object inside contain an array list and then I get list at the end as output, then how we create assertion for the array list is important because it's how we append them at the end of the search. So I agree with, I think you're 100%, I agree with you 100% that the domain is impossible to infer, but pattern of how, no, I was talking about data structure, but more like code patterns. So for example, if you have like classic, I don't know, if you have like the classical singleton and they have to get instance to get an instance of an object, right? So if you do with EvoStreet without any learning on how this works, it's going to be impossible that we get the proper instantiation. But if you learn from how that we need to invoke the method get instance of get class or whatever, then it's how we get the object to append afterward the Dmytro sequences. So like are corner cases, but in the end, no, EvoStreet doesn't work for these corner cases. Whether to creating objects requires some tricks things around.
I'm looking forward to your paper on this, Annibale.
Right. Okay, then the last is another question I have. It's more technical. I think it's one of the challenges. You were talking about the engineering part. But there's a trend I've seen at least in EvoStreet, right? So there's plenty of paper and a lot of features inside EvoStreet, but there are some of them are like hidden gems. So how a challenge is like to keep everything up to the latest advances published also by you all the tool.
Yeah, that is a big challenge because sometimes they subsume each other. For example, we had this integration of dynamic symbolic execution in the search, which worked very well initially, but then we added dynamic seeding, and all of a sudden doing dynamic symbolic execution brought no advantages over doing the dynamic seeding. So if things are not enabled by default, then that is really challenging. And the other day I tried to remove, I think it was the differential testing functionality, because I decided it's too difficult to maintain this. It's not nice code, let's get rid of it. And I thought nobody's using it, and it didn't take more than 3 days for an email, where is that? So that is an open challenge. I don't know how to properly answer a question. I mean, the other thing is that even if we maintain these features, then because there's other changes in the engineering, people will try to replicate prior results that show that this technique worked very well, but now 27 other changes have been made, and all of a sudden the results you'll get will be very different. So I think I should add what you just said to my list of challenges. We're not at 17 yet, but 14 at least.
Unfortunately, I need to end the discussion session. So I see the Paulo also has a question, but I would ask you to please take that to chat if you can, just so that we can keep the program rolling on. But thank you again so much, Gordon. That was a wonderful keynote. Really appreciate it.
Thank you.
So great job. So next up, we have a wonderful tutorial. Let me share my screen again. So hopefully that's coming through okay. We have kind of an extension that Gordon had highlighted in his talk on asphalt. And I saw this a couple years ago in Montreal from Alessio, who is working with BeamNG. So is it .tech or .research? I'm not sure how I should be referring to it. But it's a really interesting soft body vehicle simulator, which you can program. And I am very excited for this because when I first saw it at ICSI, I wanted to know how to do it. And then I ran out of time because the real world kicked in again. But enough on me waffling on that. So this is from Alessio, Mark, and Pasquale. And they're going to be going over search-based software testing for a real-world vehicle simulator. Anything else you want to append to that, Alessio, before I start your video?
Yes, just a little disclaimer to set the expectations for the audience. So originally, I wanted to have some more interactive, hands-on tutorial, but then I realized that there's so many things to do, and there is many executions involved, that it was much more convenient to record a video. So it's going to be hard to type following my explanation in the video, but we provided a GitHub repository with all the code samples, the slides and everything. So you can also try that at home with more calm and, getting care of preparing the installation right and things like that. But other than that, I hope you enjoy it. It will be hard because it comes right after this very great keynote of Gordon. So yeah, enjoy.
Yeah, okay. One thing too I should mention, so you should all have received the link in your emails for how to access BeamNG. With the research version, I was told that you can share this with your students. There is no limit on that. And I guess I should, if anybody from BeamNG wants to contradict that, that's fine. But I asked multiple times just to make sure. But definitely recommend checking it out. So I'm going to play the video. Please let me know if there's any issues with sound or anything like that. So. Can we hear this?
I don't think we could hear the sound. Yeah.
Okay. Oh, I didn't. You know what? I know what I did. Sorry. Let me try this again. I have done Zoom before, I promise.
In this tutorial, we'll see the basics of how we can use this simulation for testing self-driving car.
Okay.
So be time when you have to run many tests.
Always crops up right in the middle of a talk,
everybody,
doesn't it?
and welcome to this tutorial titled Simulation-Based Testing with BeamNG.Tech. In this tutorial, we'll see the basics of how we can use this simulation for testing self-driving car software. My name is Alessio Gambi. I work at the University of Passau, and today I will be your speaker. But this tutorial is a joint work with me and other people, including Pascal Maul and Mark Müller from BeamNG. They will be around today for addressing technical questions on the simulator and how it can be used to achieve effective testing. So simulation-based testing with BeamNG.Tech. But what's BeamNG.Tech? BeamNG.Tech is a photorealistic, accurate, soft-body physics engine that is capable of real-time simulation of vehicle dynamics and damages on all consumer-grade hardware. To give you an idea that how it looks like a simulation in BeamNG.Tech. If you see here, the software is simulating the parts of the car, which also lets you create realistic crashes. So to give you an understanding of why we are using BeamNG.Tech as a simulator for generating tests and simulation-based tests for self-driving cars, let's look around who's using it. So, so far, there are a number of papers published in major software engineering and software testing conferences, including ESEC and ISTA, and several tools that rely on this simulator for search-based testing. To name some, we have Asphalt, Deep Janus, and AC3R. And lately, we have a new another paper called Deep Hyperion, which again uses the simulator to generate tests. In addition to that, this year at the tool competition here at the SBST workshop, several people submitted their different tools that are based on BeamNG.Tech, and maybe, who knows, after today you will use it as well. So let's move back to the tutorial, starting with the goals. So this is a beginner tutorial. So we are going to cover the basics of the framework and how they can be used to generate simulation-based tests. And we also will exemplify some examples of automated test generator. Let's start with the first part, getting started. So the resources of this tutorial are published online at this GitHub repository. So you are gonna find their setup instruction, the code examples that I'm gonna run here, copy of these slides, and links to additional resources. So you are still have the chance to walk through this video again and then run the commands that I'm running here, and and then look at examples and then work with them. To install the simulator, you don't have to do much more than downloading it, which is a big tarball, and extract it. At that point, assuming that you have space to run it, you can run it. So one note here is that officially this simulator can run only on Windows, but you can also try it on Mac using parallels. For example, the videos that you're gonna show today in this presentation are recorded using a MacBook Pro that runs BeamNG inside a virtual machine handled by parallels. So to run the simulator, there are different ways. The simplest way is to double click on the exec, and that is located under the bin folder in the BeamNG distribution. Could be a nice and initial thing to do, so you can browse existing maps or create new content. So for example, here what I'm gonna do is, this is running in my virtual machine inside my Mac. I start the simulator. The simulator it takes some time, it goes up, and then you can browse it in content. For example, you have a list of scenarios, or you can use the free roam activity to look at the levels and the maps. Another way for running a simulator, which is what we are gonna do in the remainder of this tutorial, is to use it and start it using a Python API called BeamNG Py. So BeamNG Py is an open source project that is available on GitHub, maintained by Mark and Pascal, and it can be also installed as a library from PyPy. So to run the simulation, you need one call. So you instantiate the object, you import it from the package BeamNG Py, you need the class BeamNG Py, and you define it to be running on your localhost. You provide the port, because this acts as a server to which your Python client is gonna send commands. We specify home and user, BeamNG home and BeamNG user, as you see. For simplicity, I store basically everything under C, so I know there are no spaces and what's not. And for the remainder of the program of this tutorial, we will use exactly this configuration. So once you instantiate this object, BeamNG.py, you have to call open. When you open with the parameter launch equal true, that's the moment where the library spawns a simulator and attach to it. When the job is done, you can close it by calling it BeamNG.close. So this is the basic example. So if you see here, there is a pattern. You open, you do things, and you close. That's why the BeamNG Py also comes as a Python context manager. So if you are not familiar with Python context managers, those are classes that you use by means of the with keyword in Python that ensures that when you call them, they are gonna initialize and release automatically when the flow of the control flow exit the block. And this is how we get things running. So we assume that we downloaded the simulator, we installed the dependency with Python, and then we can run it. Now, in the second part, here I introduce basically the main elements that, in my opinion, in our opinion, form a test. So the pieces that you need to run a test, and then we are gonna see in the last part how to put all together to generate tests automatically. This is our reference architecture for simulation-based testing. We have a test generator on top. This can be a human writing a test or an algorithm that generates tests automatically, that generates some tests. tests are passed to a test controller. The test controller is the component that needs to start, set up, and tear down tests. So you can think of test controller like frameworks like PyTest or UniTest, and we are going to use mostly UniTest here, but a test controller can be any form of a Python script that can interact through the BeamNG API with the underlying simulator. So this controller is the one that does the job. In this case, we assume that BeamNG.Tech, the simulator, is a black box. So we don't see it, and we refer to it by means of the API that exposes its functionality. So the API hides the underlying simulator. The other two components that are relevant in this architecture are the runtime monitors. So the runtime monitor is this component that observes, collects data from the running simulation, and is the one in charge of basically checking oracles. If something happens, then this component will notify the test controller about a passing or a failing of a test, and that the test controller will stop the test and move on. On the other side, there's a driving agent. Driving agents are basically the test subjects. So they are started or connected through the test controller, and they observe and control the simulation. What does it mean? That they have a way to read the data at runtime from the running simulation, compute the control command that drives the car, and send them back to the simulator to have those cars basically driving around. And those are the components that we are going to see in a moment. So this is the agenda for this part, is the anatomy of a simulation-based test. There might be different ways of doing that, so don't take this for granted. So we start with a precondition to have a running simulator, then we see how to set up the environment and the initial condition of the test, mainly how to place obstacle, how to configure and set up the oracles and the test subject. And finally, we are going to look at how we can add some dynamism to our test. Let's start with the precondition. So when it comes to running the simulation, we assume that the simulator is running. Now, there are two main possibilities. Either we restart the simulator, a fresh instance of the simulator for each test, or we try to reuse it. Starting the fresh instance in general prevents or reduces the effects of pollution between states, and in a sense also reduce the flakiness of tests, but it takes more time to execute tests because every time you have to restart the simulation and wait that the simulation load and such. Reusing the simulator instead allows you to save some time, which may be a selling factor when you have to run many tests. In general, in this tutorial, we're gonna see how we use one instance at the simulator at a time, but nothing prevents you, provided that your hardware is capable enough to run multiple concurrent instances, so you can even parallelize the simulations. But we are not gonna see it here today. So to start a fresh instance, this is a unit test class. What you have to do is that in each test you can open and close a new simulation. Okay, here I'm using the Python context manager. So I defined two unit tests, and in the first I open the simulation. This is gonna start the simulator and close it, and then I repeat the second time and then repeat the same for each test. Instead, having a shared instance, so reusing the simulator across tests, you need a slightly different method. So what you can do is to have a class method that are executed only once for each test, but not for each test method, where you set up the simulator and start it. Now we can call this like the main client of the API. Is the client that invokes the open command with launch equal true. So this will cause the simulator to start and to be stopped after all the unit tests are executed. Now in our test, we are gonna still need to use and access this instance of the simulator. What we can do is to again instantiate this BeamNG class, but instead of calling open launch equal true, we call open launch equal false and deploy false. And why we do so? Because in doing so, the library knows that it needs to connect to a server listening in localhost port 64256 without the need to spawning another process. So this is basically connecting to a running simulation. Now at this point, in order to disconnect, we need to close the socket connection, but not the simulator itself. If we call client.close, client A or client B.close, now we will gonna kill the entire simulator, failing to basically share it across tests. But it's still, what I want you to know is that it's possible. And we are gonna see how we are gonna use this exact setup when we need to, in our example of automated test generators. So assuming that a simulation is running, now we have to set up our tests. So one way of doing it is to start from the environment. So BeamNG.tech execute tests as driving scenarios. Driving scenarios takes place in the context of levels. Levels are kind of logical containers or deployment unit, if you want, that contains a terrain, a map, all the props, arts, models, materials, all the data that you may use in the simulator. Scenarios can and we will be defined programmatically. Okay, so we can take existing maps, and there are 19 at the moment, very well defined. There are more can be downloaded, and you can also create your own manually. And then on top of those maps, on top of those levels with maps and all elements that can be used inside the simulation, we are going to create tests. So to give you an overview on how they look like, this is basically the levels that you can have. So the existing levels are very well defined, are manually crafted, and then they are rich in the details. Each of these levels comes with a name. And then what you have to do is, after you start BeamNG, you create a scenario. So there is a class scenario in which you give the name of the level that you want to use and the name of the scenario that you want to use. If the scenario is an existing one, it will be loaded. Otherwise, it will be created for you. At that point, you can make the scenario, meaning that the API is gonna create all the necessary files on your system to program the simulator. You load it, and then you start it. One central point is the ability to procedurally generate content. And this is a unique feature of BeamNG.tech, which makes it really powerful, but one of the best choice when it comes to search-based software testing, because it gives the tester the full control of all the elements of the simulations that can be programmed directly in, for example, Python. In this case, we focus on roads. So roads are defined as a sequence of nodes, and nodes are points in three-dimensional space on extended with a width of the road. So a road is a sequence of points. At each point in space, you tell the system how wide is the road, and the system is going to create a road for you. There are other attributes that you can set, including the ID, the material, the lane configuration, and the direction of the road. For example, here in this code snippet, I create a straight road, and I give it a name to a new scenario, test scenario. I define a new road that it's made of this road rubber sticky. We will see later what's this. This is the name of a material that exists in the simulator. I extend the nodes with the road, and I make the scenario. So the scenario is gonna look like more or less like this. So this code is available on GitHub under load scenario and roads.py, and the code that visualizes road is under the module visualization.py. So as you can see here, the road is made of 4 nodes. Each node defines the same width, and because the nodes form a straight line, we are going to obtain a straight segment in the simulator. So one last point is about lane markings. So we generate roads in terms of their geometry but and then we attach to them, we define what material makes them. So materials does not necessarily comes with lane marking. So we know that for testing that computer vision or vision-based driving agents rely on the features of the road. You know, the red, the yellow central line, or the solid white line on the side, or what's not. We need to generate lane markings at themselves in the simulator. Otherwise, if the texture that is associated to the material we use to generate the road does not contain those features, they will just be plain. So one way of doing that, and this is what tools like Asphalt and AC3R do, is to imagine roads as made of layers. The base layer is the concrete. So we can use a material like this road rubber sticky, which is basically asphalt, a concrete layer with no lane marking. What we can do then is to draw on top of this the lines themselves. And how we do that, we reuse this logic of creating roads, but we change the material. The alternative, which is adopted by tools like Deep Janus, Deep Hyperion, and the tool competition pipeline for this year SBST tool competition, is that we can create a texture that indeed embeds the lane marking, and then let the simulator adapt it or to the road geometry. And once you have done this, the generation of the road is exactly the same, like the basic one, but it will render slightly different. Okay, for example, this is how it will render. Now, this is how you can set up the environment, the environment, the roads, and lane markings. Let's move on and see how we can set the initial conditions of our test. This is mainly about placing vehicles and objects or obstacles. So BeamNG.Tech allows multiple vehicles and objects to be placed at arbitrary location and rotated in any direction. And those vehicles have a model. Okay, models are listed under the vehicles folder in the distribution. You can see Autobello, you can see, I don't know, Caravan, and many other things. ATK 800, which is the default one that we use. The counterpart are obstacles or objects that are static. Things like buildings, concrete barriers, and they can be either modeled in outside programs and imported into the simulator, therefore used also in your test, or they can be procedurally generated. So to place vehicles, you need to instantiate the vehicle class, provide a name that is unique in your simulation, and a model. So the model like ATK hundreds, Autobello, or City Bus, in this case, is exactly the model that you see in these folders under the vehicle folder, and added to the scenario with the add vehicle call. So, and this basically will import in the scenario whatever model you want. This is for placing vehicles. For placing objects, we follow a very similar approach. So the objects, they have collision maps. So if a car crashes into them, as we will see in a moment, they actually damage the car, but the object itself, it's simpler. Okay, so you can place it wherever you want, and they will stay there. The choice that you have as tester when it comes to placing objects is either generating them from scratch procedurally. That's one possibility. The other possibility, which comes handy when you want to work with complex objects, I don't know, a concrete barrier with a specific visual pattern, you know, red and white stripes or something like that, right? Those objects can be imported. What you need is one of these DAE file. This DAE file, I'm not going into detail, is basically a 3D modeling file. What you do and what I've done, for example, in this case, is to browse the different levels that exist already in the system, and they come with tons of those models. Choose the one that I liked. So, for example, this concrete road barrier, and then tell my simulation, look, this is what you have to take. Create a static object, use this shapefile, and import it. So that's how I can set up the initial condition. Okay, I place the static objects and the vehicles. Now it's a moment for moving away from the conditions and looking at the oracles. So when it comes to testing continuous controllers, which is different from regular unit testing and testing of regular application, we need to think in terms of positive and negative oracles. So positive oracles are the ones that establish when the test pass. Negative oracles, that are the standard one, decide when it fails. And why it matters? Because the test subject is a continuous controller. We cannot wait the end of the test to decide that the test passed. So this is the usual X unit pattern. If the test complete without triggering any assertion, then the test pass. But here there is no end because it's a continuous controller. So we need to make sure that we can identify also when the test pass. Classical example of positive oracles are target areas. So the car must drive from the initial position to some target area, and if it reaches the target area, the test passes. Conversely, examples of negative oracles are timeouts. Okay, the car did not succeed within some time. The fact that there are crashes and damages to the car, lack of movement, and even unsafe or forbidden areas. Oracles works on data. Okay, they can be defined on object states, position or rotation. The car should stay in its own lane. Absolute values like simulation time, physical quantities, maximum speed or acceleration, and even other sensors. These data that are required to evaluate the oracles can be obtained by modeling the simulation using the sensor abstraction. So BeamNG Tech provides you this abstraction of sensors of different types, state, timer, cameras, electric sensor, LiDAR, sonar, ultrasonic, just name one, that you attach to the car. And when the sensor is attached to the car, then it can be read. And this is what these runtime monitors indeed use. For example, here I have the simplest example, the sensor state. Okay, so sensors are defined under the module BeamNG.Pi.Sensor, and we import state. Okay, so we have a state sensor, we attach it to the ego vehicle, and then once you start the simulation, after we load the scenario, we can poll the sensors. We poll the sensor, we get the data, and then after that we can read it. Once we have a sensor, then we can define an oracle. For example, we can define a target area oracle, something that it's based on position. In this case, what I've implemented is a simple oracle in which we provide a location and a radius and a state sensor. And this oracle will check whether or not the position of the car is within or not this area. When it comes also to collect data, we may need to collect a large amount of data that then it must be processed on the critical path. Okay, imagine that you have everything running inside the main loop, then you get images, point cloud from LiDAR and what's not that you have to analyze. And this may take time and introduce, performance overhead, then impact the quality of the simulation because, the simulation is running, you are overloading your machine, and then you may introduce some sort of lags between, the observation when you collect them and the reaction or the monitoring of your oracles. To reduce this impact, BeamNG.Tech comes with this idea of having synchronous simulations, and then synchronous simulations are basically simulations that execute in steps. You define the steps, which are the granularity of your simulation. For example, 60 steps for each second, corresponding roughly to 60 frames per second. You can have more or less, and then you can tell the simulator, now you progress the simulation for this amount of steps, and then you stop. And once the output of your monitoring of control is ready, then you can resume the simulation for another loop. So to have synchronous simulations, you have to set the steps per second, define the simulation as being deterministic, and then you pause it. And then what you can do, what we usually do is in a main loop, we make the simulation progress, calling the bmng.step, providing a number of steps. If we provide 30 steps, after we define that in each second we have 60 steps, this will correspond of progressing a simulation for half a second. This let you control the frequency of monitoring and frequency of control. And then once you have done this, you can do your work and then resume the simulation. So now we know how to, read data using sensor and define oracles. What about test subjects? So we need to connect to the ego car, instruct about the test goal and what's not. So the ego car is our test subject. Actually, the logic that controls the ego car is our test subject. And this can take several forms. So the logic that controls the car can be directly running inside the simulator or outside it. When you run something outside the simulator, this can be an agent that it runs in the main process. So beside or along with the test case, for example, this is the approach adopted by Janus, Hyperion, the tool competition pipeline, or in a different process. So you can spawn another process or let another process connect to your running simulation and then let it download the data and drive the car. To define the test goal, we need to consider the fact that the problem that we want to solve and the test that we want to solve, either this be, keeping the lane, avoid obstacle, avoid pedestrians, recognize traffic signs. This is problem and application specific. So we need to find our own way to instruct our agent about what to do. And this can be done explicitly if you know how to do it, or sometimes it can be done also, let's say, implicitly. Other systems like Janus, what they do is that they create tests for which the driving tasks naturally follow the setup. What I mean is, if you want to have a car that follow the lane, keep the lane, you can create one single road, place the car at the beginning of the road and let it drive until the end of the road. So there is no need for trajectory planning, for telling the car where it has to go. It just follows the road. So let's see how we can use or exemplify these three different ways of including test subjects. The first one is to use the BeamNG driving AI. So BeamNG comes with a smart AI that can drive car. The API, the BeamNG pipe, exposes some methods to configure this driving agent. So here, what you can do is you take a vehicle, so you create a vehicle, you add it to your to your scenario, and then you say you can set up the mode of this AI. For example, manual assumes that you manually provide the destination or a list of checkpoints that the car should follow. Once you've done this, then the car will automatically drive. It's not that it's disabled. So in this snippet here, what I've done is I generated a road. I define a destination point as being the basically last point on the road, and then I added to the scenario a checkpoint. So a checkpoint is a specific point that has an ID that then can be used to instruct the BeamNG driving agent. Another way is a code, for example, an actual driving agent that will receive, for example, camera images and other data, and then will compute the control commands. And this is what Janus and Hyperion tools, for example, do. The upside is that it's simple. You can basically, in the loop where you pull the data and then you pose the simulation, you can forward the data to the driving agent that computes the control. But it also requires installing all the driving agent dependencies within the other components. And this may or may not be feasible in solution. But assuming that it's possible, that's how it looks like. You can you use a camera sensor, and the camera sensor in BeamNG provides you 4 different types of camera. The color one, which is what we are going to use, but you can also have pixel perfect annotation, depth cameras, and instance value that tells you exactly what's inside the image to help you testing different levels of smartness of your AI. So let's see how, for example, DeepJanus does it. So what it does, and the code that show here, it's a simplified version of what's on the website at this address, is it defines an NVIDIA predictor, which is a class that loads a Keras model that was pre-trained on images collected from BeamNG.tech that predict a steering angle from an image. This is the classical setup of a end-to-end steering predictor. Okay, it gets an image from the simulator, it predicts a value of an angle. But because we need to drive the car, we need also to compute its speed. This component, given the steering angle and a limit on minimum and maximum speed, it computes also the throttle command. Once you have this model, once you have this component available, assuming that you already have a pre-trained model as I do, you can put it into the actual execution. And in the actual execution, what you're going to do is create your scenarios, defining the road and the initial placement of the car as we have done it before. You load your models that specify the weights of your network, and then inside a big while loop, you pull the data, you get the data, for example, data from the camera, and then you ask this model to make the prediction. And once you have this prediction, you can apply the control command. Once you have applied this, you can resume the execution of the simulation. We are still running into the synchronous mode. Then the control will be applied for the next control cycle, and then you come back after you collect new data, and then you repeat. The test creates a road. It's not a straight road, it's a curvy road. Then it starts TensorFlow, and then it shows you the camera images that are collected from this camera sensor. So the camera sensor collect the image, pass the image to the deep neural network that create the controls, send back to the network to the car, and then repeats the loop. The last possibility is to run everything into a separate process, and this is what, for example, the Asphalt tool does. And then the child process or the sub process, what it can do is it can query the scenario, the current scenario that is loaded in the simulator, and query the map and its position using sensors. And based on this and some other parameters, it can also plan the control. So that's how I can configure the test subject. The last piece for this part is adding some spice, adding some additional dynamism. Okay, for example, random traffic and controlling non-playing character cars. So here I'm not gonna show the traffic API. You can read about that on the website because I consider that to be an advanced feature, so will not necessarily fit this basic tutorial. So the way to control this NPC vehicle is either by using a checkpoint or by generating a trajectory, one of those scripts. So for the checkpoint is exactly what we have decided before. You tell the car, drive to this location with this maximum speed, and the car will drive itself. Okay, so you can use this to create, and make the other cars move on themselves. The other possibility, or a second possibility, is to generate this script where that creates a trajectory implicitly by specifying a sequence of nodes that must be reached in time. So here, for example, I exemplify this, saying that at time 0, when the simulation starts, the car must be in the initial position in this leftmost node. Then after 1 second, it must reach this other node. After 2.5 seconds, the next node, and so forth. And because the nodes are displaced, the car will, turn left and right. So this is how it looks like. So you have a trajectory that it's made of nodes. Nodes are basically dictionaries that contains X, Y, and Z that tells you, where the car must be, and a T. T is the time since the beginning of the simulation in logical time, not in real time. And in this case, what I've done was to define an internode distance of 20 meters and then have a loop that basically place one point, one of these nodes every 20 meters on a straight line, and tell that the car must reach the nodes in 2.5 seconds. Then what we need is to create a vehicle, add the vehicle to the scenario, and then set up the vehicle AI with the set script. And this is how we can, those are all the pieces that we need to create tests. Tests can be created manually, of course, but then we can also use these pieces to create tests automatically. In this tutorial, I'm looking at the two main forms of test generations that I'm aware of when it comes to simulation-based testing, which are parameter exploration. We define one abstract scenario, and then we instantiate this by giving value to parameters and generate many concrete scenarios. The other form of automated test generation in this context is the one that rely on procedural content generation, where we can generate many abstract scenarios and either one or more concrete instantiation of those scenarios. So the first case, which you can find implemented into this automation example 1.py, is following a drunk driver. So the idea is that we start configuring the hidden car that the ego car should follow to follow a straight trajectory on a straight road, driving at constant speed. And then we start mutating this trajectory by changing the lateral displacement of these nodes that form a trajectory and the time between the nodes to create some sort of wiggling or let's say weird driving behavior, as you may expect from a drunk driver. So we can increase the speed, decrease the speed, keep the speed at the same time, and turn left and right. So let's see how it works. So this file is already available on GitHub under automation example 1.py. So because I'm expecting to run many tests, I'm gonna create one shared BeamNG simulation into the main file before invoking the main method. And then inside the main method, what we are gonna do is we create an initial individual. In this case, I'm not gonna create a random individual. I always create this straight line made of nodes that are equidistant, meaning that the car will travel more or less at a constant speed. Then I define a generic execute experiment that takes one of these individual, meaning this trajectory, create some debugging information to visualize them by creating some spheres. And then what I do, I place the ego vehicle at the beginning of the road. I place the heading vehicle 20 meters in front of it, and then I define a destination point. And then I define the heading vehicle to follow this trajectory that we are creating, and the ego vehicle behind it to reach the goal waypoint at a given speed. In this case, the fitness function is going to be the distance between the two cars that must be minimized. To mutate the system, the trajectory, I have immutator operators that either move the point on the side or change the interarrival time, so we can control the speed of the aiding vehicle. So how does it look like for real? So we can run the script automation example 1. I'm not going to use unit test or PyTest. Everything now it's in a basic script. We are going to see that, and then once again, this simulation is sped up to avoid spending too much time looking at and loading screens. We generate the first individual, and then you see that the yellow car, which is in front of us, is simply going straight until it reaches the end, and then we start mutating it. Those are minor differences, but then sometimes we have better mutations for which not only we change the car that is now driving left and right, but we also drastically reduce its speed. So it passed from 28 km/h to 16 at some point, and then you see that the ego car is getting closer and closer to it, and then this improved the fitness, and then at this point, boom, the car crashed into it. So we've managed to find a way to crash this car by modifying the trajectory of the aiding vehicle. So if you want to find more, you find and discuss about this, you can follow us. You can check out these resources. We have the SBST workshop documentation from BeamNG, the tutorial, this tutorial here in bold, the pipeline competition, and many other tools out of there. So with this, I thank you once again. So my name is Alessio Gambi, and with Pascal Maul and Mark Mueller, today we have presented to you this tutorial on simulation-based testing with BeamNG.tech.
Okay. Thank you very much, Alessio. That was great.
Thank you. I hope it was not too mild. Yes,
No, I can't.
Usually I tend to be more energetic.
Okay, there we go. So does anybody have any questions? I've got a few, but I'm sure other people would have some as well. All right, Stefan, go ahead.
Hi, thank you for the great tutorial. This is very interesting to see beyond the SBST competition what this is capable of. I have a question because I haven't found a clear answer on this. What platforms can and can I not run this on? Because we are running currently with a driving simulator on Linux, and it would be interesting to compare these two directly on the same system without having to reboot into another operating system.
Okay, so since Mark and Pascal from BeamNG are here, I may also ask them if they want to address the questions. Otherwise, I'll go for it. Okay,
Hi.
Mark. Hi, Pascal. Hi, Mark. Because those are more technical questions, and they are the right people to answer.
Yeah, so for now it's Windows only, but we are not that far away from releasing our Linux support.
Okay, thank you.
Okay,
but I can't give you like a date, but it's not too far away.
Sure, thanks.
This year, definitely, we can give that as an estimate. The early version should be out this year, definitely, quite soon actually, but it's probably going to explode first because it's going to be the first version of BeamNG on Linux, and then we'll see how it goes from there. But yeah, we're working on having it running natively on Linux.
Okay, thank you.
In the meanwhile, you can also try different, more hacky solutions. So the solution that I use for development, not for, of course, experimentation, is to use a virtual machine and parallels. So far on the Mac, I mean, a plain MacBook is enough to play around. There are people online trying to have cross compilation, so you can try to use this system to run a native Windows application on Linux. Or virtual machines, provided that you can configure, I guess, the pass-through from the virtual machine to the GPU. So there might be other hacky way to make it work until the official release is going to be out.
Thanks.
That's good. Other questions? Dmytro, go ahead.
Hi, Alessio. Thank you for presentation. It's actually very interesting to see how it can go beyond the competition pipeline on real examples. But I also have a technical question. Is it possible to run several simulations at the same time, for example, in different windows? Like run, for example, launch several evaluation pipelines at the same time, and run experiments in parallel. How, for example?
That is possible. There is one tiny restriction, that the user path, where basically you have the main installation folder of BeamNG and a so-called user path where any cache data and other like configuration settings are stored. You need to, if you run multiple BeamNGs at once, you need to give them distinct user paths. That's mainly because some temporary files like compiled shaders and whatnot are all specific to that execution. So if you use distinct user paths, there should be no problem. And I know that for a fact because when we were running Asphalt, we were running 4 executions on one machine.
Okay.
So that definitely worked. Again, you need to make sure they're in distinct user paths so the temporary files don't get entangled, but otherwise it should work. And has worked in my experience.
Okay, great, thank you.
Yeah, there is another addition that since you are running, since the BeamNG will listen to a port, you have to make sure that you use different ports for each of the different processes. Otherwise, it will fail, saying that it can't bind the port because it's occupied.
Okay, yeah, I see. It's a good point.
Yeah,
because
in our experience with other people like Vincenzo Riccio from USI, the limiting factor in parallelizing the experiments is not the simulator, but is the test subject. So the moment that you need test subject that heavily rely on GPU, then the simulator can run in parallel, but in many cases, you cannot instantiate many instances of the test subject on your machine. So that's also a tricky part, so to consider.
Yeah, thank you. So that's why you run only 4, but not 10. Thank you.
I guess I have a follow-up question directly related to that. Is it possible to run BeamNG headless to conserve resources?
Not yet. It's something I desperately want as well, specifically for automated testing of stuff that doesn't really require graphics. But since it still originated as a game, the UI is sort of too entangled in all of the code. That is something, again, we're working on. It was actually part of the restructuring for that was part of the Linux port as well. So it's coming along somewhat, and a lot of the functionality is available already, but for now it would just crash and burn. But yeah, it's something we want, in particular, because for some things, you don't need any UI output or graphics whatsoever. So once you have that, you can run the game in some Docker container or whatnot, but not yet. We're working on it, but that's on the agenda.
Fair enough, that I would ask. Thank you. Okay, anybody have any other questions? Okay. I guess one other question that I have for you then is this. So I really like the simulator. It's a lot of fun to play with. I've even played with the game version as well. It's really fun to drive a car off of a ramp and try to hit a giant target on the side of a cliff. That's the spoiler for what the game does. I'm curious, how relatable is the simulation to the real world? So could somebody, for instance, train a lane keeping neural network or something like that and then deploy it into a robot and have it function fairly well? I guess, has there been any kind of experience with that? Might be a different question, but yeah.
Sorry. I kind of missed the question. Sorry.
No, it was more so, can we use the simulation environment as a training scenario for some kind of a like a neural network or artificial intelligence, and then translate it into the real world?
Okay, so this is a good question, but it's also a tricky question.
Yes,
so because
that's why I
it's
asked
related on this so-called simulation gap. So if I train my AI entirely in the simulation and then I put it into the real life, will it work as I expect? So there is this concept of having digital twins. Definitely in my limited, say, experience, BeamNG comes with a more accurate simulation of some aspects of physics like inertia or load distribution and damages also that other simulators don't have natively. So you can build up co-simulator, of course, simulations. So this may reduce the gap, but I would not put my hands on fire. I mean, I tell to make it work.
I'm not sure about BeamNG specific research like that, but I know that for some other game-based simulators that has been done, not in the sense of having a fully autonomous vehicle, but you might remember, Alessio, we cited a paper in our fall that used GTA 5 as a base for image recognition training. I think that research actually got shot down by Rockstar after some point because they were like, no, don't do that with our game. But that has been done in the past. Similarly, there was one company called Wave, spelled like Way with a VE, that did reinforcement learning in Unreal Engine and managed to train a car that actually then drives down a lane in real life because they're actually a manufacturer of autonomous vehicles. So this simulation gap has been crossed in the past with other simulators that aren't really drastically more realistic than BeamNG. Like the one Wave was using was the simple, it looked exactly like our asphalt map. It was just a flat grass plane with an artificial road on it, and they had the vehicle reinforcement learn its way through that. So gut feeling would be the similar thing should apply to us. But again, I'm not aware of published research that has done that.
Gotcha. I just remember I was playing, I don't know if this has changed. It's probably been a year since I've played with BeamNG, but I took a vehicle and ran at full speed into a fire hydrant, and the vehicle, I think, flipped over because the fire hydrant was very rigid. But that's interesting. All right, we have a question from Abigail in the chat. So is there any feature for assessing injury risk? So for instance, if you run into a crash test dummy or a person analog, I suppose.
See, that kind of stuff isn't officially there, mainly because it looks kind of grotesque if you have it in the game. However, there is a very popular mod that has a crash test dummy in BeamNG, which you can just download. I think if you just Google BeamNG crash test dummy, it should be easy to find. And then you can use that like any other vehicle in the game. It should be noted that we have props in the game as well. So something like a pylon to drive over, lanterns or whatnot. Those are simulated by the same physics models, so it's not just for vehicles. And one third-party creation is actually a little crash test dummy. And if you look on YouTube or in the mod repository, you will find many videos of that dummy. And then, yeah, you can apply the same things to that dummy as you can to the other vehicles and testing for beam deformation and stuff like that.
Interesting. Yeah, I started looking into the modding community via the chat that you mentioned earlier, and there's a lot of mods, which is really interesting. I saw that there is a massive Roomba simulator where it goes around eating cars and cleaning them off the roads. That looks like fun.
Yeah,
I posted a link to the dummy in chat, which
Okay.
is a quick Google search.
Gotcha. Okay.
Yeah, if may add something, another very nice let's say byproduct of working with BeamNG is that there is a huge community. So if you want to try out something quickly, chances are that someone already provided some mod for it. So while back we were looking for drones, and someone had a model of the drone available that you can download it and play it around. So there is actually much more to it than what I managed to show. Okay, for example, I completely failed to show many of those very well crafted levels, like there's Italy or Utah, where you can actually try out urban setting type of scenarios. So in my research and in the tool competition, we limit ourselves to basic road geometry definition. The space of possibilities is really huge. So feel free to play around. That's my only advice.
Great, thanks. Okay, any other questions from anybody else? Otherwise, we'll go into a break and then into our social session. Okay. Well, nothing from the various chats that I'm trying to keep an eye on. So thank you both, to all three of you very much. This is definitely appreciated. Again, this kind of simulation for testing, I think, is really fascinating because it takes us more into the real world for testing. And that's something I'm personally interested in. So that means all of you get to be interested in that as well. But yeah, thank you very much. And thanks to BeamNG for providing access to that for everybody, because that can be, I don't know if we have any, well, we probably have a lot of PhD students in participating either passively or actively, but building up a simulation environment just to test out your work takes a very long time. And if somebody else has done that for you and then told you how to use it, that's great. Wish I had that.
Yeah, if I may add something on this, what we are doing, especially Mark and Pascal, is actually strive to make this as simple and as intuitive as possible, such that one has no time to spend in setting up stuff. They just go and try it out. And I regularly play this game with my students in Passau, master and bachelor students, and they can in a couple of hours get their hands on generating tests. That is amazing.
Yes. Okay, great. So thank you again very much to both Gordon, Alessio, Pascal, and Mark. And what we'll do now is a short break. And in 10 minutes, we'll be back for our social session. So the way that is going to work is that I will create some breakout rooms. I will randomly shuffle people in and we will do some discussions based on current topics in SBST. So see you all in a few moments. And for those of you watching on Twitch, I'm going to stop mirroring until our research paper session starts at 12 UTC. So just as a heads up for that, you're going to see the splash screen for about an hour-ish or so. So thanks, everybody. See you in a few moments. Okay, the Twitch stream is live again, so mind what you're saying. It's going out on the internet.
Oh, can I have some poggers in the chat?
Yes, although I think they replaced that emote with something else, right?
Oh yeah, and due to some controversial things the guy said.
Yep. Of course.
Yeah. Can I have some CAC Ws in the chat, please?
Absolutely. Let's get those up and going.
There you go.
You know, the funny thing about teaching, so I taught last semester, the past 3 semesters on Twitch for my students. I have learned so much that, or I've learned that I've been missing out on so much internet lingo by not being on Twitch until recently. That means I've gotten old.
How's your overall experience in teaching Twitch? I mean, do they use like the modes from Twitch? Do they use the slangs for it, or is it more formal, like in a class?
Oh, students could put whatever they wanted in the chat as long as it was safe for work, I think. I had fun with it. Abby might disagree. She was in my class, but I basically, we did normal lectures through Twitch, and I had a Discord channel for questions plus the Twitch chat, and I think it worked okay in comparison. I mean, have to make do, right? So, but we should probably get on to, oh yeah, we got a Monka W in chat. Awesome. Perfect. The sad thing is that I've started becoming afraid of using particular emotes because I know some of them have meanings attached to them. All right, people are joining, so I'm going to start recording again. We're going to get our videos up and running. So feel free to drop questions in chat. I will monitor and relay them if necessary, but we're going to start off with, now why are you playing? You shouldn't be playing already. All right, so I'm going to share Beacon. Here we go. And I think I have to switch this if you can hear this. Please play.
Hello, my name is Ignacio Slater, and alongside Professor Alex Bergel, we developed a tool called Beacon. Now, what is Beacon? Well, I'm gonna waste 20 minutes of your time explaining you that. But first, let's start with something that we all know, and that's that every application will crash eventually. So finding the source of the crash is a really important part of software development. And everyone that had worked on that knows that it's a really time-consuming task and also a very stressful one. So we write tests to check the functionalities of our application, but tests can only show the presence of bugs and not the absence of them. So sooner or later, we will have to face a crash. And wouldn't it be nice if there was a tool that we could just plug in the error and it points us to what caused it? Well, luckily for us, that has been done many times. So there are many tools for this. Star, J-Charming are some examples, and one that's going to be of particular interest to this work is EvoCrash. So EvoCrash is a tool for Java that uses a generic algorithm to reproduce crashes using only the stack trace as a source of information. But no, there's this question as to why. Why making another crash replication tool if there are already so many and that had good results? Well, the thing is, we are ignoring the language typing. Most of the investigations done until now focus on statically typed languages, and in fact, all the examples I mentioned earlier were done in Java. And there's very little work done for dynamically typed languages. And this is important because Python is a dynamically typed language and is one of the most used programming languages in the world. But why is this important? Why is typing important? Well, let me show you a little code in Kotlin, a statically typed language that I happen to like a lot. We have a simple addition of two numbers. So we have that A could be 1 out of 2 to the power of 32 values, and B the same. So we have something like 2 to the power of 64 possible inputs. And that's a very big number, but it's a finite number. In Python, on the other hand, we have an undefined number of possible inputs. We have that A could be an integer, a float, a string. So the lack of typing information makes our search space that was already very big now is infinite. So we proposed a solution for this in the form of Beacon. Beacon is a tool to reproduce software crashes, generating sequences of instructions using a generic algorithm. This was done with two main objectives. The first and most obvious one is to provide a way to reproduce Python crashes. And the second one is to generalize the ideas of previous works into dynamically typed languages, giving empirical evidence that there's no need to provide type information to generate these crash replications. A little tangent here is that Python uses a generic algorithm So beacon shouldn't implement the genetic algorithm. So that's why we developed Genial. Genial is a genetic algorithm framework aimed to be flexible, powerful, and simple to use. We have some example code here, a very simple use of Genial, and a very standard example of a genetic algorithm to guess a word. First, we have a way to generate the individuals, then we have a fitness function, a terminating function, and then we just create the population and run the engine in this case. I'm not gonna enter into detail with this. You can check it on GitHub. And let's continue to the main topic, that's Beacon. So Beacon is heavily inspired by Evo Crash. And before entering into details about how Beacon uses this genetic algorithm, let's check some definitions so we are all in the same page. A minimal crash replication will be the shortest sequence of instructions necessary to replicate the program crash. This means that if I have two pieces of code that produce exactly the same error, one with 500 lines of code and the other one with 5 lines of code, we will prefer the one with 5 lines. Now, an alphabet is basically all the possible values that a gene of an individual can take. Next, we have the signature of a function that's defined as a set of pairs with the first element being the name of the parameter and the second its value. And lastly, we have a statement that is just a triplet with a reference to a function, the name of that function, and the function's signature. And now with that defined, we can go to the first step in every genetic algorithm, that's create a population. For this, Beacon receives a Python module's name. Then Beacon will search in that module for all functions contained in it and will define the alphabet with them. And then it will use an input factory that will just map a type to a type constructor and then generate a series of end statements. On the side, we can see an example of a type constructor defined in Beacon. Now you can see that with the simplicity of this class constructor, it will be really easy to add even more constructors to adapt to every application. Now let's get to the fitness function. This will consider 4 parameters: the individual statements, the type of the exception, for example, an assertion error, and 2 optional parameters that will help differentiate 2 similar errors. For example, we can have 2 series of instructions that generate an attribute error, but the messages contained in both may be different. So we can differentiate by that parameter. So one of the parameters is a string that should be contained in the arguments of the exception, and the other is the name of a function that should be present on the runtime stack. Now, the fitness function is again heavily inspired by the work by Soltani et al., and it's pretty straightforward. Now, one thing to note is that the minimum value of the fitness function will be 0 and the maximum will be 5. But how do we compute the fitness? Well, first, the algorithm will execute all of the statements of the individual sequentially. And for each statement, it will feed the functions with a randomly generated value or the return value of a previously executed function. Then it will check if the desired exception was thrown and will take a snapshot of the runtime stack. And here's an important thing, that we don't worry about checking the type, because if the types are incorrect, it will result in a lower fitness. So the algorithm will solve that problem by itself. The next steps of the genetic algorithm are very, very standard. The selection is just a tournament selection to select the individuals with higher fitness. The crossover is a classic single point crossover, takes the first I statements of one of its parents and the J from the other and creates a new sequence of instructions by appending them. And the mutation will just, with a small probability, replace a statement with a new one. The last step on beacon's execution is the minimization of the amount of statements. This is done by a greedy algorithm that will just take each instruction of the fittest individual and delete it, and then check the fitness. If the fitness is equal to what it was before, then it will continue with the next instruction. And if the fitness is lower, then it will decide that that instruction shouldn't be deleted. This will result in the minimal crash replication we are searching for. Now, to evaluate the performance of Beacon, we proposed 3 experiments. The first just uses the standard library of Python and will produce an attribute error. That's what we are aiming for. The second one, search for an error that contains the text buffer size. And the third one, that's more difficult to find, will try to produce a scanner error that contains a call to the compose function in its stack trace. Now, we can see here some examples of how we could cause that errors. The first one is interesting because it's hard to find where the error is, because the error is in this line, because x.extends y will return none. And that's a very common mistake in Python. Now, how do we measure the efficiency of Beacon? We considered 4 criteria: the time taken to reproduce the error, the number of generations needed, the number of instructions, that's the minimal crash reproduction length, and the accuracy of the result, measured by the exception type, the minimal crash reproduction length, the exceptions message, and a target method that should be in the runtime stack. And we have some interesting results, particularly the last 2 columns, because we can see that the minimal crash reproduction are very small. So we have a little more than 1 line in average. And the accuracy, we see that we have pretty high accuracies for all the study cases. Now, this is an example, just an example of how the output of Beacon looks like. We have the type of the error, the sequence of instructions, and the message. And we can translate this series of instructions to Python code really easily. The same for the others too. But let's see a little bit more details on the results. Here we have the first experiment, the flattened list. We have that greater population size reduces the number of needed generations, and it's a little bit more difficult to see the relationship between population size and the accuracy for this case. But we can still see that the values of a population size of 1 are somehow lower than the higher population sizes. Now, the NumPy experiment is really interesting because NumPy is a really big library. And even though it's big, we had 100% of accuracy for all the tests. So we could reproduce the error every time. And the last one, the hardest one, is the YAML one. And it's clearer here that a bigger population have better accuracy, and the same for the number of generations. Bigger population have less generations needed. And what can we conclude from that? Well, we created Beacon and we gave some empirical evidence that search-based crash replication techniques can be applied to any programming language without need of providing type information. The proposed fitness function proved to be very effective, even though it's very simple. And we could see that there's a clear relationship between the population size and the algorithm's performance, where a bigger population produces better results. On the other hand, the algorithm's efficiency and the individual sizes don't show a clear dependence. But not everything's perfect. We have a lot of future work to do. Beacon is in a really early stage of development. The fitness function was defined as a process of trial and error, and we think that the function can be refined to produce better results. The scope of the search is also really small, since we just consider functions defined at module level, and we can't use classes, for example. And lastly, the experiments were run in a controlled environment, and that make the errors that we wanted to reproduce, the stack traces we wanted to reproduce, really small. So Beacon should be tested on more complex scenarios. And with the addition of classes, it will probably be more possible. And we don't have a comparison to a baseline to know how much a genetic algorithm improves the results. And that's all I have to say. You can go to GitHub if you want to check in more detail the implementations. And thank you.
Okie doke. Thank you very much. So I'd like to open up the floor for questions now. We already have one. Maria, go ahead.
Hello, thank you for the nice presentation and nice work. I had a couple of questions, but before that, as I noted in the chat, EvoCrash is not available anymore. We have BotSync tool right now, which is contains the EvoCrash technique there and also new techniques that we've introduced in the recent years. But about the question, I have a couple of questions about the fitness function. I think the fitness function, which is defined by Beacon, has three elements, and all of them are either 0 or 1. Isn't it make it very flat landscape in the search space, because it's either 0 and 1, and this is one of the problem with EvoCrash was that we wanted to make it a little bit more continuous.
Hello?
Yeah. Ignacio.
All right.
Yeah, and well, and I was having a question about the weights that you gave to the fitness function. Y, F, X, and X, F, Fn, if I'm not mistaken, they are weighted 2, but the other one is 1. So it means that those two are more important?
Yes, the fitness function was defined purely just trying values and modifying them, seeing which one gave the best result.
Okay.
But we know that the fitness function is very limited, and having all just 5 possible different values limits it very much. But we left it as that since it's a very early stage, and we wanted to see if we were going in the right way. We know that that simple function gives good results for simple experiments. We can now further improve and see really which parameters would be more important than others,
and also consider other parameters on the fitness function. We're not considering, for example, the stack trace contains information about where in the code was thrown an error, the specific line. We're not considering that. That probably should be important when we're trying to reproduce a stack trace.
Yeah, if you were like maybe to complement. So thank you very much, Poya, for your question. And they're very, and yes, you're right. Your doubts are well founded. So the goal of this work was really to replicate the effort of EvoCrush using Python. And so this is, like, as Ignacio said, a very early stage. And just to understand a bit, what are the challenges for the replications. And one of them, for example, is the lack of baseline. Like, there is no benchmarks for to be able to compare, to measure the performance of the algorithm. So that was a bit, I don't know. So this is a problem that we don't have much answer to so far. And also, like, so I don't know, like, if anyone has idea about benchmarks for Python, that would be good. And also, like, we also face problems about how to define that types are missing. So this goes to the problem that Gordon was mentioning this morning about missing type informations, which makes object reconstruction very hard. So yeah.
Yeah. Do I have time for a small question as well?
Yeah, we've got a couple more minutes, so sure.
Okay, so this question is mostly about thinking aloud here. There are a couple of techniques out there for doing the type prediction, mostly for Python. Do you think that those techniques can be used in your approach as well? Then you will have more prediction about the types, and then you can reduce the search space.
We haven't looked into that in that, but typing, type systems are quite a beast, and they are, I mean, yes, probably will help on some point, but most of the type thing that we have seen, like the type inferencer, because several of them exist in Python, but usually they are hard to put in place, and again, we haven't looked into that, so I can't really confirm my intuition, but from what we have seen in other languages, also there is so yeah, I don't know. We probably, but we don't know.
Okay, thank you.
Yeah. Also, like, you were mentioning something at the very beginning, like you tried to replicate EvoCrush, but I was not able to catch the exact name. Maybe you can write it on the chat or something.
Yeah, I put both the tool paper and the GitHub link in the chat. It's called Botsing. Yeah.
I see.
So yeah.
Thank you.
This one contains EvoCrush thing, and for instance, now it's multi-objective. It's not single objective, so there are some improvements there.
Thank you.
I've got time for one more question. Does anybody else have one? Otherwise, I do. Yes, this is my right. I just have one question regarding your, I think it was Genial, was the genetic algorithm framework that you created. How does something like that compare to Deep, which is another common genetic algorithm framework in Python?
Okay, so the main purpose, because when we were starting, of course, what we looked first was the available tools for genetic algorithms. And the thing with Deep is that the learning curve that it has is really high.
Mm-hmm.
So I know about genetic algorithms, and even then I found it really hard to understand at first. So the idea behind Genial is to maybe provide not a such, I mean, not as complete as Deep, not as efficient, but that maintains flexibility and could be more easy for newcomers? For example, when you're just learning about genetic algorithms, you can't go and use deep. It's really, really hard. And I got a lot of inspiration from other frameworks, in particular genetics from Java, that I think that's a little more straightforward. And um, Alex has a book also about artificial intelligence and implementation of a genetic algorithm in Faro that I also used as an inspiration.
Okay, thank you. Yeah, I was just curious. I have the same problem with deep, so don't feel bad. Okay, great job. Thank you, Ignacio and Alex. It was great. Okay, our next paper I'm going to share now is from Byron DeVries and Kristen Trefftz. Let me share that.
Hello, this is Byron DeVries, and this is a novelty search and metamorphic testing approach to automatic test generation. And so the original problem that we were attempting to deal with when we started work on this paper was taking some space in a 2D Euclidean format and trying to subdivide it into smaller and smaller pieces. The problem was when we moved this to a sphere or a spheroid, simply taking the straight distance between A and C on this sphere wouldn't be a straight line. We'd end up having two kind of slightly curved lines. And the reason for that is the same reason that the flight from, let's say, New York to London curves upward, up north, is because it's the actual shorter path between those two locations as opposed to what appears to be a straight line on, let's say, a Mercator projection of the Earth on a flat surface. Now, what these straight lines are is they're geodesics, or they're geodesic segments on this spheroid. And so we needed to come up with a way to actually be able to subdivide space correctly so that we wouldn't end up with this kind of space in the middle that either would end up being an overlap or it would end up being area that we hadn't covered in our subdivision. And so we had to find B. The problem is finding B, if we start at the North Pole and we're trying to find a direction south, where do we go? If we simply say south, there's almost any direction that we could go. Similarly, if we have somewhere, let's say the international date line, where on one side it's negative 180, the other side it's 180. If we cross that, oftentimes there's difficulties calculating in one of those two directions. And so we had to find a way to verify that our relatively simple midpoint operation actually worked correctly as we expected. And so what we did is we came up with a metamorphic relationship. And a metamorphic relationship is really just a property that's true about the software in that we can compare it in some way, either a direct comparison where these two things should be equal, or a comparison in terms of one should be less than the other or more or something like that. And so our metamorphic relationship is relatively simple. If we have these two different points of latitude and longitude, if we calculate the midpoint from the second point to the middle, or if we calculate the midpoint in the other direction, we should end up with the same midpoint in the middle, or at least close enough to it. And this is actually a relatively useful metamorphic relationship, because if one of these points is up by the North Pole, or if one of them crosses, one of these lines crosses over the international date line, hopefully we'll catch those issues as violations of our expected property here. Now, because these values can be difficult to calculate, we didn't always know what the results were actually going to be. And so we didn't know what things would be most useful to test, but we wanted to make sure we didn't have errors. And so we looked at using a direct genetic algorithm. It's just a standard genetic algorithm, population of 500, 1,000 generations, a chance of mutation at 3%, simulated binary crossover, and tournament selection. And then our fitness function, we actually used the Euclidean distance between the two midpoints that we calculated so that we would not use the same software under test that operates on these geodesic segments to also calculate the fitness, right? Because then we're just testing what we're testing with what we're testing. But this fitness, as it grows, should also indicate that there is a shortest path or geodesic growth in the distance between these two things on a spheroid, right? Now, the problem is we don't get good results with just a regular genetic algorithm. And so we decided to look at Novelty search. And using Novelty search, we kept all the same original parameters of our genetic algorithm, but then we had a Novelty archive of 100 individuals, and instead of optimizing for a direct fitness, we optimized for the average distance from the 10 nearest neighbors for just this 4 tuple of all the different midpoint values. So really what we're looking for is we're trying to optimize all the different places these midpoints could be around this sphere or spheroid. Now, this combination of Novelty search and metamorphic testing, when we looked in the literature, surprisingly, no one had actually combined these two before, despite the fact that with just a regular genetic algorithm, we weren't getting the types of results that we were hoping for. When we actually ran these two in comparison, we actually got significantly better results with the Novelty search on this straight black line. And you'll see it pops up almost immediately compared to the directed search. That takes a significantly longer amount of time to start identifying errors, right? In fact, if we look at the max fitness, or the largest error that we found over 40 different runs, we'll see that the Novelty search is almost always up at the maximum that we'd expect, around 360 degrees, while the directed search is almost entirely localized at the bottom, only a few degrees off, although it does get 1 or 2 up towards the max. It is limited. Now, there are limitations to this entirely. One of these limitations is that we're looking at a single limited case study with only a single metamorphic relationship. And that's important because the rate of convergence is going to be impacted by both the fitness function and the Novelty metrics chosen, which is going to relate heavily to that metamorphic relationship. And so it's not clear if this will necessarily expand to other problems. Of course, metamorphic relationships can also be very difficult to come up with, and you have to know the problem domain well enough to be able to identify those things that should be true, those properties that should be true regardless of the inputs. And then, of course, the computational cost of finding those k nearest neighbors means that the equivalent fitness function of Novelty search is computationally more expensive than the fitness function of the regular genetic algorithm that's just searching directly for these errors. So in this paper, we presented a approach to automatically identifying what we found was valuable test cases using a novel combination of both Novelty search and metamorphic testing. We've demonstrated this approach on a small case study that both showed that it worked significantly better, and it also helped identify some real-world issues in terms of issues with the polls and issues with crossing over the international date line, specifically the difference between 180 and negative 180. Our assumption had been that it had been bounded to less than one of those values, but we got values that were truly over that, and that could have easily given us an off by 1 type of error or an overflow. And then really the future work here focuses on addressing the limitations of this admittedly small study, especially applying it to different domains, different genetic algorithms, different metamorphic relationships to see if the improvement holds through a variety of different places. All right, thank you.
Okay, thank you very much. So open up for questions now. Sorry, Gio will open it up for questions now because I think this is your
Sorry,
paper.
I was sharing. Okay. Yeah, thanks for the talk. Any questions from the audience? Yeah, see that Giovanni, please go ahead.
Oh, hey, nice talk. Thanks for presenting it. I found it very interesting how to combine metamorphic relationships in the fitness function. But I might have missed it from the presentation. But why do you think the direct GA is not as efficient? I mean, I would assume that a direct fitness function would be more precise in finding the required solution. But why does that not occur?
Without further study, it's hard to say exactly why the direct fitness function doesn't work as well. But I think part of it is there's enough of an error surface, and on the spheroid, you can move around in so many different directions that until you get something that starts really close to the pole, you're not going to get the level of error that you would. And so it's a relatively flat surface until you find some of those larger problems. And so I think it just went to almost just random search until it could find some of those issues. And most of the time it couldn't find it. There may be fitness functions that are better that would allow for something better, but especially with the kind of geometric problem space, that distance function really seemed to push it into finding those problematic edge cases. Yeah.
Okay, got it. Very interesting. Thanks for talking. Thanks for answering the question.
I think next is Eric, right? If you have a question. You're muted. You're on mute.
No, I was giving virtual applause. I didn't have a handy question.
Yeah. Any other questions? So I have a question that you mentioned in the end of the talk. You said in future you plan to try to explore more metamorphic relations. So do you have any in mind that what other metamorphic relations you could have for solving this problem?
Admittedly, no. There's some other ones in kind of a geometry sense, but those are obviously very similar and probably would work in the same type of way. Really, this problem came up because we had a problem testing while we were trying to do something else. And so we haven't thought too much about what other metamorphic relationships we should try, but yeah, we're starting to think about that at least.
Thanks. Any other questions? So we still have, we have time for 1 or 2 short questions.
I have another question if you allow me. Okay, it's more like, not exactly a question, but insight from you. I mean, I saw that you use metamorphic relation in the fitness function. Do you think there are other places, like other components of a GA that you can probably use metamorphic relations, say in crossover operators or during the replacement? I don't know. It's just a comment, and because I found it very interesting the way you did it, and perhaps there are ways of augmenting the GA in other components as well.
That's a really interesting point I hadn't considered, but certainly you can generate new tests with a metamorphic relationship. Oftentimes, giving it some parameter off of those relationships, you can create new things. So I suppose there's no reason you couldn't view that as a potential genetic operator in the evolution itself, especially making sure that those outputs are still valid within that metamorphic relationship, but how far off they get. Instead of crossover or mutation, or maybe in addition to. That's a really interesting point. I don't know if anybody's looked into that, but that's really nice.
Yeah, I never seen something like this as well. And I was thinking about maybe like a local search after the crossover and mutation, in which you apply some kind of heuristic to get closer to that point that you're trying to get, but using the leveraging on the metamorphic relationship to do that. Maybe in which objective it should be very interesting as well. Perhaps some kind of metamorphic relationship between the objectives during the replacement. There are sorts of kind of things that can be done. I've never thought about this before during search, and it's very insightful. Your presentation was very insightful for me. Thanks.
I really like your comment. You've got me thinking in a whole new way now. I appreciate your comments. Thank you.
Yay. All right, great job. I'm going to move us now on to our next video. So thank you very much. We have a video. And all right, a couple of things here.
Hello everyone, my name is Seunghee and I will present about our paper about preliminary evaluation of path-aware crossover operators for search-based test data generation for autonomous driving. Nowadays, autonomous driving industries became one of the most valuable industries. In this situation, safety assurance of vehicles became a key issue on development. To improve the safety perspective, several methods to test autonomous vehicles are developed. The common method is testing on real traffic, but real traffic test has safety risks in testing itself and it needs too much cost and time. So the virtual testing method has become a good alternative. SBST is the one-off reset method to test autonomous vehicles in virtual environment. It has two main functionalities. Firstly, it can generate and evolve virtual road networks. Then, it can test the lane-keeping functionality of autonomous vehicles. To achieve this objective, SBST combines procedural content generation and genetic algorithm to road network generation and evolution. On the other hand, SBST has some limitations, that is about search operators. However, these operators do not consider the road segment that was traversed by the simulation. So, objective of our paper is to refine limitations of SBST by proposing novel crossover operators. The new crossover operators can utilize road traversal data on last simulation so that it can preserve the dominant traits of a parent road network. Moreover, we introduced new fittings function to capture more details of OBEs. Finally, we could produce road networks that maximize out-of-bind episodes OBEs in simulation. Before explaining our main concept, I will introduce the way to create road networks. That is Procedural Context Generation, or PCG in short. PCG is a system that generates the virtual road network automatically. There are three steps to create random road network using PCG: road segment generation, and road network generation. And there are two validation methods: single road validation and road network validation. I will explain these methods briefly. The road network generation is an incremental process that builds road networks from road segment using PCG. First, it constructs a short straight road segment like A. And then it concatenates randomly generated road segments repeatedly until it reaches the map boundary. This is B and C. Finally, it generates and places multiple roads on the same map to create a road network like D. After generating road and road network, validation process is required. In order for a single road to be valid, a road must cross the map boundary and must not intersect itself. If a road violates one of these conditions, PCG rejects the road and generates another valid road. Next is road network validation. There are two conditions: all roads must have only valid intersections, and all roads must have at least one intersection. If a new added road violates one of these conditions, PCG rejects to add the road and generates new road until the road network is valid. The proposed ATeSS, Automatic Test Data Generator System for Self-Driving Car, automatically generates test data map for self-driving car using GA. Our system inherits PCG and GA from SFERT with proposed improved genetic operators and fitness function. Within GA, we use strategy of tournament selection and elitism mechanism.
As a fitness function, we use bounded lateral deviation. The fitness value is calculated as the distance between the center of the road and the ego vehicle. This lateral deviation is bounded by maximum half-road width and counted as OBE if fitness value exceeds the half-road width. The original SFERT string crossover operator generates child map using any roads within the selected parent maps. The doing crossover operator, which is binary operator, gets any road within its parent map as input and split each road into two roads at a randomly assigned segment. We cross-connect the divided road on the child map until the road reaches to the map boundary. If the child map including newly generated road satisfies the validation, add new road in the child map. Our ATeSS doing crossover operator operates at the path level, so that only the roads actually traversed by ego vehicle could be selected. The traced path is shown at line in the figure A and B. The parent road is randomly selected based on the traversed path. Then the cut point would be selected from the parent road to retrieve the segment to perform crossover with. Figure A, for example, among the traversed path that involves the two roads, the road segment with yellow lane is selected to cross over. Likewise, the green lane is selected in figure B. Then we cross-connect selected road segment until the road reaches to the map boundary. If the child map including newly generated road satisfies the validation, add new road in the child map. Otherwise, ATeSS will make up to 10 attempts with the same pair of chosen roads with different cut points, after which it chooses another pair of roads from the parent. In figure C, two chosen segments which is yellow and green lane are combined into child road and added to the child road network map tile. Doing crossover process will repeat until the number of roads in the child map tile is equal to that of the parent map tile with fewer roads. This example clearly shows how our ATeSS doing crossover operator logically improved from SFERT. Each red lane in the figure shows the path of the ego vehicle. Within the SFERT, since the crossover operates at the map level, the green lane in the middle figure is selected even though it did not contribute to the fitness value at all. This selection degrades the performance of GA because it's same as the random selection. To cut off this selection, we proposed the ATeSS operator that only the evaluated path of ego vehicle could be selected, where the selected road segment in the example includes the path. Since its fitness feature lies on its path, not on the map, we suggest that our ATeSS joint crossover operator logically improve the SFERT joint crossover operator. Similar to the joint crossover operator, the original SFERT merge crossover operator also generates child map using any roads within the selected parent maps. Any road within parent is randomly selected, then the entire road is tested with the child map. If the child map including parent road satisfies the validation, add the road in the child map. This method is basically only for the merge road network. For merge crossover of ATeSS, it operates on the path that was traversed in the fitness evaluation. The traversed path is shown red lane in the figure A and B. While keeping the maximum number of roads to 3, ATeSS randomly chooses one or two roads that are traversed from one parent and merges them with the other traversed roads from the other parent. Then the chosen roads are merged into the child road network. The two blue lane roads from figure A and one green lane road from figure B are selected, which merged into child map in figure C. After merging, merge crossover operator follows the same validation and iteration policy of doing crossover. For the merge crossover operator, each lane in the figure shows the path of the ego vehicle. Within the SFERT, the blue lateral straight lane in the left figure is selected, even though it did not contribute to the fitness value at all. Same here, to cut off this selection, we propose the ATeSS merge operator that operates on the path level, so that all the selected road segment in the example includes the path. We suggest that our ATeSS merge crossover operator logically improve the SFERT merge crossover operator. We did preliminary evaluation of ATeSS using Humeniuk autonomous driving simulator. It results 13 to 29% more obese than SFERT and constantly outperformed random search. These early findings are in line with our expectation and shows its potential promising. In conclusion, We proposed more detailed fitness function and improved crossover operators in our system ATeSS, which is improved version of SBST. Our fitness function eliminates the possibility of malfunction in the previous method and can capture out-of-bound episodes more elaborately. Also, our new operators in ATeSS focus on the path traversed by the vehicle in the latest fitness evaluation in process of doing crossover. We expect our operators to better preserve the parts of the road network that resulted in each fitness value. Finally, through the preliminary comparison of ATeSS, we showed potentially promising performance. We leave more rigorous experimentation and comparison as future work. Thank you for your attention.
Okay, thank you very much. We stop sharing, and now I would like to open up for questions. So, who would like to start? Lots of applause, I see. Oh, Alessio, go ahead.
Thanks. I think I should, as one of the authors of ATeSS, I should open break the ice. Okay, so very interesting idea. One question that I have, it's not exactly on your work, but on something that kind of builds up on your proposal. So what you say is you have an entire network, but then most of this network is not reused. It's kind of thrown away because in the original implementation, we don't care where the car passes. So let's reuse this information. And this is, I think, a very good intuition. What I would try to understand is you still follow this model of ATeSS where one map with multiple roads correspond to one test case, and then you elaborate. But what do you think of reusing as much as possible the same map? So having multiple tests generated from a same road network, because you can follow different paths, and then this collecting some information about there to exactly do what you do now, selecting, basically prioritizing the roads to recombine. What do you think about this?
Well, first let me responding by thank you for the asphalt, because that allowed us to do this. In fact, I mean, I say, allowed us to do this, but it was really all the students' job, and I just sort of watched along. So what I think is interesting about this is, now that we are evolving the road networks for the testing of autonomous vehicle or driving, the layers in the abstraction layers from the fitness function to the actual genotype is much more complicated. We have multiple layers, and then they are much more nuanced. So what we did was actually to introduce one more distinction between the actual raw material and what impacted the fitness, because I think anything that's not traveled cannot be affecting the fitness, which is based on the driving. But as you said, there are many things to be dug out from that road network and one map tile, I think. So, but then we will have to increase the sort of low-level genotype. For example, we should carry on where the starting point was if we want to do what you suggested. And eventually, I think it can be not just a combinatorial or discrete segments, but something like not heat map, but you know what I mean. So how much deviation was at each point on the road, and it will be like, okay, this segment is actually hotter, this is actually cooler, and then we can really see where the hotspots are. And I think there are so many ways that we can read this particular data representation. It's just being a small sort of semester-like project, we just wanted to build directly upon asphalt, and that. But I think this was small but meaningful, interesting thing. Yeah.
Thank you.
We have time for one quick question if anybody has any other ones. Vincenzo.
Hi, thank you. It was very interesting. And what I liked most, it was the way it characterizes the out-of-bound episodes. Have you thought about measuring how many different out-of-bound episodes you find? Because right now you just count how many failures you get. Have you also thought about comparing the tools about that kind of metric?
You mean actual head-to-head comparison between this version and original S14 in terms of number of OBEs?
Number of different OBEs,
Number of different OBEs.
Yeah.
I see. So you're also touching on where the episode actually happened. I don't think so, because we fell short of time in terms of doing full comparison. But it's also a very good point. So we should not be just counting the episodes, but if we can identify whether they are the same episode or not, that would be, yeah. And I think if we want to actually read more from the past shape and learn where the problematic areas are, I think that should be the first step. Yes. So the answer, we haven't done it, but sounds very interesting.
Thank you.
Yeah. All right, thank you, everybody. I have a follow-up question. I will put it in chat so that we can keep moving along. But very, very interesting work. Thank you very much. Here, our next paper. And our last video, I believe, is on augmenting search techniques, and I should be, hopefully, sharing that momentarily.
Hello everyone, I'm Paulo, and I will be walking you through augmenting search-based techniques with static synthesis-based input generation. So, in the beginning, there was search-based software testing and dynamic symbolic execution in the area of program testing. SBST was known for being slow, but could support a lot of program features such as non-deterministic behavior and I/O operations. On the other hand, dynamic symbolic execution was really fast, but could not support so many features. Meanwhile, hybrid approaches started to appear. These actually walk between SBST and DSC, depending on the DSC ability to reason about the program features. We are currently working on a new type of approach that does not rely on dynamic symbolic execution and is capable of supporting the same program features and providing the same, almost the same search efficiency. Let's take a look at an example. Let's say we'd like to transfer an X amount of money from account 1 to account 2. In this case, we'd like to generate inputs that could maximize the coverage of this program. As you can see, there are different conditional expressions in this program. So the first step is to propagate the variable declarations and extract the conditional expression. In this matter, the first step is not really that much different of dynamic symbolic execution. Now, the second step is to categorize the conditional expressions. The thing is, there are actually two categories of conditional expressions: statically verifiable conditional expressions and non-statically verifiable conditional expressions. The statically verifiable conditional expressions are those conditional expressions that, for example, an SMT solver can reason about. Okay? The non-statically verifiable conditionals are those that require program execution so that we can know the truth value of a conditional. So, for example, if I'd like to check fraud from a transaction, I'll need to ask the server to check the transaction and then know if this condition holds or not. Now, each of these conditional expressions represents an objective that our evolutionary algorithm will try to optimize. So let's take a look at one of these conditional expressions. So each individual will be responsible for one of the conditions. in this example, we have the conditional expression number 3, which has a non-statically verifiable condition and a statically verifiable one. The static verifiable part is actually provided to a non-deterministic synthesizer, which will be capable of generating values for the initial population and for making mutations in our individual. The non-statically verifiable conditional expression will actually be used in the evaluation of our evolutionary algorithm. So each individual will try to optimize this non-statically verifiable condition in our evolutionary algorithm, since this condition is always ensured to be true because of the non-deterministic synthesizer. By the end, we should have a test suite capable of maximizing the coverage as much as possible. So we showed an ongoing work with an approach that refines search-based techniques with constraints. This does not rely on dynamic symbolic execution, so we always support the program features. And the truth is that the statistical analysis only occurs once in the beginning of the program, so there are no problems in this method. Thank you so much for everything, and hope to answer some of your questions. Thank you. Hello, everyone. I'm Paulo, and I will be walking you.
Okay, so yeah, your turn.
Yeah. Thank you very much for the talk. Any questions from the audience? So I have a quick question. So you mentioned that it supports all programs. Would you mind explaining more? Like, what do you mean by the all programs? It's like, yeah.
I'm sorry, I did not understand. Could you?
Yeah, in your slides, I think the second last slides. Yeah, you mentioned that one advantage of your work is to support all programs.
Oh, okay.
Yeah.
So
yeah.
One thing is, so as I said, typically in an hybrid approach, if the dynamic symbolic execution cannot reason about a certain condition, then that specific condition, like for example the check fraud, which required to access the server, is not really that helpful towards guiding the evolutionary algorithm. By reusing the conditional expression actually in the fitness function, then we can support that conditional expression when before it was simply ignored, for instance. Okay, so in this sense, we can support more programs, okay, and the entire and support the entire program properties, the entire properties present in programs. Not sure if that answered.
Thanks.
Okay, thank you, G.
So any other questions? We have some, I think 2 or 3 minutes for the questions.
I think I may have missed it. What when you're bringing in an SMT solver like this, how much does that add to the runtime of a search heuristic? Just a legitimate question. I mean, I'm curious.
Yes. So the thing is, one problem that we actually initially addressed in the paper, and then actually left out because we needed an evaluation was the diversity issue with SMT solvers. And the comparison with the execution time that they need to generate a specific, in this case, a specific value. The thing is, in this case, the SMT solver is here just to ensure that the value is correct. Truth to be told, our synthesizer can generate the values for the conditional expressions always correctly, which means that we wouldn't need the SMT solver to check if the condition holds or not, but we added it anyways just to make sure that it is actually correct.
Okay, thank you.
Okay.
So do you have any plans in the future to conduct more experiments to show the effectiveness of the approach?
So right now we are currently working with, so in this example I showed like integers and accounts and the simple account. The thing is, we are working on objects, and objects present a more difficult work to synthesize objects because of polymorphism and inheritance. So right now we are currently working on that. And we are also waiting for our work submitted on SMT diversity, and depending on that, keep our work in this area of test generation.
Thank you. Looking forward to the new work and paper.
Thank you, Jiin.
Okay. We're still outside ahead of schedule, aren't we? I guess we could move on to the next paper if Dmytro is ready to go. Unless there's any other questions, I guess, but we can move on a little early. That's okay. Thank you, Paulo.
Oh, yeah, okay, so I think I'm ready.
Okay, go ahead and share your screen when you're ready.
Yeah, that's right. Okay, so you should see my screen now. So hello to everybody. Today I would like to present our work called Data-Driven Testing of Cyber-Physical Systems. I'm Dmytro Humeniuk. I'm a master's student at Polytechnique Montreal, and I was doing this work under supervision of Professor Antonieri and Professor Hong. So in our study, we're dealing with cyber-physical systems, which are embedded systems interacting with a complex environment. And basically, the controller software takes decisions based on the inputs from the based on the inputs from the sensors. And one of the crucial steps in the development of such systems is ensuring that they are functioning according to the requirements. And in a V verification and validation model, an important stage, one of the first stages is model in the loop testing. In this stage, we develop a model of the hardware and a model of the controller software, and run test scenarios in the simulation environments. However, one of the limitations the simulation environments have is the lack of guidance to engineers on what test cases to use, or even if there is some guidance, the effectiveness of the test cases is not as developers may wish. So a number of approaches exist to test cyber-physical systems. Obvious one is exhaustive exploration. However, it's not effective when you have such a big search input space. And other approaches are based on testing whether a system can meet requirements specified in metric temporal logic or system temporal logic. Some approaches test the probability that such requirement is met. Others find the worst case scenario, but what is common is that they are testing the system. They're looking for a combination of system inputs to test the cyber-physical system. They're not directly considering the environment in which the system operates. So the problem that we tackle in our work is actually finding such a virtual environment for the autonomous, it mostly applies to autonomous cyber-physical systems, that will force to behave it not according to the requirements. So that such a combination of virtual environmental conditions that will maximize the deviation between expected behavior and the simulated behavior. Expected behavior can be specified in the requirements, and then simulated. And to evaluate the simulated behavior, we suggest using simplified system model and use the outputs of running the scenario with a simplified system models. And this delta function can be defined by developer. For example, for the thermostat, we're looking for the maximum deviation from the schedule. So we propose to represent such scenarios as a matrix where columns represent a sequence of so-called virtual states, and each state has some attributes that describes it. As an example, we can have a state where a system should reach a particular temperature, but at the same time, we include the environmental parameters such as humidity or outdoor temperature, and the goal is to find the combination of the states that would maximize the deviation from the expected behavior. And we are using single objective genetic algorithm to solve this optimization problem. With this configuration, it is easy to define crossover operators, mutation operators. So we're using one-point crossover where we exchange states, where we simply exchange columns for different test cases. For mutation, we use three exchange operators. For three operators, exchange operator switches positions of the columns. Change of arrival operator puts maximum or minimum random value from the maximum or minimal range. Scramble operator changes positions of columns, and they are very modifiable. You can define it according to your task. And to evaluate the approach, we are using a real model. We are using a real thermostat system from which we collected the data. Our data is the temperature in the room and the scheduled the temperature. We collected it from the period of almost 6 months, and in 2020, and we noted that we had several modes of thermostat operation, which corresponded to different decrease temperature patterns. So the goal of our search was to find such a temperature schedule, as well as the modes of thermostat operation that force it to not follow the schedule, to deviate from the schedule. And these modes of operation, we surmise that they correspond to different environmental conditions. So to compute the fitness function, we need to we first create a simplified system model as it is a thermostat, and the equations for temperature increase, decrease are more or less known from such physical laws as Newton law of cooling. And therefore we use a white box approach to create the equation and then fit and then find the coefficients by fitting the data. However, if the system is a black box, we can use some system identification techniques to find equations for the simplified model. And once it is defined, we're ready to execute it on a scenario. And here is an example of how we represent a scenario for a system. For example, keep a temperature of 20 degrees for 2 hours, then switch to 25 degrees, keep it 5 hours, etc. And the goal is to exchange these states, exchange the values to find the worst schedule. And our approach performed effective comparing to random search in different configurations. So one of the last configurations we used was 250 population size, 200 number of generations, high crossover rate, and high mutation rate and crossover rate. Here are examples of test cases generated in initial population. You can see that the thermostat follows the temperature pretty closely, but in the final generation, we can see that the room temperature, the red line, deviates from the schedule, which is a blue line. And one of the limitations of this approach was that in the last generation, the test cases were very similar to each other. So basically it would converge to one bad test case. So in the future, we would like to add some diversity operators to find a set of bad test cases. And in the example, you can see fitness function of -3, which means on average, the temperature deviated on 3 degrees from the schedule, while the user wanted, for example, 1 degree. So actually we conducted, after publishing the paper, we conducted additional case studies. One was to generate ROAS for lane keeping assist system. Another was to generate mazes for an autonomous robot to test its planner. And so in conclusion, we think that it is important to generate not only the inputs for the system, but the environments itself. We can use a surrogate model to guide the search, namely calculate how the surrogate model behavior deviates from the requirements. And in the future, we plan to use this approach depends on how well your surrogate model is. So to improve its accuracy, we plan to use machine learning or, for example, neural networks to build these simplified models and extend our approach to different test generation problems. Yes, thank you for attention.
Okay, thank you very much. I'd like to open it up for questions now.
I do have a question. Thanks for the presentation, Dmytro. You said that you measured the temperature over 6 months. Is that correct?
Yeah, we there was a we have a smart home installation. One professor has a smart home installation, and he provided us the data from the controller from the sensors, and basically we used this data to build the thermostat model.
Oh, I see.
So yeah. So we didn't use a simulation of a thermostat. We directly built model from the data.
Oh, I see. So I guess took a lot of effort to do that as well. I mean, 6 months monitoring.
Yeah. But when I was doing this this case study, the data was already collected. We were just thinking about a demonstrative case study, and we picked this one as we had data, and it is good for demonstration purpose.
Okay, and I have another minor question, perhaps. When you're generating the states, the transition between the states, do you consider transitions that are not possible? Let's say you schedule states of temperature 30, and then for the next minute to temperature 0, let's say.
Yeah. It's a good question. So yes, each test scenario will have some requirements. For example, just to make it simpler to understand, when you generate rods, you also have some limitations, like the rod can't be too sharp, can't be intersect, and here it is similar. Like we define some requirements. For example, the temperature cannot change more than 5 degrees in 1 hour or something like this. And the test cases which violate this requirement, we put the fitness function at 0. So we just eliminate them. But we check that the test cases, we validate them, and then compute the fitness function.
Brilliant. Thank you very much for your presentation.
Yeah, thank you for questions.
Abigail, yep.
Hi, thank you for the presentation. I know you said the data was already collected. Do you know what device was used as the controller and what you used for the temperature sensor?
So for the controller, we as a temperature sensor, it was ATeSS temperature sensor. I guess it was a wireless temperature sensor, and the controller was a Raspberry Pi. Actually, it is called a Z-Wave smart home system. You can see on the Raspberry Pi there is a special Z-Wave controller, and this Z-Wave platform actually provides some applications that allow you to set the thermostat schedule, and then the temperature data is collected, is saved in the log files, and then we parse the log files to extract the temperature data.
Okay, great, thank you.
Any other questions? Otherwise, I've going.
Just a very philosophical one. In the future work you mentioned, which is interesting to experiment neural network compare against what you have used, machine learning, and one on the premise was that you want to see how good the model is. So, when we move to neural network, at least my feeling is that it's very difficult to interpret them. You know how good they are, but it's very difficult to justify why they are good.
Yes.
So I don't know, maybe that's essentially how you want to actually compare the results. It's just a philosophical.
Yeah, well, I think we would calculate how accurate it is in predicting the full model values, but I agree with you. It will be a bit tricky to explain the model. So the advantage of our approach is that we know of the current approach is that we know what our model is, why we get such values. But this is a simple example. When we move to a more complicated example, it can be tricky to build an accurate model. For example, for the car model, it is quite tricky to build the surrogate model that really corresponds to the behavior of the full model. So maybe the accuracy, even if it is black box, the accuracy will be better of the neural network based model. So
I don't want to make you in trouble, right? There are papers that I wanted to mention to you. Maybe I can share that. For example,
it would be very grateful.
There are self-driving cars, for example, use an image, and then depending on the image, they decide. That can be done with machine learning or deep learning if you want, or neural network. And there are recent papers that like tell you which feature has been selected. So looking at the image, what part of the image was used for classify, the good reason for it. So maybe I will share couple of papers offline, but just to tell you that if you go in that direction, that's something to keep in mind. It's very difficult to explain. It's good to have some references for it.
Yes, thank you very
much. Good work, by the way. Good work.
Thank you. Thank you much.
Yeah, thank you very much. And that will wrap up our research paper track. So thank you to all the authors for participating. What we're going to do now is a 10-minute break, and then we'll come back for our tools competition reports. So that will start at, well, it'll be 13:35 UTC. That's 10:35 a.m. for me. So apply that to your time band. So thanks, everybody. Back in 10. Okay, we, or at least I and Sebastiano, are back.
Hey.
So next up is our tools competition. So we have our tools competition chairs will be running this session: Sebastiano, Alessio, Fiorella, and Vincenzo. We have 8 minutes for the talk and 2 for questions, I believe. So as long as you keep your papers within 10 minutes, we'll stay on track. So, Sebastiano, take it away.
Yep. Yes, just a second. I will be sharing my screen. Since the competition is a bit, composed by the cyber physical and Java competition, we probably will have just one presentation, and I will sort of give an overview of what the competition is about this year, and basically I will present the results of the Java competition. Then it will be Vincenzo and Alessio will take over, and we'll continue with the cyber physical system results. So it will be a bit longer. Instead of be 10 minutes and then 10 minutes, we decide to have one main presentation. Hope that's fine with you, Eric. So as you may see, the theme of this year competition is composed by 4 chairs. This is because we extended, we will go a bit later on this, the competition in 2 domains. And this required a lot of effort. So I think we identified, we have great teams and had a very good experience in running the competition. What is very interesting of doing and running the competition within search-based software testing is because you can experiment with tool and share a framework where a researcher can actually stand existing tools, and this from both research, academia and the industry. So I will briefly summarize what has been happening in the last years on search-based software testing, and then I will go on what is news for this year. So as you can see from this table, in the past, from early years, the competition evolved over the time. There has been updated tool for computing the coverage, mutation analysis. The number of actually classes selected in average were almost very close, usually between 50 or let's say 60 to 77. But number of projects tend to be diversified and recently there have been more projects and more diversified set of project library. So that gives a lot of an overview how stable the tool are. And typically the number of tools participating was very high in the beginning, and there was then reached a certain stability over the time. And what really changed in the infrastructure was that the tool for comparing the results evolved with Docker in the last 2 years, which make the Java infrastructure more stable over the time, also for participants that didn't participate in last year. So what is new this year? This year we decided to change, let's say drastically, the competition. That there are 2 aspects that the competition could benefit from. first considering different languages or considering different domains. We find out that doing both of the two changes this year would have been a lot of work. So what we decided to do is to keep the Java tool competition, which has been quite known and successful in the past. And we decided to add the Cyberphysics System competition. As you have seen already in previous presentation, the Cyberphysics System competition is based on BMG, which is simulation for environments for self-driving cars. And this to give the opportunity to researchers that are interested also to investigate in this domain new tools. So this is maybe mainly the main things. As good outcome of that means that more people were excited about participating in the competition. This reached probably the most participated competition ever so far, with 10 tools, like 4 from the Cyberphysics System competition, 4 from the Java competition, which we expect to be more broad for the future. What will be from now on? So from now on, I want to say that, repeat that we have 2 competitions that's been run this year. And the way we divide ourselves is me and Fiorella Zambit from University of Sagno, we decide to run the traditional Java competition, while from the other side, Alessio, Gambi, Vincenzo run the Cyberphysics System competition. So this like separation of responsibility allowed us to, I think, having a reasonable good support to the participants of the competition, as well as a good framework to dealing with during the context. So I will focus on a bit on the results, on more in deep down on what happened in the Java tool competition. Then I will be back to Alessio and Vincenzo to give them time to focus on what happened in the Cyberphysics System competition with BMG as core environment. Well, as you have already heard before, the tool competition use a Docker container infrastructure to run the tools. Essentially speaking, the Docker infrastructure takes as input a set of class to under test, and as input a given time budget. So then typical tools, for example, tools like Rundup that are in the context of our competitions is the baseline, can be integrated using runtool script, which is the main sort of API to use the integrate tool via infrastructure, where actually test case then can be actually generated. Of course, the infrastructure is meant to be very generic so that any other tool can be easily integrated and run and even compared. So once a tool is actually integrated with what runtool provide in the JUnit infrastructure, then test cases that are actually generated are filtered out by considering flaky testing, the flakiness of the test, and the surviving test case then are analyzed in terms of different criteria. For example, using with Jaeuk the coverage of the resulting test cases, and metrics are computed on top of this. So to probably give an overview how things are computed, it's a bit more than just simple coverage. The final score that is used to evaluate tools consider different sub-scores. The first score, like the coverage score, considering statement coverage, branch coverage, and strong commutation. So this is the first score that is computed, and then basically the score that is built on top of this initial score try to also consider, taking into account also the time needed to generate the test cases, so that not only the coverage is considered in the evaluation of tools, but also time is required to generate the actual test cases given a certain time budget. And finally, the score also gives a sort of a penalty to the tool that actually do not generate test cases for given project. So even though one tool tend to be more for example, generate less test cases, or sorry, to use less time to generate test cases, and high coverage could be penalized if it does not regenerate many test cases in the selected projects. So from you that probably you do not participate in competition to run the infrastructure, you can actually go in this GitHub repository, and from there you can actually follow all instruction for downloading the Docker container or running Docker container and generating test cases. That's, I think, is quite a good reference for it. For what was the benchmark of this year? So typically to select projects, we go in via certain steps, certain selection criteria. The first is we go for selecting repository on GitHub, so that are publicly available. Then we select projects that are built via Maven or Gradle, and that contain JUnit for writing test suites. The 6 projects we selected this year, as for previous years, still keep some projects that have been considered in the previous edition, for example, Wava, Sieta, and Okio, or Spoon. But then other projects have been added to the list, like JSON and Weka, to create a certain diversity, to see if still the new tools or the previous tool are still reliable in the new selected classes. So typically, what we decide then to run the competition, depending on the number of participants, is the time budget. This year we select, since we had a lot of tools, we decided to not have, like, for example, 3 time budgets we wanted to have in the beginning, and one very small to see if there are tools capable to generate test cases with a very small time budget, and one a bit more a bit bigger to see how tools perform when more time budget is given to the tool. We selected a radical higher number of classes, and we want to see to what extent tools were able actually to generate test cases. So that was intentional. And as previous year, we ran at least 10 repetitions. So test cases that have been generated by the available tools from the participants have been generated 10 times to see and the reliability of the test cases that are generated for each of the selected classes. So the environment, of course, was the Docker container, and actually the results in terms of the score that has been achieved by the different tools has been compared using statistical analysis, as was previous year, the Friedemann test and post-hoc Kohner test. So as I've anticipated, for you that you are probably early, the first time the competition has a certain baseline, which is random. This baseline is based on random test case generation. Of course, these have been compared this year with different tools from the participants of the competition. We had 2 tools from basically the University of Passau, EvoSuite and EvoSuite DSA, which is an extension of EvoSuite, which is based on symbolic execution. I try to combine what EvoSuite does with evolutionary algorithms, with dynamic execution to optimize branch coverage. You will learn more about this by the authors of the tool. And then we got 2 tools, actually quite exciting news from this year from industry, Multibot and Kex. Both of them are similar to some extent, since they use both symbolic execution and satisfiability modulo theory. What makes them different is what actually they try to do. For example, Multibot try to identify execution path and then identify what inputs to cover the various constraints of the code exercised, while Kex use the concept of control flow graph. In principle, it's quite good news that this year we got also industrial tools for the competition. So I will briefly summarize the results so that also Alessio and Vincenzo will have more time, to give them more time actually to describe the new version of the competition, considering also PMG. But the main results were quite consistent if you consider line coverage among the tools, line coverage and branch coverage. So we have tools having similar trends when considering different coverage criteria, so consider line coverage, branch coverage. And I have to say also very consistent when looking at mutant coverage. What we also try to see what actually changed comparing different time budget, like, while going beyond 2 minutes. So we try to experiment what happens to like industrial tools, for example, UTBot compared to EvoSuite, where the one performing more with higher budget, when the budget is like reach 5 minutes. As you can see, there is a lot of predominance of EvoSuite, and actually the tools actually were performing in like in order in first, second, the third level ways. So as I have to say, for previous year, EvoSuite like demonstrate to be the best tool of the competition as for last years, but Tutibox and Kex demonstrated to be very complementary in the way they are executed and the methodology. So it will be probably for maybe also interesting not to see how statically the tool performs in covering class, but actually if the various tools are covering different type of classes or in terms of complexity and the generated inputs, which is something that we could go for next year. So what we have learned actually with the running many more tools than actually previous year in the competition and running different tools also from industry is that there are some bugs that actually we need to, or we are looking for to fix in the infrastructure. Some of them concern actually the way the results can be executed or for comparing results. Some others concern also the way actually we parallelize the execution, so to make it a bit faster to run for more demanding tools. So that's one thing that we try to target for next year. So the other things that we want to like sort of reflect is that using Dockers or Dockerized infrastructure simplified a lot not only the evaluation procedure, but also the participation of people in the competition. And we had a lot of people coming from academia and industry. That's probably a good lesson learned we have. So if there is an infrastructure that need to be delivered, probably having containerized version can help to participate. So what we want to do next for next year, for example, what concern in the Java tool competition, for sure, as we mentioned, further improve usability, for example, facilitated setup and evaluation. The evaluation and setup, we would like to make it configurable so that it's possible to configure at previous stages what would be the criteria used for the configuration, which now it's pretty static. I would say you run the pipeline and the relevant scripts and a report is generated, but probably having the possibility to tune the parameter for the evaluation would be quite relevant. Also updated documentation, so sort of when those changes are basically performed, make it available to the users, find ways to actually play with those configuration parameters. Also, the idea is that to have like also facility that helps to storage version results from previous years. This year we had test cases that were like generate data that were gigantic. Like to generate test cases, it was using a lot of gig of memory, and so we were not really able to share the results of all the results that are being produced by all tools. That's something that we need to think or reflect more for a future year. What we expect to do for next year edition concerned program languages is extend the Java tool competition, like sort of program language competition, where we have not only Java, but we have, as probably have been discussed before, Python as a new language to experiment in the infrastructure. So we will have infrastructure that are able to run other languages. Next year, we want to start with Python. And of course, more tools. We wish to have more tools from industry, especially, but also from academic colleagues, and more a pipeline is able to cover more classes from the experimented projects. So with this, I think I was able to summarize most of what happened in the Java tool competition. So I will give my token to Alessio and Vincenzo Gambi, so we'll stop sharing the screen so that they can proceed with the presentation.
Okay, as said by Sebastiano, before this year, we wanted to spice up the SBST tool competition by adding a brand new challenge along with the traditional and successful Java tool competition. With Alessio and with the support of BeamNG, we added the challenge of testing cyber physical systems, and in particular, self-driving cars. This self-driving cars, since I was a kid, were a dream, since I always imagined these cars able to drive autonomously and communicate with the driver. And today we can see things like a supercar or Herbie in the real streets, and it's cool. But the road to Optimus Prime is still long, but I guess we are on the right track. But this, on a more serious note, those are systems that are life critical. So a failure may endanger the human lives and can have deadly consequences. So the dream can be easily transformed into a nightmare. We, as software testers, have to assess the quality of these software systems, but it's not that easy to do that on road, since this is impractical and also dangerous. I would never drive on a road where I know there is an half-tested self-driving car driving on it. And also it's kind of incomplete test you can do on real roads, since I don't know how many of you can control the weather conditions. But luckily, these software systems, the real ones, the ones that are then deployed on the real cars, can be already simulated in virtual environments, thanks to driving simulators. And this is where we share some common ground with the gaming industry, because we both want to develop realistic simulations. And both critics and gamers are really happy about BeamNG because of its accurate and realistic physics engine. You should see the YouTube videos in which people have fun crashing the cars. Those cars are very realistic. I can imagine why they are having so much fun. But besides that, as we have seen in the tutorial presented by Alessio and Pascal and Mark, BeamNG supports also us researchers by providing APIs and the vehicle state and simulation data, and it allows us to develop test input generators. A self-driving car can have many driving assist systems. One of them, the one on which we focus in this competition, is the lane keeping assist system that helps the drivers to keep the lane by warning them or even changing the steering angle in order to keep the lane and not going astray. But what is a test case? What are we asking to the participants to our competitions? we wanted to have as test case a driving task in a virtual scenario. You can see it on the right. And to make it is as simple as possible, we asked the competitors to provide us sequences of bidimensional points, as you can see here on the left. And our infrastructure took care of transforming them in a curve that represents the center line of a two-lane road on which the car should drive on the right lane from the first point to the last point. And in this case, in this context, what is a failure instead? A failure is, for a lane keeping as a system, is simply when a car doesn't keep the lane. And we choose to adopt the naming proposed by Alessio, Gordon, and Mark, and we call them out-of-bound episodes. Thanks to the simulation environment, we got to know what was at each time step the state of the vehicle and its position. So we can check what is the bounding box of the car and its intersection with the lane the car should keep. And we defined a failure, an out-of-bound episode, when the percentage of the car outside the lane was above a certain threshold that we can tune in order to detect failures with different severity. So this year we developed this brand new infrastructure, and it was exciting to do that, also because the participants really got involved in the development. They sent us a lot of issues and a lot of advice. Our infrastructure should be configurable. So we can configure the time budget for the test input generators, the maximum speed in which the agent can drive in the road, the size of the map in which the road is defined, and the tolerance of the out-of-bound episode. But most importantly, this infrastructure, our code pipeline, should allow to easily plug in the different test generators to the competitors and communicate with the driving simulator. So the tools produce their sequence of bidimensional points that are translated by our code pipeline in test scenarios that are simulated in the BeamNG driving simulator. That then returns to our code pipeline the simulation data at each time step. That is the vehicle state, but also the state of the environment. We wrap all this information and we provide a simulation report to the tools that can perform their computation and compute, as an example, their fitness function based on the feedback of the simulator. At the end of the run, we provide the participants with the results of the run of their test input generator. The metrics we used to evaluate the test input generators are different, and the first one was the number of out-of-bound episodes detected by the test input generator. That is simply the number of generated test cases that were able to trigger a failure, a car going out of the road. We can see in this example that this simple metric, as I was mentioning before to Shin too, has some shortcoming. As an example, the first and the second test case are very similar among them, and both produce a failure in the total count of failures. Even if they are very similar, they still count as different failures. So the number of out-of-bound episodes is 3. But to solve this shortcoming of this metric, we proposed also another metric, that is the failure sparseness, that is able to compute the diversity among the detected failures. If you remember what Gordon said at the beginning during his keynote, it's very difficult to compute diversity with tests of non-fixed size, and this is our case. Therefore, we limited the computation of the distance to the road sectors relevant to the failure. This means that we took for each failure the road segment before it, because it determined the state of the car, and the road segment after the failure, because we wanted to take into account also the trajectory planned by the car. You can see as an example that the first and the second road, even if they are different, have a failure that happen in a very similar road sector, as you can see. And the third metric was about the efficiency and the effectiveness of the tools. We wanted to compute the number of tests generating within the time budget and how many of them were valid. We had a not valid road when it self-intersected, contained overly sharp turns, because then it was an easy win, of course. And finally, it should be fully contained in the specified map. So test case should respect this constraint. The test subject we considered was the BeamNG AI, that is the driving agent shipped within the BeamNG simulator. And we used, for this context, the default configuration, that is the one that we proposed to the participant during the development of their test input generator, that had 5 hours of search budget, no maximum speed set, and an OB tolerance of 0.95. And also, we applied another configuration that was not disclosed to the participants. It had less time to generate and simulate the tests, the same map size, a fixed maximum speed, so the agent was more prudent, a more sensitive out-of-bound tolerance. We had a lot of competitors this year, and we are very happy with that. And they are deeper, that is the fruit of an international work between Iran and Sweden. Then from the east, there is Frenetic from the National Institute of Informatics of Tokyo. Then there is a family feud between Gab Explorer and Gab Exploit that carry on the eternal fight between exploration and exploitation. And then we get to cover also North America with Sword from Montreal. Let's see, move on. We got that for the number of out-of-bound episodes, both Frenetic and Gab Exploit got to produce 10 times more out-of-bound episodes than the other participants. We can see that Gab Exploit reached the maximum number of failures in some rounds, but also less failures in some other rounds. Instead, Frenetic in both configurations was more consistent. As regards the failure sparseness, we can see that Frenetic was successful in both configurations to produce diverse failure. And finally, as regards the efficiency and the effectiveness, we can see that Frenetic produced in both configurations more test cases, while Deeper produced more valid test cases, whereas SWOT had the best ratio between generated test cases and valid test cases. As we can see, each tool stands out from a certain perspective. And so I want to ask to Alessio, what did we learn from this competition?
Thanks. I think this is still your slide. So what we learned, can you go to the next slide, please? Is
yes.
That it's not, so the first lesson that we learned, that this is trivial, is don't drink and drive, since we are speaking about cars that leave the road and there is a nice view here. No, joking aside, it's that we kind of had to compromise on how to evaluate these tools and what type of test subjects to use as the very first lesson learned, because I will speak this about later, that as you may see, there are many facets that we can consider while comparing the tools, and it's not easy to decide which one is better than the others. Another important lesson that we learn is how it's important to strive for an intuitive and open infrastructure to enable the participants, the competitors, to focus exactly on the job that they are supposed to do, generate test cases. Try to hide as much as possible the complexity and the engineering effort that Gordon mentioned this morning to enable the generation of tests. So that's why Vincenzo, myself, with the support of the others, try to make this competition and the interface to use it as simple as possible. Another important lesson that also Vincenzo mentioned before is that it's really important to build a community and try to be inclusive and involve the participants and the interest parties in developing such pipelines, because this is still open field, in my opinion, and there is a lot of feedbacks that may come from different sources, and then we got a lot of nice feedbacks and suggestions to improve from our participants. And this is, I think it's something important also to keep in mind for the future. And in this effort for building a community, go back.
Okay.
You can notice the links because you can join us on a discussion on this Slack channel, and you are always free to create pull requests, feature requests, and extend the pipeline. It's open for a reason, so that's a way to support community effort by open source projects. So for the future, this was the first edition. So as I said, we had to make compromises on the test subjects, the amount of experiments, the type of tests that we can run, because we were not sure what will have be the results of this investigation. So for this time, we kept things simple and limited. But for the future, what we would like to do is to introduce more test subjects, or different test subjects at least. So here we use this internal BeamNG AI, which is basically trajectory planner, something a bit more than that. But our initial hope was to involve and use computer vision-based system, for example, based on deep networks and such. And this is what we plan to do for next edition, to have more, let's say, realistic test subjects. In doing so, and this is also a reason why we haven't done it in the past, in this edition, is that there may be challenges to solve that are related on how to configure those deep learning systems. So deep learning systems and their quality depends very much on the training data that are used in training them. And we learned the hard way, me and Vincenzo, that test generators that use very different representation of the inputs, despite they generate nodes in the end, may get the job either easier or harder, depending on how the test subject was trained. So if you train a test subject with roads that have feature very different than the one that you generate, then it's easy to make it fail simply because it was not trained for that. So for the next edition, we are trying to understand how we can avoid introducing bias by basically asking participants to provide us a reference, let's say, set of inputs that can be used to train these test subjects, and then put them everything together for some sort of all test subject to run in the competition. Since someone asked in our during the development, it would be also nice to extend a bit the space of search. So now we have flat roads that are specified as sequence in bidimensional spaces, but as we saw this morning in the tutorial, the simulations may allow very different and more rich tests. So we are also considering whether it makes sense to let tools create three-dimensional roads that can be steep, or changing environmental conditions, changing the weather, lightning, or even introducing obstacles. So basically evolving, creating more challenging scenarios. One last thing, because before concluding, we are also considering, and for this we will also would like to hear your feedback, some sort of open submission type of competition. And the reason is that evaluating these tools, as you may see, takes a lot of time. It takes hours to run one experiment, and we want to achieve statistical significance. So we need to run the experiments many times, that multiplied by many tools makes a big number, and then we have a very limited time. So we would like to, push participants to submit their tool sooner, such that they can be evaluated over a long period of time. That also some model that we are considering. Next slide. This concludes this part on Vincenzo. Can you switch the slide? Conclude this part on this new track of the competition, and it's also a farewell from me and Sebastiano. And since we are all Italian, we should say an arrivederci, because as you may know, the tool competition is chaired by taking turns. So every year someone comes in and someone goes out. This time it's my turn and Sebastiano to go out.
That we join together.
This means that there are 2 free spots there for you to volunteer to join the effort. So the plan is, as Sebastiano told, to include Python on top of Java and the tool competition, and you can bring in your own ideas if you volunteer for this position. So they are looking for you. Please apply. It is a great, it's kind of funny and a great experience. So if you want to try, feel free to contact them.
Yes, I will also add that, since there are Fiorella and Vincenzo late, both competition, you will not really start like not knowing anything. You will be supported by them, but then will be free to add new stuff like the Python, support the Python competition for next year. So, okay. For applications.
Yeah, I think we are running out of time, so that this basically closes this presentation. Yes. And then I would like to let the speakers and the tool competitors to take the stage.
The next is EvoShoot at SBST 21st. So I think there are some of several of the others. So EvoShoot, I don't know who will be the leading, but suggest to go ahead and sharing the screen, presenting the results of this year.
Yeah, I'll present. Can you see my screen?
Yes.
Okay, great. I'll try and catch up on time since we're behind schedule. And I already stole some of your time in the morning. So I assume at this point, I don't need to say much about what EvoSuite is and how it works, because I showed this already earlier today. So maybe the interesting question is what changed between last year's entrance of the tool competition and this year's entry of EvoSuite? And the answer is not much, because it's pretty much the same configuration. There are no entirely new features we applied, but still, I just had a look at the Git statistics. between the two versions used at the competition last year and this year, there were a substantial number of changes, despite us not implementing any completely new features. Well, so there are some features, which I can briefly mention. For example, we finally upgraded EvoSuite from Java 8 to Java 9 Plus, which was a non-trivial effort because the JVM introduced some breaking changes between 8 and 9. And so anything from 9 onwards now works. And there's some fundamental differences in, for example, up to Java 8, the system class loader was a URL class loader, and you could modify the class path easily. Things like that didn't work from Java 9 onwards. This now works in EvoSuite. It's not relevant for the competition because I think we use Java 8 here, but it is one of the things that has changed since last year. We have added JUnit 5 support, which again is tricky because some things have changed that EvoSuite relied on. We have got Docker support out of the box. Thank you very much, Mitchell, for that. Maybe one difference between the two versions back then and now is that Dynamosa is now the default algorithm. We already used Dynamosa as the algorithm in last year's competition, but now it's on by default, even if you download and run EvoSuite. And besides that, the changes are essentially loads of major refactorings. For example, the implementation is super messy in that we originally built EvoSuite to compare test suite chromosomes with test case chromosomes. And then that works nicely as long as you have a nice abstraction of what a chromosome is and what the search does with it from all the other messy stuff I showed you this morning. But over the years, many domain-specific optimizations were implemented that depended on this either being a test case or this being a test chromosome. And so it was quite a big effort to cleanly separate and refactor this. And now it should no longer happen, for example, as it did last year when you run a test suite and you run EvoSuite with Dynamosa and have the wrong strategy on things would explode. That should no longer happen. The source code quality has improved quite a lot. So the first two authors of the competition paper, Sebastian and Sebastian, they rewrote large parts of, and all the cases where we had raw types and casts and so on, they're all gone. There's ongoing refactorings around the treatment of generic classes and plenty of bug fixes. So the actual configuration we used is essentially the default parameters, except for a couple of tweaks. And I just had a look at the version of the competition front end we used. So if in a future competition you want to use a version of EvoSuite, the actual run tool for EvoSuite is available. And essentially to configure it, you have to pass in a number of options. And maybe just to point out some that differ in how I would use EvoSuite to generate tests in a regular case and how we use it in the competition. Maybe to think about also in terms of how the scores are calculated. So for example, usually we don't test deprecated code, but deprecated code is counted for coverage. So when we run it for the competition, we activate deprecated code. Usually EvoSuite spends quite a lot of time on minimizing the assertions it generates, right? If otherwise you get too many assertions, tests don't look pretty. But it better spend time to do the search and increase coverage rather than minimizing the assertions. So we just keep all of them. Don't spend time on this. We do minimize the tests though, because the main reason for doing this, even though this takes some time, is that this reduces the chances of introducing flaky tests. The longer the tests are, the higher the probability of there somewhere being flakiness or some other issue. So we minimize it, not because we like minimize tests, but because we want to reduce the chances of something going wrong. We do deactivate some of the other optimizations. Inlining of variables, for example, doesn't make a difference for the competition. We don't need to write out statistics. And everything else down here is essentially tweaking and tuning EvoSuite to spend how it wants to spend the time given in the scope of the competition. And so to explain this, I just very briefly go back to this slide I showed, or this picture I showed earlier. I said this is the evolutionary search, and then there's loads of things happening around this. So initially EvoSuite does the static analysis where it analyzes the class path, extracts all the classes, and just uses reflection to find out the methods and inheritance tree and whatnot. then the actual tests written at the end are not the result of the search, like the best individual of the last population, but the contents of some sort of archive. From that archive, we select tests, we minimize them, inline them, generate assertions. Then we write each test to disk and try to compile it to see if there's compile errors. They do happen. Then we run the tests to see if they're flaky. Then finally, we write all the non-flaky and compiling tests to test suite, and we write some statistics. So this is what EvoSuite in general does. And each of these steps requires some time. Now, if you specify a time parameter for EvoSuite, this only refers to the actual search and not all the other phases. But in the competition, we get an overall time. So we have to somehow spend it on everything else. So if you look into the run tool that is used to run EvoSuite in the competition, there's this somewhat non-intuitive snippet of code that has evolved over several iterations of the competition, where we've somehow determined that we want to spend half the time given by the tool competition for the search, and the other half is split across the other steps of initialization, minimization, assertion generation, with some parameters that we have tuned over time. And this turns out to work fairly well given an overall search budget. Okay, but is it overfitting for the competition? Probably. So here's summarizing the results of the competition. We've already seen the statistics, so I don't need to talk much about this. I just want to point out two things that might be interesting. The first one is, so this is the, what is this, 30 seconds, 120 seconds, and 300 seconds. And you would expect that coverage increases, but actually it doesn't. For the 300 seconds, the coverage is lower than for the other search budgets. That's maybe a bit surprising. Where's that? That's mainly looking at the log files, because running EvoSuite longer increased the chances of something bad happening. And in most cases, in the scope of the competition, what happened was that EvoSuite ran out of memory. And then it crashed, and so no tests were produced. And the second thing that might be of interest in this plot is that the mutation scores are substantially lower than the coverage scores. And this is because on the one hand, there's flakiness. So you can have a test with high coverage, and then if there's something wrong, some sort of flakiness, that will lead to a 0 mutation score. And the other thing is we had quite a number of cases where EvoSuite's instrumentations, EvoSuite heavily instruments the code in order to, for example, to avoid flakiness as much as possible. But the PIT mutation tool used in the competition also instruments the code. And so there are certain scenarios where these two instrumentations are not compatible with each other. And then that results in an error and a mutation score of 0. And maybe one last point, these data points and the scores and so on were calculated on only a subset of the classes used. Right? As I understand, these are the classes in which all the tools produced test suites. And for some reason, this happens to be mainly classes from Guava, which is kind of my nightmare project in terms of applying EvoSuite, because Guava makes very heavy use of Java generics. And this is something I mentioned earlier today. It's you can see the nice and red and terrible source code in EvoSuite and how we deal with generics, not very well at all. So we even have dozens of test cases extracted from Guava in order to deal with all the magic that happens in there. We have generic types for classes, but then override them with other generic types and generic methods that somehow extend generic interfaces, which are again recursive, and then EvoSuite at some point just isn't robust enough to handle this properly. So I'm happy it worked as well as it did in Guava, but if at some point you want to fix something in EvoSuite, please have a look at how it deals with generics. Okay, and that's essentially all I have to say about EvoSuite's competition entry. Thanks to everyone who contributed.
So I guess there will be people having questions. Great presentation, by the way, Gordon, and for helping us out. You know, we are a community, so I guess we have to try to go in the right direction. You have the experience for going ahead. There is any question for Gordon before we go for the next session, or?
I do have one question.
Internal.
Yeah. Can I, or there's someone else?
No, go ahead. I mean,
okay,
I
so,
think people will.
Yeah, I will take one of the ball that Gordon threw by pointing out that its configuration may be tailored to the competition. And the question is the following. We should, as a community or as a tool competition, strive to evaluate the tests also along other metrics. You know, because test, there's coverage, there's full funding abilities, but what about complexity? Size of the test, readability, even naming of the test may matter in some cases, right? Do you think that there should be an extra effort in extending, you know, the competition towards this end?
Isn't the size included in the score? I don't know. I think at some point it was included in the score. Definitely, I think it would. So if I can just show this again. A lot of what's on this is code that is intended to make the tests look pretty. And so obviously, I think it would be, since it is so important to the users that the tests look nice, it would be valuable if also the competition somehow takes this into account. But it's not so easy to measure.
Yes.
How do you quantify how readable the tests are? And the complexity probably is, I mean, there's no conditionals in the test cases. So what would you want to measure in terms of complexity, except for the number of statements, maybe? So if you have any ideas of how to take into account other factors, I think that would be a very good idea. I don't know what specifically to suggest, though.
Thanks.
Yeah, that was a good question. I guess you have done a lot of work, Gordon, on generating meaningful identifiers. I've seen work from you, and maybe there could be some metrics, because there are metrics, for example, to judge the quality of variables used. Maybe there could be a direction, or you think that should go beyond of that? How could we approach the problem? I guess it's difficult to come up with metrics. Maybe there are directions that are viable. We can go there, and maybe others more difficult. What do you think?
What I think about?
So basically, I've seen previous work from you where you generate meaningful names for test method, and that's one way, for example, to make test cases generated more easy to be understood by humans, by developers, basically. And basically tools that don't do that could be compared, for example. But there are other aspects that could improve the way they're generated or can be compared. But of course, just referring to your work.
So the thing is that, for example, EvoSuite tries to generate meaningful names for tests, which is challenging because the tests usually aren't meaningful. But it doesn't do so by quantifying how meaningful they are. It just tries to, by construction, come up with a name that describes what's there. Right? So if you want to judge whether that is meaningful or not, you could ask a person if they think it is meaningful. I mean, probably somebody could come up with some deep neural network to do that job.
Mm-hmm.
But right now, I don't think there is a suitable metric.
Yeah. So essentially, or other involving developers, or rather try to find proxies for that, like based on neural network. That's a good idea. I don't know if there are other questions, but thanks a lot for inputs to us for next year competition and for the keynote of this morning. Maybe it's time to give the time for the next talk, which is from actually EvoSuite DSA, so it's your team, but I guess Ignacio will present it. Have you seen it? Here is online.
Oh, yes. Hello. Can you hear me?
Great.
Okay, awesome. Let me share my screen.
Yes. Great. Thank you.
Presentation. Sure. Can you see my screen?
Yes.
Okay, great. Well, hello, everyone. I'm Ignacio Lebrero. I work in EvoSuite DSC with Juan Paulo Gagliotti at the University of Buenos Aires in Argentina. Well, I think that for the explanation of the competition, Sebastián already did a few explanations of this, so I can skip it. And well, so we were working on the dynamic symbolic execution module of EvoSuit. The dynamic symbolic execution was there for some time. It was a bit immature in the sense of which features it has implemented, and it was mainly used for enhancing the search-based execution that the tool previously had. In one of the later works, we basically decouple it from the genetic framework that is built, and we created a pure concolic module to have just a dynamic symbolic execution module on the tool. The tool mainly works at a Java bytecode level, which I think Gordon previously explained this. You only need the jar file with the compiled dependencies on it to run the tool. And the good thing about having the dynamic symbolic execution module inside of EvoSuit is that EvoSuit is very matured in a lot of on the post-processing and pre-processing of the test suite itself. So we can reuse that on top of dynamic symbolic execution. So basically for this, Gordon explained a little bit of this. First, there is a static analysis phase. We mainly use it from the contour flow graph to calculate what is the code coverage of the test suite that we are generating. And then on the test case generation side, now you can use both or the search-based execution or the dynamic symbolic execution separately to generate the test suite. And then in the post-processing stage, one of the things that we used was the test suite minimization for optimizing the test suite that was generated. And we mainly work on the dynamic symbolic execution module. So the high level of the module is pretty standard, actually. On one side, you have an exploration algorithm, which in the current implementation that we have, we're using a generational search, which is exactly the same implementation that Sage has. But the only difference that we use in incremental branch coverage instead of incremental block coverage to decide which is the next test case to execute. This is mainly of how EvoSuit works on the background. And then once a test case is selected, it's sent to the concolic executor section, where we have the symbolic interpreter, and this section instruments using ASM. The good thing about having the symbolic interpreter for the Java bytecode itself is that we can model a lot of the Java features on top of that. We recently added here support for JDK9 and the invoke dynamic instruction. So we are currently supporting partially lambdas and closures as one of these things that we saw that is something that not all the tools support. And then once the execution goes through and the constraints are recollected, that condition goes back to the exploration algorithm, which generates new constraints for unexplored paths. And those constraints got sent to the SMT solver section. We currently support C3 and CBC4. And once those solutions are retrieved from the SMT solver, they are sent to the exploration algorithm back for further exploration. So what the engine can reason about currently? We can reason about currently about primitive types. We mainly model integers on the SMT solver side for the usual integer types. And we're using reals for both doubles and floats. And on the heap, we are currently modeling both strings and arrays. For arrays, we have two implementations, actually. We're using arrays theory on one side. This is the classical arrays theory on the SMT library. And we have another one that is called lazy variables, where we basically see the array as a bag of independent variables. So each time the symbolic execution finds a usage of one of the array elements, it just sees it as a primitive type, and it models it as an interpreted function on the SMT side. The only drawback of the tool itself is that we are still not supporting references, which is kind of a huge drawback because one of the main Java language uses is objects. So this actually lowers a lot the coverage that the tool currently generates. So for the results of the competition, we had some interesting result is that we have exactly the same amount of coverage for the 3-time benchmarks, which it's interesting because it may suggest that we have a small exploration space, given the actual things that the tool can reason about, which means that if we don't reason about objects, as is one of the most used things in the Java, the amount of things that we can explore is quite small. And so given this, we were expecting actually that the tool had lower coverage as a result, but we wanted to see how was the maturity of the engine given the subject of their test from the competition. So taking a little bit at the results, we saw that there were a few cases where we had zero line and branch coverage. So running this locally, we saw that these executions actually generated some tests, but they were removed in the post-processing stage of EvoSuit, like in the minimization and other stuff. So we still need to further investigate why that was removed, because those tests generated some amount of coverage. So we assume that they were supposed to be there at the end. And we found one bug on collect ordering. We didn't investigate that a lot, but it may be related to what Gordon said previously about generics in general. So after that, we said, okay, let's compare it against the other tools to see how we perform in comparison. And we took 3 different scenarios that we wanted just to check. We saw the cases where we have 0 line and branch coverage, the cases where we actually generated some line coverage, but we didn't generate the branch coverage, and the cases with the tool performed the best, which are hash code, hashing, and media type, that we generate the best coverage amongst the other classes. So taking a look at this, if we see the line coverage comparison, on the left side, we have the cases where we didn't generate line coverage or branch coverage. In the center, we have the cases where we generated some line coverage, but we didn't generate any branch coverage. And on the right side, we have the cases where we perform the best. So for the cases where we didn't generate any line coverage, we see that the other tools generated some coverage. For example, the gray one is Kex, the orange one is Evosut, and the yellow one is Utibot. They did generate quite a lot of coverage in a few classes, and they struggle in another ones like finalizable reference queue. But in the one where we actually generated some line coverage, we see that in these cases, at least, we performed quite well compared to the other tools. We had almost the same performance as Kex in free-range map. We actually outperformed the Kex in escapers, and we performed the same or better than Kex and the other ones. And Utibot, in these cases, at least, we didn't see any results. And on the cases where we performed pretty well, we actually did quite a good job. We almost had the same results as Kex on the hash code, and we outperformed in hashing and even in media type for these cases. And then if we look at the branch coverage of that, kind of the results are quite expected, seeing what line coverage was. But on the cases where we didn't generate any branch coverage, we see that there were quite a good coverage here and here. But given that we didn't know what was the coverage of the tests that got removed in these scenarios, we're not sure how Evosut should have been, Evosut DSC should have performed in these cases. And in the cases where we didn't have branch coverage, we see that the tools actually struggled a little bit in these scenarios, because even though Utibot did pretty well here, it struggled a little bit here, and neither Kex or Utibot had results on these other 3 classes. And on the cases where we performed the best, we see that we actually outperformed in hash code, and we did a pretty good job in hashing, even though Kex has almost double the coverage as us. And in media type, we did quite the best compared to the other ones. These classes, at least I don't know what's hash code, it's very heavily focused on the parameters are strings and arrays. So it seems that on the things that we currently have modeled in the tool, we're performing pretty well. But there are a lot of parameters on most of these classes that are objects. And those parameters we only had null for the test case. So we cannot generate any other test case that is just passing null. So we are losing a lot of exploration in that scenario. Other drawback of the technique is that we can only use static methods. So for non-static methods, we cannot generate any test currently. And that is another huge drawback that the tool has. So these results are actually quite good results, given that if these classes only needs things that we have modeled and we are performing a little bit, we could be a bit happy that the things that we're doing seems that we're currently doing pretty well. So to close up a little bit, for what we saw, most of the classes had a lot of objects as parameters, and the tool doesn't support that. So that suggests that if we actually implement references support on the engine itself, it will hugely improve the performance of it, as there is like a huge exploration space that we're not actually seeing, which was something that we were expecting, but it's interesting to see the results and comparing it with other tools. We saw, well, that a few tests were being removed, so we need to investigate a little bit about more that. We found one bug on the engine, and our cases, as we saw before, were a bit competitive, seeing it with the other DSC tools, basing that we don't have any reference support. We are not doing the best, even though we were expecting it. So we have a positive vision for next year's competition if we manage to implement the things that we saw here, which might be really good to see on the tool for next iterations. Thank you.
Thank you, Ignacio, for a very good presentation. You already have good agenda for next year, I guess. You probably would have a few questions from people here. There is anyone that want to make a question about Evosut DSC? It's very similar to other tools. Maybe you could relate to it. maybe a question. Or...
Yeah, I think there may be some questions that will be repeated for most of these tools.
Yeah. So I don't know if there are questions for other people. I will have a very generic one for you. You sort of DSC sit on top of EvoSuite and with the idea to maximize branch coverage. There's one question is about what is the added computational overhead. When you talk about genetic test, genetic tools, also scalability is quite important if you want to move forward to an industry. According to your experience in running a tool with the class under test in the competition this year, do you think that the computational overhead added by DSC is too high or still manageable to be used in industry, or what's your opinion on that?
On DSC in general, so when you say is work on top of the genetic algorithm, you mean because the tool has two ways of using the symbolic execution engine. It can be used as a standalone dynamic symbolic execution engine, or it can be used to enhance the genetic algorithm.
Let's say, when I talk about scalability, how fast it is, how actually computation expensive in terms of times and memory, do you think that's your tool? Okay. It's like introduce more computation overhead in these two dimensions, one of those? Was just curious to see your feelings.
Okay. For what I've seen at least from the other tools of the competition, and for what I see for the execution of our tool itself, the technique itself is expensive because dynamic symbolic execution takes a lot of time to execute. And for industrial level software, it probably requires a lot of hardware to actually run and create all the tests that you need to see interesting scenarios. But I feel that our tool is way more lightweight in the sense of the memory and computational cost that it has comparing to the other tools. I think, I actually have a really good feeling that if we implement the features that we want to implement, like objects and invariants and stuff like that, we can model on the engine side. The tool can actually perform pretty well in industry level software if we have the computation. Sorry, if we have the hardware that could run it for a reasonable amount of time on this level of software. But yeah, in general, I think that the tool has a really good baseline for working at least for 1 or 2 years from now.
Yeah, the other one, I don't know if there are other questions. It would be like more, I was with, go ahead, Alessio, then I will do it if there is time.
Yeah, it's a short question, I hope. There are some tools like yours that basically would benefit to having probably larger budget, or they work simply having different phases, And my question basically is generic for everybody: is how we should include them to avoid this bias towards algorithms that are just fast. Should be something like a more extended model of this pipeline where we have phases and then we have each budget for each phase. Or it would be better to have simply a separate category. So tools that do not make use of expensive techniques like symbolic execution fit one track or one category. Therefore, we can compare them along some matrix, but other tools that rely on other techniques should be better compared with other things. What's your opinion?
That's a good question. I never thought about something like that. No, I feel that depending on the technique that you're using, like if you're using a white box technique or a black box technique or a gray box technique, that I think that makes a significant difference on the performance of the tool. Because if you're using, for example, a white box tool, that will usually have a lot of computational overhead because you have to analyze a lot of things. While a black box technique, even though it has a lot of computational overhead depending on the model that you're using, maybe can be used. Can we have a few more phases where pre and post processing, because you can distribute that. Yeah, I feel that it might depend on the technique itself that the tool contains. That can be something interesting to analyze in the way that maybe you want to categorize which tools to compete against each other. Because in the scenario, in the analysis that you have to do after on the results, if you don't have in count how the technique itself works, and how that time budget is separated, and you only see the results, you may find these huge differences depending on what the metrics are. Because the metrics can change as well, right? Because For example, if you're measuring the length of the test cases that you have, or the flackiness, or readability, and stuff like that, depending on the technique, you can have really different, how is it called, like flavors of tests that are results, right? Because the techniques themselves generate them differently. So it could be really interesting to do a small study of how those differ to try to understand how to categorize them in different categories.
Okay, thanks, Ignacio, I guess, for answering the question. Actually, it was the same question I wanted to ask you. By the way, thanks a lot again. I think it's good time to give the authors of KEX to join and share the screen, so to present their tool for the composition. I don't know which of the authors are available for presenting it. All right, perfect. So,
okay.
Perfect. Okay, Azad.
Yeah, so hi, my name is Azad, and today I want to talk about our tool KEX and its performance on SBST tool competition. So KEX is a white box test generation tool for JVM platform. It's based on symbolic execution, and it aims to reach a maximal branch coverage during analysis. And KEX currently uses only static analysis to generate test suits, and it uses dynamic information such as traces and instrumentation to guide static analysis. So it's some mixture of methods. And KEX generates JUnit for test suits, and it's currently a research prototype, and we develop it in our laboratory. High-level overview of KEX, it's pretty standard pipeline. We take a set of compiled classes as an input. We build a control flow graph for each method, and then we convert those control flow graphs in our own intermediate representation, which is called predicate state, which is suitable for some transformations and optimizations. And then we use SMT solver to generate the test inputs that reach some interesting points of program under test. And then we convert those test inputs into test suite. Currently, KEX supports several SMT solvers, but we used Z3 in this competition. Now I want to briefly talk about each step of the KEX, and then I will go to discussing the results. So first of all, we, as I said, built a control flow graph for each method of the program. For that, we use our own library called KFG, which is used for instrumentation, some optimization, and transformations that are required during analysis. Then for each basic block of this control flow graph, we built a predicate state. As I said, it's an intermediate representation. We use it to perform some SMT-specific transformations, such as slicing, memory spacing, which is a technique that is used to optimize SMT solving process. And we also use predicate states to do some reification, to add some additional information about intrinsics, some contracts, etc. And then predicate state is converted to SMT formula and sent to solver. And solver gives us an SMT model which describes test inputs. And then KEX uses its own original approach called reanimator that tries to generate a valid action sequence that constructs these test inputs using only public API of an object. So we try to not use reflection to receive more easy to read code. So this is very brief overview of how KEX works. And now I wanted to point out some of the weaknesses of KEX in terms of the competition. First of all, as was mentioned before, it uses symbolic execution, which is very resource intensive. And in case of limited time budget, it's the overhead is very big. Second of all, also because of the time limit in the competition, we decided to work only on a single method level, and the interprocedural analysis is only supported through inlining. So we inline some of the methods to better, so symbolic execution engine can better understand what's happening. And the last weakness is the test generation process. First of all, Reanimator is also based on the symbolic execution, and it takes some time to actually generate test suits, even after we understood what are the test inputs. And second of all, if the inputs are complex or very big, Reanimator sometimes can fail, and we just wasted a lot of time without producing any test. So I want to talk briefly about the results. KEX scored 44.21 points, as you already know, and took 5th place. And the main problem from our point of view is that KEX failed to produce test cases for most of the projects. And I wanted to address both of that issues. First of all, Guava is the only project where KEX was able to generate some test suits, and it reached on average 20% line coverage and 40% brain coverage. And this coverage is still very low, but again, in the limited time budget, it's acceptable, we think. But we still decided to manually analyze the sources of benchmarks to understand why KEX has failed to generate tests in other cases, and found out that KEX and mainly Reanimator is struggling to work with benchmarks where some complex language features are used. For example, abstract classes, reflection, or some static inner classes with a lot of internal structure. And then to understand why KEX failed to generate tests for other 5 projects, we also analyzed them. And we think that main problem is low level of maturity of KEX. And while it's a research prototype, it's the first time we used it like an off-the-shelf tool and tried to give it to other people to actually run, and found out that it was not prepared, and basically on the most of the benchmark it just failed with some errors, and we plan to work on that in the future and be more prepared to the next contests. So overall, all I can say is that KEX can generate a test suite with about 20% of code coverage under 30 seconds, but it still has some implementation issues, and we plan to work on them. That's it. Thank you. I'm ready to answer your questions.
Thanks, Azad, again for a good presentation. There is anyone they want to make a question to Azad? Maybe you, Ignacio. She has a very similar tool in terms of logic and then requirements, comments. Okay, while waiting, if there is anyone want to follow up on you, I would like to bring back a bit of the few things that we discussed before. It's quite interesting. It's quite interesting actually also for the competition. Do you wish to have, as has been mentioned before, to have an adaptive approach, sort of use symbolic execution for few complex classes, and a more lightweight approach? And the other question is more about the time budget. I know that we have probably delivered to symbolic execution tool limited time budget. Maybe you need more, maybe 4 to 5 to 10, maybe with less classes, to see what are the actual benefits of your tool. Do you suggest to us, for example, this second question, to have separate like comparison between symbolic tools, or what are your thoughts?
Yes, I will start with the second question. I thought about like how to properly compare tools that use different methods underneath in such a contest, and I don't know, maybe yes, if there are a lot of enough contesters, maybe it will be very interesting, at least to have like some sub contests. Like we have a main competition with all the tools, and then more close comparison between static, for example, static or symbolic execution based tools, or maybe to perform some additional experiments with increased time budgets. For example, this year we had 30 seconds and 120 seconds. Maybe for symbolic execution tools, we could have also added like 10 minutes, 20 minutes, and etc. just to see what the results would be.
Okay.
Yeah.
Thanks for the answer. Actually, it's something that we are thinking about for next year to sort of, because it would have been unfair at least to have time budget to actually tool actually. I mean, the tool actually require have different requirements. Symbolic,
yeah, it's
the ones based on symbolic require more time resources, and of course.
Yeah, I think it would be interesting to see what results the tools will achieve in the.
What will be the benefit?
Yes.
The wish is that maybe symbolic execution could be used for more complex objects where actually other tool also fails, and we don't know to what extent it's true, and that's be probably one of the key aspects to answer next year.
Yeah.
Anyway, thanks a lot again for your
thank you.
And actually to join, and we hope you join also for next year to continue to evolve this community. That was great to have you on board.
We are planning to keep the contest and apply to it next year. Thank you.
That's great. That's great to hear. Thanks a lot. Okay, so I guess it's time for the authors of Utibot. I see that from the program that there is a video, so probably I don't know if there are the authors presenting or there will be the video that will be shared by Eric.
Hello everyone. Yes, the authors are here. We are glad to participate, and yes, we have recorded the video. And if you could, we would like you to play it back.
Absolutely, I can do that. No worries.
Thanks a lot, Eric.
One moment.
Hello, I'm Dmitry Ivanov, leader of software analysis team in Huawei St. Petersburg Russian Research Institute. We developed a tool called Utibot, and it participated in this year Java unit test tool competition. So Utibot is automatic test generator for Java, which tries to maximize code coverage and minimize user efforts to generate these tests. Basically, Utibot doesn't work with source code, it works with bytecode, and not only with bytecode, it works with special representation of this bytecode called Jimple, which is obtained from bytecode by Suit framework. Jimple is more suitable for us than bytecode because it has only 15 instructions as opposed to more than 200 which are in bytecode. After we get Jimple, we transform it into control flow graph, and then using dynamic symbolic execution, try to generate every path in this control flow graph, which goes to return on to exception. So, and the interesting detail here is path selection, how to select all paths that covers all the instructions in this graph and try to do it in minimum time. First of all, we used heuristics. So we calculate, we have a priority queue of next statement, where should we go during this analysis. And the heuristic says that we should go to the node in this graph that closest to uncovered node, uncovered instruction. After competition, we applied some machine learning techniques to this problem, which makes this path selection even better. And that machine learning helps us to cover all the instructions in minimum time. So during we traverse all the graph, we, as in symbolic execution, we obtain path constraints and keeping symbolic memory. So, and here, when we go to some return or throw statement, we try to solve all this constraint in SMT solver, which is a piece of software that can solve these constraints. And in our case, we use Microsoft Z3, which as a SMT solver. The solution to these constraints are concrete values, and it's called model. And here, some solution that satisfies this constraint is x0 equal to 2 and y0 equals to 4. And this serves us as arguments to test case. And so far so good, but how to deal with non-primitive but reference values? We need to introduce a memory model. So here is an example where we have class A with two fields x and y, and class B, which is inheritor of class A with field z. We encode this class in SMT array theory, and each field we have in a separate array. So for example, ax in one array, a y in one array, and b z in one array. So, and for each object in the system, we have unique address. So for example, here, let's suppose that this code is under address 3, and here for x we have 3, for y we have 2, and what we have for reference value z, we have some new value, which is a new address which is not taken, which is a reference to the next node. And here is x equal to 1, y equal to 1, and as well as that is null, it's equal to 0. So this is basic as a memory model. It helps us to deal with such problem as aliasing. For example, in this case, it's possible here, even if fst.x is not equal to 0, this statement can throw exception. It can throw exception in case of fst equals to SND. So using this array theory, SMT solver will find such a solution when fst equal to SND and throw the exception in this case. This is particularly useful to find real bugs in user software. Also, we encode for every element, we encode possible types. For example, in the first statement of example method, we don't know which type of element variable, so it can be A based on declared type, or it can be B, where B is inheritor of A. And with typecast, we narrow the types. So for type ID inside, we have bit vectors, so we store all the types in bit vectors, and here we narrow the type from bit vector corresponding to A and B to type B. We try to solve everything on solver, but sometimes it's too slow for real programs, and we optimize it solving these type equations in program, not in SMT solver. So we're ready for demo. Here we implemented UTBot as a plugin to IntelliJ IDEA, and let's take methods in this class to generate. This is Guava, by the way, Guava, which is used on competition. And here is a generation going for this class int_math for method we chosen. It will generate tests, and the test with lots of different test cases for each method. So the tests are generated, and we run these tests right now. Okay, test is run, and let's see coverage for the chosen methods. As you can see, the green bar on the left shows that for generated methods, for the methods under test, we have full coverage. So let's see the results of the contest. For branch coverage, we have average is around 30 on 16 seconds and around 34 on 120 and 300 seconds. And for mutants coverage, it's more than 40% in average. So we think that this is quite good because it's only 6 months. Our tool is developed only for 6 months, and this is just the beginning. And also, we don't use mocks inside. So we honestly look through all the code without substituting some special objects inside. And what we have done with mocks, it's for lots of cases, so we can achieve even 100% of coverage. But for competitions, this is a version of UTBot without mocks, which we just symbolically execute real code. So that's all about UTBot. Thank you for your attention.
Thanks a lot for the presentation, the video recording of the
There you go.
presentation. Thanks, Eric, for ending this. So I guess there are questions that we want to ask to the authors of UTBot. Let's see if there are questions. Okay, so I guess would be, again, we had a really long discussion again, also before previous presentation about the, symbolic versus static analysis tool, like execution, if you want, like more like software efficient. Maybe the others can sort of follow up on their reflection, what could be improved for next year by considering previous discussion. Do you have any thought on that? Sure. I see that the Darsen is here online. I don't know if.
Yeah, I can hear.
Yeah, right. Okay. So my question was, I don't know if you follow up the previous conversation, like actively on KEX or like UTBot, the other tools, but like sorry, in KEX. There was previous discussion about, I know, symbolic execution will be quite expensive, but of course more advanced to generate test cases for more complex objects, and maybe other tools like ATeSS and are more agile and can be actually used, for example, to generate a cover classes that have less like complexity. I don't know what when you analyze your results or your data, what was or your perception, your tool, what actually could be improved considering those aspects?
Well, I believe that there are a lot of challenges, both in the area of genetic algorithms for ATeSS and in the area of symbolic execution. For example, we have mentioned in our presentation that in the version of UTBot for the competition, there was a heuristic-based algorithm for path selection. So this is an algorithm that made some assumptions in order to select the next branches that we want to cover, and we are currently working on the improvements in that area, as we said in the presentation again. And we are trying to apply some machine learning techniques. Also, I believe one of the most heavyweight parts of the symbolic execution is the requests to the SMT solver, which tend to be really difficult in case of large constraint systems. And I like to think that there are a lot of potential improvements and optimizations in the future for that part as well. And I also would like to tell about the code generation part, as I remember that Azat was talking about the challenges of generating code for example, private methods and using reflection. And specifically due to this reason, in the competition, we have used a lot of reflection techniques in order to achieve the better coverage results. But we also have another code generator that does not rely on reflection, on Java reflection, and produces a more human readable code. One other thing is that we specifically for the competition, we have used unsafe. This is a class that allows us to allocate memory as we can do in some languages with memory control, like C++, for example. And this is especially useful because it does, when we allocate memory in this manner, we do not fill the memory with some unnecessary values. It is completely empty, and we can initialize the values as we want them to be. And this allows us to avoid some divergence between the models that we produce and the expected, the generated results in the actual code. So that's about it.
Okay, thanks a lot for the feedback, and we wish to have you also for next year, because I think it's you and as a cakes like from JetBrains and Huawei, introduce really a diverse tool that actually could be interesting to exercise with different time budgets. So that we wish that you are next year we give you the possibility to run with a larger time budget and see actually what is the benefit of your tool. So we really wish that you are also participating next year. We will for sure contact you back close to the deadline next year. At least in the future or the competition.
Yeah, we're looking forward to it, and it was a really great experience. And I believe that indeed the increase in time budget, it may be interesting to test the symbolic engine-based tools on greater time budgets.
Yeah, next year it's one of the things that you want to integrate, not only increase time budget, but also the possibility for those tools, these specific tools on symbolic executor, like the multi-thread, where actually you can execute aspects that could parallelize because they are more heavy computational. But that's something that need to be redesigned a bit in the next year competition. So the new chairs will deal with this decision, but there's something that will be taken into account to give you the chance to show the benefit of your tools.
Yeah, because you know the modern tools tend to rely a lot on parallelization, so that would be a great idea. Thank you.
Thanks a lot again, Arsene, to join for the presentation to answer the question. So I think we can move on now to the actually tools from the Cybersphere system competition. So for maybe it's also good that Alessio or Vincenzo join a bit here, because you know they led that part of the competition. So and we give the time to the Frenetic, the people that developed the Frenetic tool to join the and presenting their work.
Hello, my name is Ezequiel Castellano. Today I'm going to present Frenetic, our work for the SBST competition. To remember a bit, like the idea of the competition was to generate virtual roles to test a lane keeping assistance system. This was in the BMG simulator. A role here was a list of points in the Cartesian, which is basically a list of points like this one that then was interpolated to produce smoother roads that should fit within the map boundaries. The pipeline for the competition was a test generation, that is what we needed to produce, that would generate a third list of points. And then this would be validated after doing some interpolation and executed to by the BMG simulator if this was a valid one. Then like we would have some execution stats and an outcome that would tell us if the test passed, failed, or like has some error. But this means that the simulator failed. What we want to get is like failures, which means that our test produces a failure in the system. A valid road here is a road that is not self-intersecting and doesn't have overly sharp turns, and it's within the map boundaries. So this is what we want to produce. We want to produce this kind of valid test. A failure is defined as an out-of-bounds error, and this means that a certain percentage of the car is outside the lane. For instance, if this percentage will be defined as 90%, having 75% of the car out of the lane would be accepted, would be still a valid result. And if we have 99% of the car outside of the lane, that will be considered as a failure. Another important metric here was the OOB distance, which measures the distance between the center of the lane and the center of mass of the car. And this is what we will use to guide our algorithm to produce tests that fails. So the idea of frenetic is basically to combine how curvatures are represented in Frenet frames with some genetic or evolutionary-like algorithm. The frenetic pipeline is basically the same as before. The only difference is that our generator, instead of producing points, produces curvature values that need to be transformed into points. So this is our representation of a road. These roads needs to be transformed by doing numerical integration of these curvature values. And to do so, we need to set some parameters like the initial orientation, which is fixed, and the arc length and the initial position. And then we can obtain a representation of the road in the Cartesian that this is what we send to the validator or simulator. Genetic algorithms are evolutionary algorithms that are based on generation, and you can define different selection methods or how the test survive. It's a single objective, which is good for exploration and exploitation, but sometimes may be a bit low in diversity if you don't do anything to mitigate how exploitation is done. For instance, in our first intent, we combined how curvature values with genetic algorithms, and we were observing that like many of the tests were actually similar, very similar, like minor modifications of the same test. So that's why we decided to try something a bit different. So the idea of frenetic is not too far from that. Basically, follows the similar ideas of the evolutionary algorithms. That is to have an initial population, then mutate this population, and do crossover among some of the candidates. One minor difference is that our initial generation was fixed to 1 hour because for the competition, because we felt that we need to do so to get at least an initial set of diverse tests. Then we will mutate just good candidates, which means that our candidates that pass a bar that we define, that the minimum OB distance is less than 0.5. And that this test pass or fail, which means that it didn't produce an error in the simulator and that we haven't visited before. And if there is no such a test, like we would just continue doing random generation. After producing a certain amount of tests, we will do crossover among the 20 best candidates, and this will produce 20 children, and then we continue in this loop. What we can observe from this simple comparison is that before we had like a very similar test, and now we have at least more diverse ones, and even though we probably have less amount. So that's why we decided to go with this idea. For the mutations, we use different ones for those tests that like produce a failure and those that pass. These ones aim more to exploit a failure, and this one aims to produce like new modified versions of the test. And to improve diversity, also we decided to stop mutation after a child already produced a failure. And for children of parents that already failed, we decided that those cannot even be mutated. So like basically this is trying to prune the number of tests that the number of similar tests that produce a failure. For crossover, we use very standard operators like chromosome crossover and single point crossover. This one mainly like chooses one curvature value from each of the parents, while single point crossover is taking just the middle point and like swapping the back of each to produce 2 new tests. In order to mitigate these validation requirements, like we chose to reframe the test when it's an out of boundaries. Basically, what we do is like to shift all the points to make it fit, and if this was not possible, we would discard it. And then for self-intersection and overly sharp turns, we didn't do that much. Basically, we restricted the length of the roads, the initial roads, so this doesn't the self-intersection doesn't happen too often. And we bounded the values of the curvature values both globally and with respect to the previous value to limit how curved the road is. And here we could have done a bit more, but yeah, we decided that maybe this was enough. The results of the competition, we felt that they were quite positive. Frenetic was the second in terms of number of out of OB errors, which is pretty good to us. And also it produced like very consistent results. That's why here we gave ourselves maybe half silver, half golden medal. And in terms of sparseness was like the winner, and like this is one of the things we wanted to do. So we were happy about this. Like the results were positive overall. And in all the runs we produced very consistent results. So yeah, we felt that it was positive. But we were also criticized because we produced a lot of invalid tests. We were the winners also in this field. And our defense is that actually we still produce many valid tests. We are the third ones in terms of that. And actually most of the competitors produce the same amount of valid tests. Also, the pipeline was already validating this point. So we felt that maybe there was no need to double check too much. Yeah, if we do it again, like we will be double checking, and we felt, okay, maybe it's not necessary. And generating a test with Frenetic is inexpensive, so like we don't lose much time. So in conclusion, we are happy with the results of the competition. We generated many tests that drove the car out of the lane. And in terms of diversity, we produce a test that is more diverse. The negative aspects are that we have many invalid tests, but yeah, we were a bit lazy here. And another point could be that the selection method that we're using for crossover, it chooses the best one, which may lead to very similar tests in the long term, but this can be improved by changing how the selection method is. So thank you very much. If you have any questions or comments, please let me know.
Thank you for your presentation. I really liked your tool and also the strategy to have diverse failures. And yeah, generating a lot of inputs that that were invalid. Of course, it was a trade-off because the time that you would have used for validating them, then it would have been like wasted on that task, and then you relied on the two competition. Otherwise, it would have been performed 2 times. But have you tried your crossover operator to consider also not only the best individuals, but doing the crossover also with the ones that are not always performing best? Maybe you can enrich your pool of test sets and maybe reaching even better results, or maybe not. Have you ever tried it?
Yeah, that's a good point. Actually, yeah, we haven't tried that, but yeah, that would be a way in which we could improve diversity even more, I think.
And then that's very good. Congratulations also for your interaction with us. It has been very good to work with you. And do you have any suggestions for next year? Would you like to see something new in this infrastructure?
No, I felt like in general the pipeline was good and the competition was interesting. Maybe would like to see more objects or things like, I don't know, as you mentioned, you could add much more things with BMG simulator, and like, it would be nice to explore more complex scenarios, and yeah, that would be nice.
That's okay, Ezequiel. Do we have any other question from the participants?
I've got one, if you don't mind.
Mm-hmm. Yes,
so I was just kind of curious, when you're building a tool like Frenetic, how long does it take from start to finish to, I guess, execute your test suite on a real world simulator?
I mean, for us, it was not too much because the pipeline was already provided. I guess that's the hard part of the work.
Sure.
So yeah, for us, it was you could basically write your algorithm and just run it on it. So not that much.
Okay, that's good. Yeah, thank you.
Thank you.
Thank you. We can go to the next presentation with Florian Kluk from the TU Graz that will present both their approaches called GA Bezier.
So can you hear me?
Yes.
Okay, give me a second. I'm struggling a bit. So here we go. Okay, so yeah, welcome also from my side. My name is Florian Kluk, and in the following minutes, I will present you our contribution, GA Bezier, which we submitted to this year's tool competition. And I did the work together with my colleague Lorenz, and a bit about our background. So we are both part of the Christian Doppler laboratory, where we develop quality assurance methodologies for cyber physical systems at the Institute for Software Technology in Graz, under the supervision of Professor Votava. So I will keep it short here, since we had it covered already in the previous talk, but basically the goal of the competition was to generate valid test input to test a lane keeping assist system. And once generated, the test input should be handed over to the code pipeline, where a virtual road was constructed, validated, and then finally executed in the BeamNG research driving simulator. In the end, we were of course aiming for failing test cases, and those were the ones that resulted in a road geometry that forced the ego vehicle off the lane. So how did such a test case look like in general? So basically a test input is a sequence of points within a 2D squared map of a given size. And the first point defines the ego start position, and the last point defines the ego target location. And the code pipeline then takes the sequence as input and calculates the final road geometry and generates a virtual road that is executable in the simulator. But as I said, before the actual simulation, there is a validity check performed. And if it fails, the test case is considered invalid and therefore also not reported. And what makes a valid test input? A valid test input is one where the resulting road does not intersect or overlap. And furthermore, it must not contain any curves that are too sharp. And it's also not allowed to cross the map boundaries. Regarding the competition evaluation, what we knew from the beginning is that there will be a time budget that is limiting the number of test cases that we can generate and execute during the search. And furthermore, we knew that the reviewers will pay attention to how many tests have been generated in total and how many of those have been valid, invalid, passed, or failed. So let's jump into the details, and that's how we designed our test case generator. So basically, we thought it would be a fun idea to use the concept of Bezier curves for our test case generator. Also, because we had a Python implementation for Bezier construction already available from a previous study, and we wanted to play around with it. I will not go much into detail here, but Bezier curves are constructed based on a number of control points, as you see here, P1, P2, and P3. And the specific location of each control point has a global influence on the curve shape. So we decided to randomly locate 7 control points within the given map to construct various Bezier curves, as you see in the picture below. And finally, from each individual Bezier curve, we obtained a different sequence of 200 row points, forming the input for the code pipeline. After implementing some additional constraints, we hardly generated invalid roads regarding overlapping or map boundary violations. However, we had some issues with roads that had too sharp turns. We tried to solve this problem. I will go later into detail about this. However, it was not that easy for us. But in the end, it worked out quite good for us. And the thing is that Bezier curves alone do not generate challenging roads for the system under test. So we combined it with a genetic algorithm that basically optimizes the location of control points to result in challenging roads. And one set of control points represents then one individual in our seed generation, and we execute them to determine the individual's fitness, and it's determined based on the percentage of how much the ego vehicle crossed the center lane or left the road. And then we assign this as a maximum value as a fitness score to the individual. Once we knew that our approach was generally working, we performed some initial test runs to find the right configuration for the competition. So this was our first configuration A, where we randomly generated a seed population containing 25 individuals, and then continued the search until the time budget was fully consumed of 5,000 seconds. And we carried out 4 runs here in this configuration, and then quickly observed that on the one hand, we have a high number of failing test cases. However, they seem to be all quite the same. So we used the Frechette distance here as measure for similarity between the curves that resulted in failing test cases. It's probably not the best indicator, but it worked quite good for us as a simple indicator. And basically, the lower the value, the higher the similarity between these curves. And completely identical curves have a Frechette distance of 0. So as we see here, we have low values indicating that in all runs, the failing test cases have been more or less the same. So what we did then is we tried a next configuration where we restarted genetic algorithm every time that we observed a failing test case. And then again, we collected data over 4 test runs, and the results indicated that this configuration, on the one hand, shows more diversity, but on the other hand, also a very low number of failing test cases. So it was not that efficient. We furthermore noted that completely restarting the GA and not doing anything else is not very beneficial, because we introduce a high number of invalid test cases again into the seed population. So we tried to solve this in configuration C. And here, once we found a failing test case, we generated a new seed generation, but we performed a validity check on each new individual to avoid invalid test cases. But here the problem was that the validity check was very computational demanding and sometimes got stuck. So we had to increase our time budget to 10,000 seconds and also to decrease the population size to 15. And in the 2 test runs we carried out here, we observed good diversity between failing test cases, but a relatively low number of failing test cases. On the other hand, also a relatively low number of invalid test cases, but on the other side, also a low number of test cases generated in total. So on the one hand, we preferred this configuration, but on the other hand, we were afraid that during the competition, the time budget will be so low that we will not find any test cases at all. So in the limited time, we could not find a configuration that both produced high diversity and high number of failing test cases at the same time. So we implemented 2 versions of the test case generator for this competition, which is GAB exploit, the exploitative configuration A, where we aim to maximize the total numbers of failure exposed, and GAB explore, the exploratory configuration B, where we restart the GA. And during the competition, in the default setup, a 5-hour time budget was given to our tools for the generation and execution. And here, GAB exploit has been very effective, at least, in triggering many out-of-the-bound episodes. However, the spread between runs is large, so it was not very consistent. In one run, we generated around 120 failing test inputs. In another one, we didn't find a single one. And furthermore, the sparseness shows that the failing test cases are very similar. And both the lack of robustness and also the lack of diversity in the failing test cases is not very good in terms of test efficiency. GA Explorer generated a rather low number of failing test inputs in the default setup. I think it was between 1 and 8 in every run. However, the ones they found at least showed some good diversity. And in the SBST setup, both GAB Exploit and GAB Explore achieved again low sparseness within the 2-hour budget. GAB Exploit again showed quite unstable performance, and GAB Explore especially suffered from the lower time budget and hardly found any out of the bounds episode. I think only in 5 of the 10 test runs that were carried out. So a summary for us, it was the first time, and then we implemented everything in a bit of a time pressure, but I want to say that we had great fun and enjoyed doing this. And we want to thank the organizers for this opportunity and also the great support we had during the preparation. I think especially getting to know BeamNG simulator and the whole underlying code pipeline was very interesting for us, and it's probably also very valuable for future research. We can say that our test case generator worked at least and was effective on larger time budget and found a high number of failing test cases. However, to be honest, the low sparseness is definitely an issue for the overall test efficiency and requires improvement. So thank you very much.
Thank you. I really enjoyed your analysis and how much you tried different configuration and you shared it with us. It helps also future research. And we chatted with Alessio about your work, and we saw that while Exploit can find a lot of out-of-bound episodes, Explores reaches a very high diversity. Have you thought about combining them and how to combine the two driving forces?
Yeah, we definitely thought about what we would have done differently if we would have more time, not exactly combining them, but pay more attention to only, or to consider more valid inputs in the seed population from the very beginning, and then maybe also not completely restart the GA, but maybe just swap parts of the population, or work with constraints so that we do not consider any new inputs that do not improve the sparseness or the Frechette distance as we used it. And maybe we could also use an indicator or a parameter like the Frechette distance for guiding the genetic algorithm, because in our case, it was basically completely unguided and we worked with the default settings.
Yeah, thank you. I have also another question from Alessio. Please, Alessio.
Yeah, unless there is someone else from the audience that also wishes to ask questions. Okay, yeah, I have a question about the validity of the roads. So you say that, and indeed it's true that validating the roads takes time. So generating roads that are valid, it's directly by design is a benefit because you can simply run more. What I was wondering is, you think there is a way to predict from the control point whether or not a road will be valid or not, instead of relying on expensive computations from the tool pipeline, whether this may be used to rank the individuals in terms of the likelihood of them being failing, actually being invalid, or things like that.
So if I understood it correctly, you think if there is a way to predict if the input will be valid or not. We were thinking about this, and it's probably a trade-off between complexity of the generated road and the chance that it's being invalid. So if you, for instance, say we put one control point very close to the previous one, then the turns will not be too sharp. But on the other hand, it will also be hard to find these curves that challenge the ATeSS system quickly, because it will take a lot of execution time, because you just move them in very, very slow steps and change only slightly change the road properties or the road geometry. So that's a thought that we had on this. But maybe there are other ways to predict it. It would be interesting for next year's competition if the topic remains like this.
Okay,
Yeah.
thanks.
We have another question from Dmytro.
Hello, thank you very much for presentation. My question is more a technical one. Are you planning to make your tool open source, or maybe because it is one of the advantages that this competition also provides baselines for other researchers, and like it would be interesting to be able to compare with your baseline too and run evaluations.
Yes. So we will do this. We plan to do this. We have not done it yet because we were still using these scripts, and we probably continue research in this direction. But once it's finished, it will be made open source.
Okay, great. Yeah, thank you.
Okay. Are there any other questions? I guess no. I have only one curiosity, and then I go to the next paper. Have you thought about using, instead of the Fraser distance, the edit distance that was already used inside the code pipeline?
Yeah, we should do this, because the Fraser distance turned out to be not a suitable indicator, to be honest, because only a local difference, a slight local difference, will give you a large Fraser distance, and the remaining curve can be exactly the same. So it's not a generalized measure of the complete curve, just of a small section of the curve.
Yeah, I agree. I also had similar hard times with Fraser distance when I was doing.
On the other hand, it's available and easy to implement.
Yes,
There's a Python library, so again, this is a trade-off.
Yeah, that's right. That's why we are proposing the code pipeline to help you to build on our shoulders, on our research.
No, should have done
because
that.
I had the very same problem when I was doing Deep Janus. So yeah, let me know if the performance improved. And we can go to the next paper that is presented by Mashi Delali Mogadam. She will present us the deeper tool.
So, hello everyone. Yeah, let me share my screen first, but apparently I cannot start sharing. Maybe the previous presenter should stop. Okay.
Yes.
Okay, great. Can you see my screen?
Yes, perfectly.
Okay, perfect. So, hello everyone. My name is Mashi Delali, researcher from RISE Research Institute of Sweden, and Mineral Industrial PhD candidate at Melbourne University. Today, on behalf of actually my colleagues, Marcus and Jalaluddin, I'm going to present shortly our tool called Deeper at SBST 2021 tool competition. Actually, Deeper is an evolutionary testing tool, which actually has got extended after the competition even, and currently, at the present, it consists of a couple of different test case generation techniques. However, the version of the Deeper that got participated at the tool competition involved mainly test case generation and evolutionary test case generation technique, mainly inspired by a state-of-the-art tool called Deep Janus. Let's see how the version of the Deeper, that version of the Deeper, rolled at the competition. Well, actually, we know that testing machine learning system is an emerging challenge in the scope of software testing, because we see a big shift of control from code to data in these systems. And maybe some of the traditional testing techniques might not be efficient any longer. And so in this regard, we know that deep learning systems and its associated techniques like deep neural networks are getting more and more attention in different application areas, for example, in autonomous driving and autonomous vehicles. Actually, then simulation-based testing is one of the well-suited approaches for testing or for performing system-level testing for machine learning systems, because it enables 3 E's for testing: early testing, effective, and efficient testing. Actually, it allows you to test whatever is ready whenever you need. And then actually the simulation-based testing let you execute and create critical scenarios in a simulation environment. And also it's more efficient compared to field testing, of course. Then let's get back to the actual competition. And so I'm going to go through these slides quickly because it has been covered by the previous presentations very well. The system to be tested in the competition was a lane-keeping assist system, a DNN-based system for predicting the steering angle based on the images captured by the camera in the simulation environment. The goal was generating critical test inputs, causing the software under the test to fail in a simulation-based testing environment. Test inputs were test routes to assess how well the system operates, and the test environment BMG simulator, and of course that we had predefined and fixed driving scenarios in the competition. And well, our tool actually in the competition was deeper an evolutionary testing tool. It involved an evolutionary algorithm mainly based on NSJ2 for generating critical test cases. It was actually based on a multi-objective search, as I mentioned, based on NSJ2, and then it was inspired by deep Janus. However, as I mentioned, actually this testing tool got extended. The research on the tool got continued after the competition, and then we also developed some tailor-made and then special crossover operations for the problem, and like we added different variants of GA algorithm to the tool, plus we also implemented a test case generation technique based on particle swarm optimization algorithm, and then we added to the tool. Anyway, I mean that these are some details related to the competition that actually have been covered properly by the previous presentations regarding the competition pipeline, and then the conditions for valid routes, and then the definition of the failures in the system and pipeline. So the test case generation technique in deeper was an archive-based NSJ2 inspired by deep Janus. The objectives in this test case generation technique was maximizing the distance of the car from the center of the lane while minimizing the roads of the roads lengths. And then we also used an initial quality population seed to boost the search process since we had a fixed test budget. Actually, we used this initial quality population seed instead of a set of random valid roads or seeds for the algorithm. Then the test case generation technique involved or were based on two main operations, like one operation was for repopulating. It was a repopulation operation. Actually, it used the simple greedy archive to store all the candidates that forced the car to get out of the lane with regard to a certain threshold. For example, we set it to 50%. And then it tried to replace a part of the population that had common seeds with the members of the archive. It was mainly to actually insert and inject new members to the population. And then on the other side, we had like a mutation operation for mutating actually the individuals in the population. And then this is like overall view of the simple test case generation actually technique that was involved in the deeper. Then actually in the competition, the target was to generate the highest number of diverse test cases leading to failures. And so we had some quality indicators, for example, number of detected failures, failure diversity, and test generation efficiency and effectiveness. So with regard to these quality indicators, actually, we saw that deeper, for example, could expose failures with an average rate of 2.6 and 0.5 in the runs on default and SBST setups. And then regarding the failure diversity, actually, to be honest, the test case generation techniques did not have any mechanism for promoting the diversity. So it showed low sparseness and low diversity on the generated test cases. Regarding the test generation efficiency and effectiveness, I mean that it's act quite well. It's like ranked second regarding the number of generated test cases. Meanwhile, it generated the highest number of valid test cases and then achieved around like 90% generation effectiveness in all setups. And meanwhile, it did neither generate any self-intersecting test roads or any roads outside the map boundaries. Actually have like good performance in terms of generating valid test cases. And so generally with regard to test generation efficiency and then effectiveness. Yeah, that was it. Thanks for the watching and listening.
Thank you. Thank you. That was brilliant. I really appreciated that you built on top of the channels, but also what I appreciated is that you fulfilled the goal of this competition to try out things in this competition and then come up with new ideas for your research. What was the main limitation you encountered with your first solution, then you addressed for your future work?
Actually, since I think that I missed a part of your voice, I mean that would you please just repeat the last part of your question?
I'm sorry.
Regarding the achievements? No problem.
Yeah, you encountered some limitation of your first solution, and then you decided to go on with your research and propose something new, some new change. Which was this limitation and how it drove you to propose something new?
Okay, great. Yeah, to be honest, I mean that one of the limitations or one of the weaknesses that we saw was the lack of diversity. Actually, we felt that we needed some sort of operations, maybe better operations to provide diversity. And that's why, like in the further steps of our research, we developed a couple of crossover operations, well-suited crossover operations for the problem. And then to be honest, I mean that when we developed those crossover operations and when we inserted those operations together with the mutation operation, like the mutation operation that we borrowed from the Jaeuk into an even simple GA algorithm, the performance actually changed drastically. And so we got much better that efficacy in terms of all the quality indicators. And then it was even more interesting when we used actually the PSO. Actually, I can say that we have not published the paper yet, but for example, the PSO could beat actually.
Okay, this is interesting. So
yeah.
I invite you next year to propose also your new version and to participate again to the challenge. Thank you. It was great.
You're welcome. Thanks for that organizing this great competition.
Thank you. And now we have the last tool presented by Dmytro. There is a SWOT now.
Yes, hello, I'll start now. Okay, I'll start sharing my screen. Okay, so somebody's still sharing the screen.
Yeah,
yeah, it's okay, fair. So thank you. So, hello to everybody again. I would like And now I would like now to present SWAT tool that we submitted to SBST 2021 competition. In previous presentations, we already saw what was the description of the test generation pipeline, and briefly the goal was to generate the rods that force the car to go out of bounds without generating invalid rods. There were three types of invalid rods: the one that goes out of bounds, the one that is too sharp, the one that is intersecting. And the rod was represented by a set of points, like 2D coordinates on a fixed map. And here I can make a link with my previous presentation where I was describing our approach to represent environment. And here we actually applied this approach to represent the virtual rods. And here is an example. So we defined like three so-called attributes of the virtual states. It was the type of the rod, length or turn radius, depending on the type. So if the type was straight, we added the length of this straight segment. If the type of the rod was the turn, we added the angle of the turn. And we had two types of turns, to the left, to the right. So the goal was to, again, to generate sequences of straight and segments that are turning right, segments that are turning left, in such a combination that force the rod to go out of the lane. And now I'll show a simple animation of how our approach works. So it starts by creating a backbone vector, like a base vector. In the original work, we started on the boundaries of the map, but in the way, actually, we also improved our tool in this time, and we actually found that it is more. It produces better results if we start from the center, as it allows for the rod to evolve in different directions. It may not allow to have a very long rods, but actually we don't want to have long rods as they take more time to execute. And the size of this vector actually corresponds to the lane width. So it's like a start of the lane. Then, for example, if we have a state go straight, say 10 meters, we'll just apply a fine transformation, which is a parallel transition. Then we can have a command turn left. Then we will make two. There are two possible directions in which we can go. It is either the one shown in red or the one shown in green, and we select the one which doesn't intersect with the previous polyline. And why there are only these two options? It is specific to how we implement the turn. We implement turns to the left as only anti-clockwise rotation. Well, there is an explanation for this, why there are only these two options, but there are only these two. We choose the green option, like the direction of the green direction, as it doesn't fall in the previous pass. Similarly, if the command is to turn right, we again do this oscillation test. We choose the direction and do the actual turn. And so that's how we proceed. And in the end, we just provide the yellow dots to the pipeline, and they are approximated by some polylines. So we use this approach to be able to apply in our test scenario representation. And as I said earlier, we improved our tool. We actually added evolutionary algorithm to search for the test cases that force the simplified car model to go out of the bounds. Actually, simulations to run simulations in the BMNG could take sometimes 1 minute or a bit less, a bit more, and therefore we had an intuition that using a simplified model can produce more test cases, and it can be effective too. So here is an example of how our surrogate model deviates from the road, and the real model in the green also goes out of bounds because we don't see the further execution. Here we see the same example. Here our model approximates the path of the real car good as well. But unfortunately, yes, there were some cases where our model was telling us that there should be a fault, but actually there was no failure. The car didn't go out of bounds. But to improve this, we should improve the quality of the model. Actually, another advantage of that is that it can. So we used actually two objectives. One is to maximize the difference between simulated between the road and the to maximize the deviation from the road lane center, and also we used the diversity operator that was calculated as a Jacquard distance between the set scenarios, and it was easy to calculate the Jacquard distance because of the representation. We just calculated the number of unique values to the number of values that are different in the two test cases. So we didn't need to calculate the threshed distance or other metrics based on the road shape. And then we converted this scenario to the 2D coordinates. So we have some new results. The swatted is the improved tool. Random swatted these are our older results. I'm showing the results for the 2-hour experiment. Random, it is the improved random generator, and the random search, it is random search based on our optimization function. So initially we submitted a random generator that just randomly generated the sequences without any optimization. But further we improved this random generator, and the improved version could reveal more faults, around 14 in 2 hours, and the sparsity was almost the same. Well, a little bit better. Actually, the ratio reduced slightly, but still it was quite good. So again, here the invalid test cases, we checked for them and gave a very low fitness value to the invalid test cases. So for the future, we would like to improve the accuracy of the surrogate model and also run experiments on the full model, because we have not yet we haven't yet run enough experiments to make conclusion that surrogate model actually allows to produce better, allows to produce more results. But we think this perspective to use simplified models. And finally, I have just a small idea for other tool competition. It can be generation of obstacle. It can be testing. It can be dedicated to testing autonomous robots, generating some mazes or some obstacles for them that will block them from reaching some goal. And I think it can also be implemented in BMNG. So yeah, that's all. Thank you very much for your attention.
Thank you, Dmytro. Also for you, that was the same thing. We are really happy that you didn't stop with this competition. You continued to develop your tools and your solutions. Do you think that your surrogate model you can develop a surrogate model that can be used to guide the search, like a fitness function?
Yes, that was actually what we were doing. We for example generated the road points which are in yellow. Then we took our surrogate model and executed it on this yellow points. It takes seconds to execute this surrogate model. It is fast, and then we calculate the deviation based on the surrogate model, and we use it as a fitness function instead of calculating the deviation from the road lane center based on the real model.
That's great. Well, if you have suggestions for simulators and use cases, please send them to us because we are trying to expand our horizons.
Okay. Yeah. Okay.
Now, if we do not have any other questions, I'll go back to Eric for the session closing.
Sounds good. Thank you very much. And thank you to all the tools authors and to the tools organizers. You all did an absolutely stellar job. So thank you very much. Great job, everybody.
Thank you.
Okay, so I'm going to stop your sharing and let's go into the closing, which has disappeared. I swear I do know how Zoom works. Okay, there we go. So we let the tools session run longer because your talks were all very interesting, I thought, and the discussion was really good. So we will skip the discussion session for today. We're basically going to go over what the promising areas for SBST to go towards are in both research and industry. So I think you guys probably all covered that as well in your discussion. So that's good. So just to wrap things up, I would like to, on behalf of Jiin, we would like to thank you all for joining. This was a very successful workshop, I thought. I think everybody did a wonderful job and it was absolutely delightful having you. We'd also like to thank the PC committees for both the research and the tools track, and the tools organizers for reviewing that. It's a lot of hard work and we definitely appreciate that. Our steering committee, as always, thank you very much for helping us with transition this online. It's obviously not easy for everybody. And just to give you all some metrics, we had 20 participants registered specifically for SBST. Obviously, people could pick and choose which workshops they wanted to as well. So watching our participant list, we had a peak of 39 people joining, so not too shabby. And we had 7 people attending via Twitch. A maximum of 7 real people. There were some bots that kind of kept coming in and out as bots do on Twitch, but overall, I'd say a pretty good turnout. So thank you all for joining and for participating. Anybody want to say anything else before we wrap it up for the day?
Just thanks for the great job, Eric, as usual, as last year. Thanks a lot.
Yep, of course. And I should mention too, so this was recorded in 2 different formats. I'm going to go through the videos afterwards and I'll put them up on the website at some point after. And we'll make some announcements in the coming days regarding SBST 2022. Plan is to keep going. We have a good structure in place for that. So we'll be making those announcements in the near future. But yeah, other than that, I'm not sure if you're still around or not, but thank you for co-organizing. This has been fun.
Thank you very much for doing
there you go.
actually most of the job actually. Thank you so much, and also thank Sebastian and the other tool competition chairs for organizing the very wonderful tool competition. Yeah.
Thanks, Vincenzo, Alessio, and Fiorella for this. It was a great venture.
So really looking forward to next year's event.
Absolutely.
And thanks for everyone for participating in the workshop and all your insights, comments, questions, talks, or very wonderful.
Okay, other than that, I'm going to end the stream. So I will see you all minimally at the next SBST, but hopefully at some point before then. So thanks, everybody. Have a wonderful day.
Thank you.
Ciao.
Bye.
Thank you. Bye-bye.
Thanks all.
Bye.